and welcome to Intellipaat. A SysOp is an administrator of a multi-user computer system, such as a bulletin board system or an online service virtual community. This phrase may also be used to refer to administrators of other internet-based network services like AWS. In this day and age, the demand for AWS SysOps professionals is never-ending. Dedicated training in this area can pave the way for a successful career for an individual. With that, let's take a look at the agenda. Firstly, we have the course prerequisites and experience, after which we will see the understanding system operations on AWS, after which we have tooling and automation, then we have computing of servers, again, computing of scaling and name resolution, again computing, that is serverless and containers. Then we have database services, which again is part of computing. Lastly, we have the basics of networking. Now, before we jump into the video, please make sure to subscribe to our YouTube channel and hit that bell icon for more updates.
This course is an intermediate program and is a assumption that you should have cover your basics of the AWS, and you should know how to do the basic administration, Linux or Windows. You should have a good understanding of on-premises virtualization technologies, network configuration, TCP/IP, DNS, firewall, disaster recovery and backup. Why I'm saying is a intermediate course because we are assuming that you know all these aspects. We are assuming that you are already managing your on-premises infrastructure. We are assuming that you are already doing your day-to-day work with respect to the infrastructure and you are moving to the AWS. That's a major impact here, or differentiation in terms of the why we are saying it is an intermediate program. So it is not for a fresher. So if you are already doing a networking on premises, you are creating a machine virtualization, database management, your monitoring, your backup, restore, exactly same thing you are going to do into the cloud. And when you're moving to the cloud, you're doing the same thing, then becomes easy. But in case you don't have, that's not a restriction, that's not a problem at all. And then the best way to ensure that you should learn everything, that you ask the question. Don't hesitate what your colleague thinks about, what other your teammates think about. No, you have only two options. Either get it clarified from your own self, do the learning, or ask the question. I'm happy to answer even you are asking the basic question. I don't have any problem at all, so no need to worry from that aspect. But the important point is you need to understand one simple thing, that you're doing this course so that you eventually move into the production environment where you can start managing your AWS services. And that will be only possible when you can be very interactive. You will ask the question, understood something. If you're not understood, ask me. Now, please remember, being an intermediate level program, I'm talking about some concept assuming that you know about it, because I told you that the intermediate, I'm assuming that you already have a good experience on premises. If you don't have, no worries. How that can be solved? Asking a question. Now, it is also possible that you are from the from the infrastructure point of view, you may have coming from the different verticals. You might be from the networking verticals, or Windows or Linux vertical. You may be from the monitoring team, backup team, database team, and you are not as of now involved in other streams, other vertical, which is perfectly fine on premises, but not in cloud. Cloud have a very simple expectation that when you move into the cloud, you know everything. When you're deploying your, let's take a simple example, when you're deploying your workload, means your application, you don't supposed to go and ask your network, hey, network team, can you solve this problem? Hey, security team, can you solve this problem? I'm not able to connect my machine. No, you should know everything. You have end-to-end knowledge. You have end-to-end experience. Might be possible in future, you just need to do a specific role, but that still does not mean that you should not concentrate on all the concept one. Otherwise, will be much more difficult into the cloud expectation. So, important point, which I'm reiterating, it's the intermediate course expectation that you should have a good knowledge of on-premises infrastructure. So, the best part is ask the question, be interactive. Even if you know something, very good. If you don't know, then it's still good. No problem. Ask the question and clarify. Now, what we are going to cover as part of this program, we are going to cover your how to deploy, manage, monitor your AWS services, which is mainly used from the network point of view, your server point of view, database, automation, container, high availability. We are going to talk about all these services which you are going to use on AWS. Exactly, the only difference is you're already using on premises, but how you can use an AWS one with respect to this course one. So very simple aspect. When you complete this course, you should have a good understanding how to manage your AWS services, use it, and do the day-to-day administration one. So just to update you, as part of the system operation, what all the things we are going to cover. We are going to talk about the basics of the cloud, basics of the administration, your tooling and automation, servers, uh, scaling and name resolution, serverless and containers, database services, networking. So this is what we talk about. Let's go to the first module. Allow me a minute. Okay, so from the module one, we are going to talk about the basics of the AWS, basics of the cloud, and understanding your system operation one. So we are going to talk about the various aspects from the system operation. Now, if you look from the system operation, what is the main role? What you're going to do from the system operation is like administration. Ultimately, you become administrator. And when you are become administrator, what you'll do? Your job is to start from building, testing, deploying, monitoring, maintaining, and secure your environment. Simple. This is a simple thing we are doing. Probably you are involved as of now in one of the pieces, but eventually, if you look holistically, the complete your solution or your computing solution include everything. Your job is start from building to day-to-day maintenance. So now you need to look from all these aspects. So when you move into the cloud, you need to look that, okay, you are now need to probably start your journey from the network, deploying your machine, monitoring, backup, securing. You need to look from everything from the system operation aspect. And when you're doing a system operation, one of the important thing as on date is you should know at least one of the scripting language. Good option, good for your career enhancement, good for any organization point of view. So if you're doing same thing again and again, if assume on a whole day you are creating 100 machines, what is the fun of creating 100 machines from the console? You should automate it. You should automate it. And to automate, you should have a good understanding of one of the scripting language. It's up to you. If you don't know, learn it. That can be a Python or JSON, whatever you wish, you can go for it, learn. But that's what I'm trying to say, that one of the scripting languages always enhance your career and then help you to do much more from the management point of view. But eventually, you need to manage, deploy your resources in your AWS via console and via a CLI one, whatever. Now, when we're starting your journey into the AWS, my always suggestion that don't switch directly to the script or CLI. You can create a resources via the CLI from the script, but don't switch directly. Take some time to understand all the concept from the console. And when you have a good understanding that how you're managing your resources from the console, then you can go and switch to the scripting and CLI. If you directly switch to the CLI and start from the day one creating a resource from the CLI, you eventually do not have any knowledge what is happening onto the console, and much more difficult in your long career. So humble request, always ensure that you should have a good understanding from the console and then move into the CLI. But ultimately, you need to use the one of the scripting language later on, so that you can help your organization to reduce your overall cycle in terms of the resource deployment one with respect to the AWS. Now, quick one, before we go to the deep dive into the AWS, let's have a basic understanding of the cloud itself. Now, if I ask you, what is a cloud? Or assume you are a part of the team and you need to explain some layman, any layman, that what is a cloud? How you can explain in a simple word what is a cloud? We are all learning here, going into the cloud, but what is a cloud? What are the basics of it? What do you mean by the cloud here? Yep, anyone? You're right. Any service, fine. Let's go deeper into what do you mean by the service here. In simple word, what we are trying to say in a general layman language, the cloud means you are accessing over the internet. A simple word. Over the internet does not mean on internet. You can have any connectivity, but let's understand from this aspect. So what you're saying, cloud is you're accessing over the internet, and what you're accessing, you may be accessing your server, you are accessing your storage, you are accessing your tools. So you are accessing your tools, you are accessing your software, whatever. But important things you are accessing over the internet. Fine, all good. But is this something new? Are we doing something new now? When I'm saying the word, you're accessing over the net, is there something new? No. If you look almost 10 years back or 20 years back, lots of services are already available over the internet. 20 years back, there was a Hotmail. 20 years back, there was Orkut. So it is not something a new concept. This concept is exists since last many years. Now, another question comes, then what happened suddenly that everyone start talking about the cloud? Why? What happened? If you see in the last few years, or eventually I say that in last 2 years since the COVID-19 break, the cloud takes, cloud is actually going very fast in terms of the deployment. But if I go back the basic question, what happened suddenly that everyone start talking about the cloud? Now, if you look from the cloud aspect, the company who's providing these services that we call a cloud service provider, they started providing the service as a utility service. Now, what do you mean by the utility? This is exactly the way you're paying your electricity bill or your water bill. Means, if assume you go for month 1 and you consume 100 unit of electricity, pay for it. Month 2, you consume 50 unit of electricity, pay for it. Month 3, you got lots of guests, you consume 500 unit of electricity, you pay for it. So what happened, this service provider started offering their service as a utility service. In terms of the utility means, whatever you consume, you pay. No upfront payment, no minimum commitment, no need to worry about anything. If you consume, pay for it. If you don't consume, don't pay for it. Now, the minute I use the word utility service, and the minute I say the concept that it will lead to the concept as a pay-as-you-go model, that what change the entire your framework in terms of the utilization of the services in our organization. Now, as an organization, they will see much more benefit the minute they move into the cloud, considering pay-as-you-go model. Now, let's take a simple example where you can use this pay-as-you-go model. Now, if I ask you, if you look around your organization, which service you think will be best case for pay-as-you-go model? Which service you think will be actually good for pay-as-you-go model? Considering my definition that is like a utility service, whatever you consume, you can pay, and no minimum commitment, nothing more than that. So just use and pay and exit. Pay, use, exit. If you look around in your organization, do you think which area will be eventually beneficial to start with? Storage, mailing services, virtual machine. In simple word, let's take another example. So let's assume you need to deploy one web server. Let's say that you need to deploy one web server. Your manager asks you to deploy the web server. This web server you need to deploy for 3 months. Okay. So as the organization, they don't have any hardware or virtual machine available as of now. So all are completely occupied. So what you need to do? You need to eventually go buy the hardware, deploy. You can create a virtual machine, or you can directly deploy the web server onto the hardware, whatever. And after 3 months, you can exit, because you need to deploy only 3 months. And fine, all good. You are happy. Customer is happy. Management is happy. But the few question remains. And that question is, what we should do with this hardware? What is my ROI, return of investment? I already invest too much money to buying the hardware. What I can do? Either I should wait for another project to come, or I may utilize in somewhere, but before that, I'm not going to do anything. Number one. Number two, because the day your management asks you to deploy the web server, you need to raise a PO. It will take 4 to 6 weeks time to deliver the hardware. You take another week to rack and stack on your data center, then another few days to deploy your application. Probably 4 to 8 week times you took just to deploy your application. No, I don't want to. This is the some issues which is there. So time, return of the investment, this is the question. Now, if you move into the cloud and you look for the pay-as-you-go model, this problem can be solved immediately. I may deploy my server in 10 minutes, literally in 10 minutes. Probably in hour, my application will be ready. I may create a server for 3 months. And after that, I can exit. No need to worry about the ROI, return of the investment. Good option. Now you have to look from the aspect that which all services I can move into the cloud where which is does not need always on my running always, or just which have a shorter need. Another option, POC. As the admin guys, you are doing lots of POC. Your company want to buy some software. Before that, they want to do the POC. And to do the POC, you need to buy the hardware. No. Go to the cloud, create a machine, do the POC, exit. Assume that a new product launch and you want to learn the new product. Let's assume the Windows 2021 is launched. I'm just giving example. You want to, before you need to deploy, you want to learn. Okay, fine. Why don't you create a machine in the cloud and deploy the 2021 and learn, and then you can when have a good understanding, then move into the your then upgrade. So if you look from the pay-as-you-go model aspect, it will open a whole new world which you can use to deploy your resources, where you don't need to worry about your long-term, where you don't need to worry about buying a product. Go, get it, learn it, deploy it, exit. That what is the basic aspect from your cloud one. So if someone asks you, hey, which all service, tell me which service I think we should go for a cloud. You said that immediately we can go, which is a immediate, which is a shorter need to start with. I'm not saying for longer one, not for the longer one. I'm saying to start with. So people can say, oh yes, now let's start learning the AWS services for at least for the services which is shorter need. When you learn, you can then go for a longer services which you want to host for a longer period. Ultimately, it is a step-by-step journey. So from the cloud computing aspect, that's what we talk about it. Now the next question comes, when you move into the cloud, how you can control your application. Control your application. From the controlling aspect, we have a 3 concept that's known as a cloud computing models, known as infrastructure as a service, PaaS as a service, SaaS as a service. IS, PaaS, and SaaS. Now, from IS, PaaS, and SaaS, anyone, what is the basic difference between IS, PaaS, and SaaS? Anyone? So let's try to understand it from the taking one of the example. So let's look into this way. So your manager asks you to deploy the web server again. So your manager asks you to deploy the web server. Now web means web plus database. Okay, fine. So assume that you have a data center. You already have your data center. In the data center, you have a storage, network, security, physical or virtual server, whatever, but you have a server that can be physical or virtual. Now, because you have a data center, your organization is responsible for 24/7 support, maintaining the hardware, replacing the hardware, managing the electricity need for the data center, cooling, security, monitoring team. You have a lots of things. Okay, fine, all good. So if you deploy the hardware, sorry, a web server, so you go to your data center, get your server. Then first thing you need to do to deploy or install your operating system. Yeah, right. Then on the top of it, you can configure install your runtime environment. Runtime environment, considering what kind of the language application you are deploying, like a Java, Python, C# or .NET. You are deploying the code accordingly, and you need to configure the runtime environment. Then you may need to deploy the database. And then you can deploy your application or code. And finally, this application or code will be accessed by your user. So if you look from the top point on your 20,000 feet, this is something like your task or step you need to perform for deploying an application, right? Anyone, I'm not going to the too much details like monitoring backup, but do you think this is fine? Is it, do we miss anything? So you have a server, operating system, database, runtime, or then application and code deployment, and you can access by the user, correct? Correct. Yeah. Now, if you look from this one, this is perfectly fine. Now your management decide, one day management decide, boss, I'm thinking that we are spending too much money and we have too many resources who's managing my entire IT support. Now they also decided that they don't want to maintain the data center. Okay, fine. So they thought that why don't we sell this particular aspect to someone or outsource this to someone else? So they talk to the company and they say, oh, why don't you manage everything up to this line? Now you own the data center, you own the hardware, you own everything. And whenever I need a machine, I call you. And whenever I call you, they say, okay, give me a 2 processor, 2 GB RAM. You can create a machine and hand over to them. Them means us as an organization, and I'll pay for you. He said, fine, all good. So let's go for do that. And you saying that, boss, please also remember that anything starting from operating system and above, I'll take care of it. Anything below operating system and below the operating system, you need to take care of it. Means if hardware fails, you need to take care of it. Replacing the hardware, you take it. Maintaining the data center security, electricity, cooling, you need to take care of it. Even virtualization is also taken care by you. You need to also manage your physical server, your virtualizations, hypervisor, which include like VMware, your Hyper-V, everything. You need to manage it. I don't care about it. You need to do everything. You just give me the virtual machine and I can deploy my operating system and above. The rest is your responsibility. If there's a problem in operating system, I'll take care of. If there's a database installation, database management, application installation, application management, monitoring, backup, everything, I'll take care of it. Fine. This concept is called infrastructure as a service. In infrastructure as a service, you have managing everything starting from operating system and above. Now, same organization decided after a few months that, hey, I think we are still spending too much money in managing my operating system, database, or runtime. I just want a developer. I don't want to have any other resources in my organization. I just want a developer. Oh, okay, fine. So they call the same company. Hey, why don't you do all the additional tasks? You are already managing the data center. Why don't you do some additional tasks like installation of the operating system, maintaining the operating system, installation of the database, maintaining the database and everything? He said, fine, I'll charge you extra amount. I'm saying, okay, I'm good to pay you. So now you say that, okay, let's manage everything up to this line. And my developer, whenever they need to deploy the code, they will call you and say, give me a machine with a Java runtime environment, give me a MySQL server, give me a processor with the Windows or Linux one, 2 processors, 4 GB. Just communicate to them. They will do everything for you and hand over to you. Your job is to just develop the code, deploy the code, and maintain the code. Rest will be taken care by them. This concept we call a platform as a service. You also going to heard some terms known as managed service. You also going to heard some term related to the serverless compute, but eventually all falls under the PaaS category. In a PaaS, you just need to concentrate on developing, deploying, and managing your code. Okay, fine. Again, same organization, after some time, they say, no, I don't want to even a developers also. I just need 2 employees who can just manage my IT need. I don't need anything else. Okay, fine. Now, you are not even developing a code and deploying the code. Rather, you are using the code which is already developed and deployed by someone else. You are just using as a subscriber. So you are using as a subscriber. Like you're using your Gmail. You're just creating your account and you're not doing anything else. You don't need to worry about what happen if the software, some bug into the software or application is not running or working or hardware fails. You don't need to worry about anything. Assume the Gmail is a paid services. You're just paying for per user. So you're subscribing for 100 user or 1000 users, whatever. You're paying for it. You don't need to consider on anything else. This concept is called your software as a service. Some other example of the software as a service like O365, Salesforce, and few more, Microsoft Dynamics. So from the deployment point of view, you have three aspects: IaaS, PaaS, and SaaS. Now remember, when you move into the cloud, you can choose either of it. IaaS responsibility start from operating system and above. PaaS responsibility only related to the application. SaaS, you don't have any responsibility and everything is taken care by the service provider. From the cloud aspect, we mainly concentrate on IaaS services and PaaS services only. And this is what we are going to manage, control, and deploy from the IaaS and PaaS. Please remember, below the operating system, you don't have any access. You cannot have any control. You can only depend to the service provider in case you have some requirement one. Right? And this is what we talk about IaaS, PaaS, and SaaS. Correct? Anyone have a question? Please go ahead. Clear? Okay. So from the IaaS, PaaS, and SaaS, that's what we talk about it. Now the next terms comes with respect to the deployment model is your public, private, and hybrid. Public, private, and hybrid. Okay. So, okay. Anyone? What is the difference between public, private, and hybrid? Anyone? So in terms of the public, which is the public services, public cloud is offered to the general public. General means anyone. Anyone can, you, me, anyone. No limitation. And our public cloud are AWS, Azure, Google, all are public cloud. Number two, it is offered you as a rental service. Remember, it is always offered you as a rental service. Private, only used by the organization, or it is used by you, your partner, your associate, whomever you want, and it is owned by you. The difference is owned by you. So if you look the comparison between Ola, Uber, and your own car, if your own car, you should decide who can use it. You need to buy the car. Whether you're using it or not using it, you still pay for it. You're maintaining it. It is up to you. But you move to the cloud, remember you're using as a rental service. And when you're using a rental service, it is up to you what you want. So assume you initially want a hatchback car, small car. Later on, you decided that I want to go to sedan, big car. Later on, you want to move into the SUV. It is up to you. Whatever you want, you can pay for it, but no limitation. And that's why I say rental services. You're using as a rental one. Third, you're using as a shared environment. Shared means, if assume there's a physical server, and this physical server, you are running a 4 virtual machines, then this may be used by the IBM, this by you, your company, this by the, let's say, Capgemini, this will be used by the Accenture and so on. Shared environment. When you have private, all will be used by you, your organization, no one else. All are used by your organization. So shared and dedicated. So the major difference between public and private is general, rental, shared, used by you, own, or dedicated one. Whenever we use the word hybrid, hybrid means when you're using the mix of it. You are using the mix of it. Like my web server into the cloud, but database server into the private cloud. Or my primary data center into the on-premises private one, or disaster DR is in cloud. You can use mix of it. Remember, hybrid we also use when you have using your on-premises data center and integrating with the cloud also. We also call a hybrid. Mix of it. Nowadays, we have moved into the color there where we call a multi-cloud platform. We already move ahead where we have a multi-cloud platform. My web server running on AWS, database running on Azure, and so on. So now we are using a multi-cloud platform. So instead of putting all the resources in one cloud platform, we put into the two different one just from the management point of view, or or you're considering that what happened if one of the company get failed, whatever, you have all the option, right? So this is what we talk about public, private, and hybrid one, right? Anyone have a question? So you, actually it's a hybrid, but we also call a multi-cloud. See, hybrid means more than one. So if you have a public, two different public, multiple private, yeah, we call a hybrid one usually, but actually it is a multi-cloud, but usually people also call a hybrid, which is not a problem at all. So from the public, private, and hybrid, this is what we discuss with respect to difference one. Yeah, anyone have a question? Please go ahead. Clear? So tell me one thing. If you have your data center, on premises, you have a data center, and you integrate your data center with the public cloud, AWS, so that your servers, so this is your on-premises data center, this is your AWS, you can connect your data center to the AWS.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
This is also called a hybrid one, and you are in the course. We are going to use hybrid means you are connecting with your on-premises data center also. So remember it. Okay. So this is what we talk about. Now the next thing we are going to talk about the basics of the AWS. Now with respect to the AWS have spread all their data center across the globe. AWS have presence across the globe. They have almost 24 locations where they have a presence. 24 locations. These locations we call a region, or we call a city also. City, you can say the city also. So they have their presence across the globe, and they have their data center. So eventually they have almost 24 plus region, or as of now 24 region where they have a presence. So assume this is Mumbai, this may be London, this may be Paris, this may be Singapore, this may be your Ohio, whatever. So they have their data center which is presence all across the globe, and they place in such a way that they would cater all the global need. So they have their data center. The data center, we have their presence where data center where they are you're creating a resource. When you're creating a machine, storage, database, eventually it will be created onto one of the data center. This data center is available in one of the region. That region is nothing but a city. So city Mumbai is a city, is we call a region, like West India, East India, West Europe, East Europe, West Europe, US, East US, whatever. It's a region name. But eventually it is a city. So they have almost 24 plus region where they have a presence. And with respect to the India, they have presence in Mumbai. But let me tell you, they are also coming a new region into the India, which is in Hyderabad in next year, second half. So India, they are also coming with a new region. So if you are working for the India business and you look for the region, this is what is overall about it. Now, with respect to the region, if you have why they have a 24 regions? What is the purpose behind it? Why you think they should have a 24 regions? Why one region is not good enough for them? Let's take another way. So your business is located in some, let's say X region. This is your business. Okay, so you have a business which is in an X location. Okay, where is your current office? Which location you have your main office? Now let's take that example. And you have a 24 region. On what basis you should select the region? Absolutely right, nearest location. But why? What is the actual benefit of it? Latency is very important aspect. Why? Because the entire solution it depends on the latency. If the latency is low, your performance will be high. If latency will be high, performance will be low. That's why we always look for the region which is nearest to them. Nearest to them. Okay, fine. So they have 24 plus regions, considering that you can select the region which is nearest to your business so that you get a low latency, high performance on. Okay, very good. Now in every region, they have at least 2 or more data centers. So what they did, so every region, they have a 2 or more data centers. So now you know that why they have a region and what basis you should select the region. Number 2, every region, they have at least 2 or more data center. They are independent, not sharing any hardware. Maybe this data center in west of the, let's say, Mumbai, this may be in south of the Mumbai or south of the city or west of the city, distance apart. Same city, but distance apart. So you have a 2 data center. These data center we call availability zone. Availability zone 1, availability zone 2. Okay. Now, what do you think you get a benefit by these 2 availability zones? But high availability you can also get if you deploy your application into the 2 different regions. But fault tolerance still you get across the 2 different regions. You can deploy across the region. You get high availability, scalability, perform your invest some money, which is fine. But still, one important point you are missing. Think. But I'm still saying this is region 1, this is region 2, and your presence is in X location. So you selected your region which is nearest to you. Probably this region will give you, let's say, 10 millisecond. So for high availability, you select the second region, which is the region 2, and probably they give you 100 millisecond latency. Fine.
It will be
so you build the disaster DR across the region. One is low latency, one is high latency. Fine. And you know that when your primary goes down, user will face some latency issue. Now look from that angle. What is the benefit if you get 2 data centers in the same region? Yeah. In simple word, one of the main aspect is you get the almost same latency with a high availability. That is the major purpose. So it means if this region give you 10 millisecond latency, this is also give you 10 millisecond latency, you get both. So if you deploy the 2 web server here, and if your primary data center goes down, user can still access with the high availability, but with the low latency. Performance will not going to impact. But in this case, if your primary goes down, your performance will be impact. That's why you want that. Why don't I deploy the 2 web server in the same region, but across the 2 different data center, which is distance apart? Usually all the data center does not goes at a time unless there is a natural calamity, flood. If that is, if assume that entire city goes down, and then of course there's no other option, but you should access your service from the second region and everyone accept it. Boss, when entire region goes down, why don't there's no other option that user may face some latency issues, but which is acceptable. But to avoid this latency, they have all these options. What? So you can have a availability zone. So you get high availability as well as low latency as well as high performance. And that's the reason always look for the solution that you deploy your services across the zone to maintain the availability in the same region. Nowadays, AWS already changing their region from 2 to 3. So they are actually building a 3 zones in every region. So they are actually moving into that direction. That's why you can see in this picture, wherever the numbers, it will show you how much zones you have. You may also see one of the region known as Osaka, which have 1 zone. Osaka have a local zone. It is not connected with any of the region. Now, please remember, AWS have their backbone link. This backbone link is connected to all the regions, all the availability zone. So all the traffic within the AWS will be flow via the AWS backbone link. So they have own private link, traffic flow. And if you enable the replication happen across the AWS backbone link or whatever you look from it. Osaka is the region which is independent, isolated. In case I want to deploy the services which should not be accessible from any other region, Then we go for Osaka. That's why you're seeing the number 1. But rest of it, you are seeing that you have a region which is showing you 3 numbers or 4 numbers or 5 or 6, whatever. The maximum is 6, which is the North Virginia region. North Virginia region, we also call a default region. Rest of the region, we have number 3. In India, also, they have moved from 2 to 3. I think recently, if you check in Mumbai, also, you have a 3 regions, 3 zones. And some are upcoming one, if you see in this slide. So from the region point of view, they have almost 24 plus region across the globe. And every region, they have at least 2 or more zones. The purpose of the zone to provide you high availability and low latency. Like you can deploy the 2 web servers, 2 database servers, or your 2 application, whatever you can do for it. So from the region aspect, availability zone, that's what we talk about. Clear? Anyone have a question? Clear? Anyone have a question? Let's say that your application is too much critical. You say that at a region level, if my zone 1 goes down, so you know the concept of the n+1. Always there's a high availability concept. We always looking for 3. So usually companies go for 2+1. These are normal disaster recovery scenarios, n+1. So whatever we try to add. From that aspect, they put the 3 servers, 3 zones, so that if there's one goes down, it means you are now becomes a single point of the failure because single zone is running. So from that point of view, they're trying to upgrade to the 3. But that is one aspect. But actually region is actually what happened on the backend scenario. When Azure came later on, Azure started their journey later on. Everyone knows that Azure actually started their cloud services later on. What they did, they started upgrading every region. So initially they have 1, but they started upgrading to the 3. So they started saying, because AWS offering 2. So Azure says, let me offer 3. When Azure started 3, AWS say, I'm also offering the 3. So there's a business reason, but there's another reason, which is n+1. So the people eventually get that high availability at any point of time. You may get 2. So, but still, you may say that what happened if the 2 zone goes down? You may get 1. It will never be end. But from the N1 concept, which is always a good option, because if you are looking for high availability, usually people go for 3. So 1 goes down, at least 2, so that they get sufficient time to bring the first one and avoid then a single point of failure. That is one of the reason behind it. But there's a reason which is the technical, but there's another reason which is a business point of view. So the people who start migrating to the Azure because of the 3 zones, they want to bring back to them again by offering the 3 zones. So business reason and the technical reason. Let's look into this way. So if assume that I'm saying a data center does not mean a single data center. They have a bunch of the data centers. So assume there's a one building. In the building, they have built one data center onto the ground floor. Usually every data center, they keep approx 30,000 physical server just from the performance aspect. Usually they keep 30,000 physical server in one data center. If they reach to the limit, add one more. They add one more. They add one more. They add one more. Or they may have also a campus. In the campus, they have multiple buildings to add more resources one. So they already have a future aspect, and they ensure that the resources get added, bandwidth can added. When you're deploying it, you always get the same performance. So as of now, we are not seeing an issue. In future, might be, we don't know what will happen. But let me give you one scenario. Are you expecting that everyone moving to the cloud or data center is everyone moving away from data center? But that's not true. The way people are moving to the cloud and increasing the business onto the cloud, people are still adding their own data. Performance point of view, I'm not seeing much issues with respect to the future one. But this is what is currently we have, right? So from the AWS point of view, hoping things will be smooth in a future also, right? So okay, so this is what with respect to your services aspect. Now if you look, now the question is how you can select the region. First, we just talk about it based on the proximity, latency, fine. The other one is based on your data governance and legal requirement. What does it mean? It means, assume if you're deploying your services in one of the country, which says that please ensure the data should remain into the same country. It not should go beyond the country. Assume you have that expectation that data should remain into the country. Then in that case, you should ensure that data should not go beyond the country boundary. Let's assume that someone said that data should remain to the India. You said, fine, data will remain into the India. But your in that case, you need to select the region which is in India 1. Data should be in India. So when you're selecting the region, select the region based on the your compliance need or governance need. Like if you know that European Commission says that with respect to the data into the Europe 1, that data should remain into the European boundary, should not go beyond it. In that case, you need to ensure that your data will remain into the European region. And if you remain into the European region, then you should select the region which is into the Europe 1, or probably like India, remain into the India 1. So when you're selecting the region can be selected based on the country, your compliance need, legal need. There is also a possibility that when you're selecting the region can be based on your based on the services. It is possible that some services may not be available in all the region. Let's assume that whenever AWS started a journey, they deploy their services in one of the start region. They deploy into one or two region, and later on they add at the additional resource region 1. So of course, this is not possible that they can introduce the services in all the region. So probably they start with 2, but gradually they add more and more, or they start new feature. It is possible they start in 2 region, later on they add more and more. So if you're looking for some service or some region, some feature, it is possible that they will be only available into the specific region, or specific from the feature point of view, service point of view, and you have to select the region based on that, and from the service availability 1. You can also select the region based on the cost. Same service, same server may cost differently from the region to region. You're deploying a 2 server with 2 GB RAM with a 2 processor. In region 1 may cost you $1, maybe region 2 cost you $1.2, region 3 may cost you $0.8, possible. Pricing, services, compliance or legal requirement, and proximity is the reason using which you can select one of the region 1. Got it? Clear? Any question? Got your question answer? Okay, so the next thing is edge location. Now, anyone, before we talk about the edge location, have you heard about the CDN? Anyone, what is CDN? Heard about the Akamai, Cloudflare? Anyone heard about it? So CDN is basically used mainly, but this is only, I'm saying CDN purpose is web caching. Look into this way. So now assume your users are spread across the globe. See, you selected the region because which is near to the user. But if your user is spread across the globe, then what we can do? Then we come with a concept known as CDN services. So assume this is a web server. The user who's near to this web server will always get a low latency. But what about the user who's far away? They may get have a high latency, performance will be bad. To help those customers, they come up with the concept that is not CDN. Remember, CDN means they have almost in 200 plus major cities. This is additional to the region. They have a 200 plus cities where they have their presence. But this presence, we call them edge location. Edge location, point of presence, whatever. The purpose is to reduce the latency. Let's assume you have web server, but this server is static. Remember, I'm using the word static. Static means which is read only. The pages is changing oftenly, not always. If you have a such server, then what we can do, we can cache your data into this edge location. Now, user does not need to go all together to the server to bring the data. User will access the data from the nearest edge location, which reduce the latency and increase the performance. So edge locations are provide you some additional feature. One of it is web caching 1. But apart of it, they provide some additional feature like when you enabling your DDoS attack. For DDoS attack, you can also enable the DDoS attack from the web caching, caching location or edge location. When you do the name resolution, DNS name resolution, the name resolution will always happen from the AWS services aspect, will happen from the edge location and few more. But this is an additional aspect for providing you the feature. And please remember, all the edge location, all the region are connected with AWS using the AWS backbone services. Traffic remain within the network between edge location and region one, private and secure. You don't need to worry about it. But there's an additional aspect with respect to your application deployment one. So edge location is another aspect, how you can reduce your latency to improve your overall performance one. So from the core services or for infrastructure aspect, we talk about your region, zones, edge location, and when deploying your services, you can select your region which is near to your business, deploy your services, and deploy across the zone for high availability, across the region for high availability. Is up to you, whatever you can do with respect to the AWS services aspect, right? Anyone have a question? Please go ahead. Edge location, you cannot manage it. You cannot deploy any resources. It is mainly used for the one is for caching purpose, other for the name resolution services and other blocking your DDoS attack. But you cannot deploy or create any network, your machine, your database in an edge location. No. Okay.
Yep.
So from the AWS point of services, please remember they have some core services. Core services are include network, compute, storage, database, access management, and few more. We'll talk about detail, but you have they're offering the various services like VPC, which is a virtual private network, EC2, which is a virtual machine, your IAM for directory services. They have various aspect from the services. We'll talk in detail later on, but they have a services from network, compute, and access one. Now, from the AWS services point of view, please remember the services have their scope. Scope means what is the scope of the services? Few services are offered from the global service. Global service means you don't need to select the region. It is offering across the globe. You don't need to select the region. Like your users, when you're creating a user can manage all the resources across the region. When you're creating a DNS services support all the regions. CloudFront support all the regions. CloudFront is your CDN service. Route 53 is your DNS services. CloudFront is your CDN service. CDN and that DNS service. Some services are region. Or let's look into this way, reverse of it. Services are a zonal one. When you're creating a service, you need to select the respective region and then zone. Their boundaries, respective zone. If zone goes down, services goes down. EC2 machine. If you're deploying the EC2 machine into the one of the zone, if zone goes down, application down. That's why you deploy the 2 server across the zone, or 2 database server across the zone, 2 disk across the zone for high availability purpose. So services are zonal. Some services are regional. You don't need to select the zone. It is part of the region. But if region goes down, services will be down. Like your S3 services, your VPC network, or some your caching services. There's regional services. You don't select the zone, but if region goes down, services goes down. Some services are global. You don't select the region. And if one region goes down, still you can access it across from the different one, because it's a global service. I told DNS services are running across the globe, users supporting across the globe, and so on. From the services aspect, you have a regional, global, and availability zone, and then you can use it. Now, please also remember, with respect to the AWS, when you start the journey in AWS puts some soft limit. Why? So that you cannot do any mistake when you start your journey. Probably the day one you created a account, you created 100 machine, then you get the bill for 100 machine. You do the mistake. How you can avoid to do the mistake? If I keep the limit, I say that you cannot create more than 2 machine. Okay, fine. If I want to create more than 2 machines, raise the request and AWS will increase the limit. So by default, they put the soft limit, which you can change, but you cannot go beyond a hard limit. So hard limit that you cannot create more than 10,000 machine. Okay, fine. That become hard limit. But I start with 2. I can add a request to keep it to 2 to 20, 2 to 40, 100, and so on. That's called a soft limit and hard limit. And eventually you can go for it, right? So Remember, if you're seeing that you cannot go beyond a limit, raise a request, add more resources, and then you can do for it. Now let's take one example, one scenario, and as a administrator, how you can solve it. This scenario one. So assume you're a startup company, you are just you are part of the administration. That company needs to deploy the application which is mainly used for the video transcoding. Fine. So you are looking for highly available, scalable, secure services. You want to analyze their web logs, monitoring their services, backup, and everything you want to maintain. Okay, fine. So what are the things you need to deploy? You want to deploy the web server, database, auto scaling, load balancing, monitoring and logs. Auto scaling means scalability. If you don't understood some concept, no need to worry, it will be clear later on. It is just from the high available point of view. And load balancing one, which distribute your load. So we start our journey to create a network. Now, please remember, if you are not from the network background, I'm still saying networking is very essential. In a cloud, if you don't do networking, you will face much more issues. Networking is the first step. When you start the journey, networking is the first step. You have to first create the network. So here you see that we create a network across the two different zones for high availability one, and we can enable the replication so that zone one goes down, I can access from the second zone. So we create a VPC, and we have a subnet where we deploy the web and app. What is subnet? I'll talk about later, but it is a network layer. Just consider this a layer. And I want to access I say that public subnet where I can access the internet, private subnet which cannot be accessed the internet from the security point of view. So I can deploy my database in private subnet, web server in public subnet. Database server should not access over the internet from that point of view. So create a network, deploy your web server into the public subnet so that it can access over the internet. Deploy your database into the private subnet so that it should not be accessed over the internet, and your web and DB can communicate to each other. Same configuration you can put into the another zone for high availability purpose. So two different zone, you can put your web and DB for high availability purpose, right? Of course, for high availability. So you're joining an organization as an administrator and they want to deploy the web server or application for high availability one. You can achieve the high availability by deploying a servers into the two different zone, web and DB one. Then you want to access over the internet. You want to create a DNS services, which is a route 53. So you create a route 53, which is the DNS service. You can put the load balancer, which will distribute the load across the zones. User will access the load balancer. Load balancer will distribute the traffic across the zones for high availability purpose one. From monitoring aspect, monitoring and scaling aspect, you can put into the auto scaling group. Why? So that when load increase, it will add the instance. You don't need to do anything manually one. Load add, load increase, add the instance. Load decrease, reduce the instance. Scalability. To manage your load, you can put the auto scaling. For analyzing the data, you can use the CloudWatch. CloudWatch is a monitoring service which you can use to monitoring your data, CPU utilization, disk utilization, logs. You can also integrate with the scaling service so that whenever load increase, add instance. Whenever the load decrease, reduce the instance. And you can keep your logs into the bucket. You can also use the CloudTrail. CloudTrail is basically used to check your API calls. Glacier, which is used for storing your log files for a longer period. You can use the RDS and so on. See, don't get confused. Don't need to worry about it. I'm just talking from high available point of view. What are the different services one should use for the complete management aspect? And ultimately we're talking about each services one. And you can store your logs, monitor your logs, manage your logs. You can also take a backup and restore. You can take a backup of your database. You can take a backup of your virtual machine. You can deploy your resources via the script, deploy your resources into your virtual machine, take a backup. If machine goes down, restore it. So take a backup, restore it. If something goes bad, you can eventually do that. Good option. You can also integrate with the on-premises services. You have a AWS, you have on-premises, you can integrate your on-premises with AWS, and you can use AWS services like a virtual private gateway or your direct connect, to connect your on-premises network to the AWS, or two different network in AWS. You can also connect with the peering one. You can also deploy your resources by automation. You can use the script known as cloud formation, using which you can deploy all the resources to avoid the manual errors or mistake one. Now, this is what we talk about from the services point of view. Ultimately, all these services which we have discussed, we are going to discuss in one by one and talk about your load balancer scaling. But this is what from the high level aspect. So assume if you're working for a project, then you need to deploy the services. Usually the design comes from the architect. And based on the design, you need to start and deploying your services. You need to deploy your network, deploy your web and DB servers, deploy the web and DB across the zone for high availability purpose, deploy your Route 53 name resolution, load balancer for high availability. You can put the scalability so that load increase add instance, manage your monitoring, your CPU, disk, network utilization, take a backup and restore the backup, integrate with your on-premises so that user can access it. This is what, and also the automation, you can use the cloud formation template to automate your environment. This is what we talk about so far from the AWS services point of view, and this is what is the job of the cloud administrator, that what you can do it. From the IAM one, the IAM is your
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
used for authentication and authorization. Used for authentication and authorization. Exactly the way you are using your on-premises directory service, same way. We use IAM for authentication and authorization. So with respect to the IAM, basic concept is to authenticate and authorize. So when you create your AWS account, then you want that your employees or your administrator can manage your account or manage your resources. Of course, that is what needed. So assume with respect to your organization, you are going to manage your organization AWS resources, but before you manage the AWS resources, you need to log in and perform the task. So the first step is to create your user. So they should have a directory services. AWS should have a directory service where you can create your username and password, user and password, and user and password, so on. So eventually, for your user can log in your account. So main purpose is to log in your account. When they log in, then only can they do any task. And this login is nothing but your authentication. So they should authenticate. And when someone authenticate, then they can perform the task. So first thing, you should create your username and password in your AWS directory service so that user can authenticate. And after that, you should allow who can do what. So assume as the organization, you want that user one can only manage your virtual machine. User two can manage a virtual network. User three can manage a database. I want a restrictive access. So once they log in, I can assign the permission to the user that they can manage a virtual machine or virtual network and so on. This is what they can do, perform the task. This task they perform is called authorization. So with respect to the IAM is identity and access management, and the basic purpose of the IAM is to authenticate and authorize who can log in and who can do what. So with respect to the IAM, first of all, IAM is a free service where you can create users, group, roles. Users are normal one, individual user like you and me. Group, I want to assign a policy or permission to the group of the user. So instead of that one, I create a group and add the user into the group and assign the policy. Policy means who can do what. What is the role? I'll talk about it. But you can create a users, groups, roles, policies, who can access what, who can log in, what services you can access. These all are managed by the IAM. So we require the IAM, which you can use to manage your resources one. Now remember, when you create your account, you eventually create your account using your email address. You all created your account using the email address. That email address which you use and using which you have created account become a root account. The root account is the account using which you can manage all your services one. So your services with respect to the your services aspect, the root account which you created have extreme privilege. He can do everything. The ID using which you created account is called root account, and he can do everything. And usually it is not a preferred to share the root credentials to your users. Rather, you should create their ID, individual ID, and when they log in, that's we call the IAM user. Guys, everyone keep a mic mute. So from the IAM aspect, one is root credentials, which have extreme privilege, using which you create your account. It have extreme privilege. We don't share it. Rather, we should create IAM user. IAM user means individual user ID. Two purpose. First of all, everyone should use their own username and password to access your account and manage the services. Second aspect, that they can log in and perform an activity and you can track it. As an organization, you can track who did what. If someone trying to do something which is not they authorized, as an organization, you can track. If someone change it unauthorizedly, you can track. So for controlling and compliance and aspect, one should manage their resources using their own ID and password. Now, okay, one question. What is the difference between a user account and service account? You are using lots of time as an administrator, as a one. There's a two concept. One is called user account. One is called service account. Anyone knows what is the main difference? What is the major difference between user account and service account, and why we use the service account? Because both are same. Yeah, anyone? Have you are people using Active Directory?
Yes.
So assume you go and you create a user, and user is user. So you can use the user. Let's say ABC is a username. Password is let's say P password. So both this can be a use. You can use this as a user as service account. But what you do differently that you're using as a service account? What is the main purpose? Still, that is one of the major. All are you are correct, but one of the important aspect is service account cannot be used login interactively. What does it mean login interactively? You cannot log in via the username and password in your account from the console. Service account can be only consumed programmatically. That is one of the major difference. Apart of all the difference, what you're saying right, but one of the major difference that it does not use to support allow interactively login. Logon interactively does not allow. So that's why you're seeing that. And AD, when you open, you create an account, you go to the properties section. There's one box that block login interactively. You should enable it. That is makes the service account. Same concept goes to the AWS. When you go to the AWS, when you create an account user, first of all, IAM user which you're creating can be a person, cannot be a person. If you're creating an account with a person name, let's say Ahmed, then this become used by the Ahmed, same account. And you can allow them that, okay, go to use the username and password and log in your account interactively from the console. But the same user account, if I created with the name, let's say HRMS, it is not for the user one, it is mainly for the HRMS application or access login interactive login programmatically. And using this account, we use access key and secret access key. So when you create a user, you get two things: username and password, using which you can log in interactively; access key and secret access key, using which you can manage it programmatically. You cannot use it to log in interactively, like on a service account. So if I want to manage my resources via the CLI, I want to manage my resources from the software development kits by the developers, we use access key and secret access key, and to use it from your programmatic access one. So you have two options which you can go for. AWS IAM. IAM can be a person or cannot be a person, depends what you're using. And you can create it, and by default you get an option to create a user with the username and password, or with access key or secret key, or with the both. You have all the options one. You can also enable MFA, two-step authentication, to avoid from the security aspect. Two-layer of authentication. When user login, he get a 6-digit code on their mobile, and when you log in, it can be much secure. So you can, a part of using the username and password, you should log in with the your 6-digit code, which is one of the secure aspect one. So from the IAM aspect, you can create a user. Now, please remember, when you create a user, by default, user does not have any permission. He cannot do anything. By default, user cannot do anything. So you create a user. By default, no permission is allowed. And then after that, you need to allow them to perform some action. By default, no permission. He cannot do anything unless until you can allow them to do. Even read permission is also not with the user. The minute you create a user, he does not do anything. He does not even have a read permission. You need to allow them to perform the read operation or not. It's totally up to you. And you can eventually use it and manage it. And when you're creating a user, you can create a user with the username, password, or access key and secret key. So with respect to your password policies and password management, so how you can allow the user to can do what? With respect to the policies is a JSON policy. Policy are a JSON policy. And using the JSON policy, you can allow the user to who can do what one. Now, instead of managing a single user, usually the preferred one is to create a account groups. So let's assume I have a multiple role in my organization. Like you, multiple people are from the network, multiple people from the Linux or Windows. Same concept that goes on premises. So you have multiple users who are performing the same job. So one option is I can create a policy. I can assign the policy individual to the each user one, not a preferred one. Because if user will move from one group, one department to another department, then you have to individually go and manage the policy to the individual user level, which is not a preferred approach. The preferred approach is create a group, assign the policy to the group, so that minute you add the user to the group, a policy will be inherited to the user. When we remove the user from the group, policy get removed automatically. So from the policy aspect, the suggested ways to create a group and assign the policy to the group instead of the individual one from the management or best practices aspect one, and you can eventually use it. Remember one important thing, also ensure that user should create a complex password, enable that user should, when creating a password, you can enable the policy that how password reset option, length of the password, strength of the password. You can define like user can use a uppercase, lowercase, or a special character, all the thing you can eventually do that. At any point of time, you can assign the access key can be removed also. So instead of disabling the user, you can revoke the access key and add the access keys. Is up to you. Just from the management point of view, enable the multi-factor authentication and assign the permission to the user and create it. You can also tag the user. What is a tag? I'll talk about it. Tag is used for the metadata, and it is mainly used for managing my user management one. I'll talk about the tag later on, but just understand as of now, the purpose of the tag is to manage your metadata description. It is providing additional detail for the user. We'll talk about the tags later on, but simple aspect just for managing a user. So I want to tag the user that I want to see who all the users are part of the HRMS department. I want to tag the user that who all the users are from the admin department or from the IT department. From that aspect, you can also use it and manage it. By default, user does not have any permission. He cannot do anything. He cannot utilize any services. You need to assign the permission explicitly to the users or group of the users. It means a group. And when you assign the user to the group, he will get that permission because permission will be automatically inherited to them. As part of the best practices, always give the user what they needed. That's called a granular access level, least privilege one. Least privilege granular basically is an option which using which you ensure that user will get the necessary permission what they need. If you have a database in the administrator, why should you give them a role for the creating a machine? If you have a monitoring team, why should you give them a role to create a machine or stop the machine or start the machine? No. So least privilege. Only give the permission what they can do. Don't give anything else from the user point of view, and you can eventually use it from the user's aspect. So With respect to the users, IAM, what we talk about, your root credentials, your users, or your groups one, and uh, how you can manage the users uh, in terms of the managing your resources programmatically by access key, secret key, or username and password one. Right. Before we go, anyone have a question so far? Please go ahead. So from the IAM point of view, now how you can assign the permission? Permission you can assign in the form of the JSON policy. And policy you can create it via using the JSON, or you can also create a visual editor. Visual editor is another way of creating a policy. So in another way, when you're creating a policy with the visual editor, it will on the backend it will generate the JSON policy. So if you don't know how to use the JSON, use the visual editor, or else you can write the policy using the JSON one. Both is possible one. Now from the policy aspect, the policy are identity-based policies or resource-based policies. There's one more policy that's called a service control policies. I'll talk about later on, and access control policies. Access control policies is managed individually at your S3 bucket level. We are not using it now because initially access control policy we use using which you can manage your users control at the S3 bucket. But later on we shifted to the IAM policy, and using which you can manage your much granular access. But yes, there's one more call. There's access control policy, and another one is organization policy. I'll talk about in a few minutes. But there's two types of the policies which you assign. One is called identity policies and resource-based policy. The difference between identity policies and resource policy is that you can assign the policy to the resource. Resource means like S3 bucket or some other resources one. So something like, let's take this example. So I have a user. I have a bucket, storage bucket. Bucket is your resource. So I created a policy here. Bucket one have a full access. Bucket two have a read access. Okay. So there's a policy. This policy I assigned to the user one. And in the policy, I define the bucket name and type of the access. I create one more policy, which is I assign to the user to the resource, where I say that user one have a full access, user two have a read access. Anyone, can you help me to know what's the difference between the policy which you assign to the user or resource? Anyone? See the difference here. See the difference and then try. So what we did, see here, assigning the policy to the user, you define the resource name. When assigning the policy to the resource, you define the resource user name. And that is the major difference between user-based policy and resource-based policy one. So if you want to create a policy for the user and assign to the user, write the resource name. If you want to assign the policy to the resource, define the user name. That is the major difference between resource-based policy and identity-based policy or user-based policy one. Now remember, with respect to the policy, when you're creating a policy, the policy can be allowed explicitly and denied explicitly. Allowed explicitly and denied explicitly. Allowed explicitly means that you want the user can perform certain action. Denied explicitly means you don't want the user can perform any certain operation. In case the two policy for the same work assigned to the user, deny will always take some precedence one. Remember, if two policies for the same task assigned to the user, the deny will always takes precedence. So I created a policy allow for my virtual machine. Another policy I create deny for my virtual machine, and same two different policy you apply to the user. Then deny policy will always win. So just remember it. So sometime you can create a allow policy, sometime you create a deny policy. If assume I have a monitoring team and I don't want that monitoring team can ever create a machine, I create a policy named deny create EC2 machine and assign to the user. Now, what will happen? Even assume the monitoring team have a very good terms with their manager, and manager can eventually go and assign them a policy that allow create a EC2 machine. It will not work. It will not work, and deny will always takes a precedence. So considering the situation, you always create a deny policy that you want that in any situation user cannot perform any action one. So you can create a deny and allow policy. So with respect to the policy, when you want to execute some task, system will check whether the explicitly deny policy is there or not. If explicit deny policy is there, deny. No other thought. And if explicit deny is not there, is there explicitly allow policy is there? If explicitly allow policy is there, then let them to perform the job, and neither explicitly allow, neither explicitly deny, then of course is a deny, because I told you by default, user cannot perform any action. If he cannot perform an action, then of course he cannot perform the action. But after that, if you create a policy to allow them, he can perform the job. Or you can create a policy to deny them, then he cannot perform that job one. So with respect to the policy, deny will always win, and you cannot perform any action. Now, from the group point of view, is a collection of the users. Add the users, assign the permission to the groups, and remember, group cannot be added into the group. Nesting is not supported, and but user can part of the multiple group, and eventually when user part of the multiple group, or you can assign the multiple policies to the single user, no limitation. So you can assign the policy, allow S3, allow RDS database, or allow SNS SQS, any services. So create a multiple policy, assign to the user, or create a group, assign the policy to the group, and add the user to the group one. So you have all the options. You need to look for how best you want to use, or how best you want to manage it. Is totally up to you how you want to do the management one. But preferred one is create a group and manage your users into the group one. Okay. Correct. Anyone have a question? Please go ahead. So roles. Role are a specific special principle which is used to manage, or which is used to assign a policy in various conditions. Let's understand it first. Now, first basic you need to understand. In case, remember what I'm saying. In case the policy which is a JSON-based policy, which is a JSON-based policy, which you can use to assign or define who can do what. In case policy cannot be assigned directly to the users or resource, in case policy cannot be assigned directly to the users or resource, in whatever conditions, we use another principle that's called role. Role is another option using which you can manage, you can assign the policy indirectly to the users or resource. How? Let's take one example. So let's take an example. So I have a EC2 machine, virtual machine. My code is running here. And this is a code which is running onto this EC2 machine will basically allow the user to download the images. So I have an application which is basically used to, I have a company application where users can download the images. I am providing them millions of images. My EC2 machine, where my code is running, I don't host my images into my code to EC2 machine. I created a storage, additional storage that's called S3 storage. And all my images are here. Fine, all good. Now I want my code should go and fetch the image. So assume your code needs to fetch the image from the bucket. As I told you, by default, neither user, neither resource have access to another. Even one AWS resource cannot have access to another AWS resource. Now, what is the best option you can do it here? One of the best option is I can create a user. I can assign a S3 full access. I can put the username and password in my code. or access key and secret access key in code. Of course, any of it. But storing the credential into the code is never be a preferable option. It can be misused. Now, another option is I may create a S3 full access policy and assign directly to the VM. This will be a good option. But you cannot assign policy directly to the EC2 machine. In such a case, we use the role. So one of the role functionality is you can create a role, assign the permission to the role, assign the role to your resource. Eventually, your resource can get an access to the service via the role another time. In case you cannot assign the specific policy to the resource, in that case, we need to create a role and assign the permission to the resource one. And that can also be temporary. Assume later on I want to remove the role. Yes, you can remove the role. Your access will be revoked, or assign the role. Access will be assigned once. So role number one aspect is your resource to resource, right? Now, second option, let's look into this way. I have a 3 account. So your company, your company have a 3 account. One is production. Okay. Now tell me, would you like to create a user in all the 3 account, or you can do differently? How you can manage all the 3 accounts? So you are one of the user. Would you like to create a user in all the 3 account? So go and create a username and password here, username and password here. Is this the way? So user need to manage 3 ID and password, and he can log in, log off, log in, log off, log in, log off. Or can we do differently? Anyone? Now what we can do here, in such a cases, we use the concept switch account. Switch account. So what we do, we instead of creating a user into the development and QA or other account, we create the role. So let's say create a role where user can have a EC2 access. Here, create a role, user can have a EC2 access. Now what we do, my user will eventually log into my first account. And there's a one option that's called switch account. There's a one option they give you, switch account. He can click on the switch account. Then it will open one more browser where they ask, okay, give the account number and your role name. The minute user define the account number and the role name, he can eventually access the different account. So via switch account, he can access the different account. But what he can do, then we use the role because we assign the permission to the role, and user can perform all the action with respect to your role one. So role, I told you, when you cannot assign the policy directly to the user or the resource, we use the concept role. Here in this account, I cannot assign my policy to the user one because user is not there. So we use the role or one. So switch account is a concept using which you can move from, switch from one account to another account without having an IDs in respective account by the concept of the role. Same role is also used when we integrate with a third party or on-premises directory service, same concept. So you have on-premises directory service. Your users are here. I don't want to create your user in my AWS one. Then one of the option I can use a create a role, and I can create a role. And when user login into my AWS account, my role, he can assume the role, take the permission from the role and perform the various action. So in simple word, role is a permission, specific principle, which is give you a temporary access because you assign the role and remove the role. You don't need to assign the credentials, and you can assign the policy directly to the role, attach the role to this resource or assume by the user one. So you have another option using which you can manage your resources in terms of the role one. So like you can use the role to give a service with access to other resource, of course. You can use for single sign-on, SAML 2.0 or OAuth 2.0, federated user, on-premises directory services, or switch role to access resource in your account or other account one. So you can have all the option. So from your account to other account, cross-account access, we can also use the role. to provide the permission and user who can do what, that what we can eventually use with respect to the role one. So role have a special permission, very good option. Using the role, you can manage your resources much better in terms of the temporary access, give a cross account access for a federated access, or assign the role when you cannot assign the policy directly to the users or group one. This is what we talk about from the users, group, role, policies one, right? Okay, clear? Everyone clear? Anyone have a question? All good. So what are the best practices? Avoid using your root credentials. From the daily administration point of view, don't use the root credential. Instead of that, create an IAM user account and assign the permission to the IAM user. And always give the least privilege, give the permission who can do what, and also provide them a cross account access using the role one. So you can do all the things with respect to the multi-factor authentication. Enable the multi-factor authentication for give a two-step authentication so that your account cannot be, username cannot be compromised. When user login, he can give the username password plus 6-digit code. You can configure your two-step authentication using your any software like virtual software which install onto mobile like Google Authenticator, or you can also buy the hardware like a Gemalto or RSA or other tokens, and you can also use it with respect to the MFA. And MFA provide you the two-step authentication. You can use it. So you can also assign the role MFA to the role so that it to make it more secure one. And that's what we talk about with respect to the one.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So now let's see how to manage the IAM one. So first of all, let me log into the console. So you see the option root user and IAM user. First of all, I should log in with my root user. I have an email ID using which I'm logged. Okay. Now, if you see, this is your console, simple, but this is your console. On your console, on the right side, you can see your, on the top, you're seeing your account number. Every account have a 12-digit account, your unique 12-digit account number, your name. You can select the region on the right side. You can see the option, selecting the region. Whichever the region you want to create a resource, you to select the region like North Virginia, Oregon, Mumbai, or Paris, and so on. Select the region from the right side. You can also go to the support in case you want to raise a case with the AWS. On the right side, you can see the option services. Click on it, and you can see all the services are here. Whatever the services you want, go and select it. And the recently services comes under the favorite one, which you are using it on regular basis, or you want to also make it favorite by just enabling this star button. On the top also, you can search the services. So you can also directly search the services from here. So multiple option you have. Now let's go to the IAM first. So either I can search the IAM here, or you can go to the services and select the IAM. So you can see your dashboard of the IAM account. Left side, you can see the users. Let me create a user here. So I click on add a user, click IAM, select the user, create a user, give the user name, let's say BV user 1. Now these are two options. If you want, the user should log in with the management console using the username password, enable the management console access. If you want, user can manage your programmatic access, enable the programmatic access key and secret key, or you can use either of it, your wish. Sometime I am a developer. I want to manage I want to log into the console, but I also want to manage my resource programmatically by using some development tools. So you can also use it. So both is available. Okay. You can also generate your password. You can also enable the password that user can change the password of the first logon. I don't need to need it. I'll just remove it, go to the next. As of now, I don't want to assign any permission to the user. Otherwise, you can click on attach existing policies, and you can see all the policies are here. Policies are two types. AWS created policy, which is pre-created, which is already available. You can use that policy. If your day-to-day needs is not fulfilled by the AWS policies, create a custom policy, create a policy which you're creating. So that's what we are saying. When you need to create a policy, that's called a custom policy. Otherwise, you can use AWS managed policies. I don't want to assign any policies as of now. Go to the next. Go to the next. I'll click on a create a user. That's all. Now, when you create a user, you can see that option: username, password, access key, secret access key. So you can also see on the top that user can log in with this URL. In this URL, you can see your 12-digit ID. Every user can always log in with a 12-digit ID one, which is this URL. So two ways. I can copy this URL. I can copy here. Now, if you see here, the minute you log in with the URL, it will automatically populate your account ID. And this account ID you can populate, which is a 12-digit ID. Then you have to provide your username and password. This username is not your email ID, rather is your username, this one. So I copied this username, give your password and sign in. I sign in. Okay, all good. So let me move back to my console. I click on close, all good. So this is my root account. Let me see one thing. Let me go to the EC2. Sorry. Let me see any virtual machine is running or not. Fine. So I have one machine is running here, which is in North Virginia, and I can see from the root account. Now let's go to your user account. You can see EC2 here. I go to the instances. You are getting the error. You are not authorized to perform this operation. Why? Before that, you see that now I am in different region. So ensure that your region should be correct first. Otherwise, you cannot see the resource. So first thing, but you are right. So first change the region. We should be in the same region where you need to see the resource. But again, in this region also, I don't have a permission to perform this operation, which is absolutely right. So let's go back to your IAM, open the user, and you can see the option for permission. Let me add the permission. I can click on attach existing policies, and I can see all the permission here. I can see all the permission here. You can go eventually add and see all the permission here. See, so all the permission are here, and you can give an access to the user, whatever the permission you want, and you can see it here. So let me check if I get read only permission. Otherwise, I'll assign the full permission. Let's give them a EC2. So you can give an EC2 read only access. Let's say that. So I see the EC2 root access. I assign the permission. This is an inbuilt permission. Now user have a EC2 read access one. I go back. Now I can see my resource from the user now. So you see that username, account ID. Now he can see the permission. So you can create you can give them a permission. You can also create a policy and assign to the user same way. So the way this is any orange color is a inbuilt policy. Now, if you want to create a policy, you can also create a policy by going to the policy. This is a user created policy. So click on a create a policy, and you can write a policy into the JSON directly, or you can click on visual editor, and the visual editor, you can expand the service name, whatever service you want, you can search it from here. I'm just giving you just few options. Let's select search for the EC2, and you can see you want to give all the permission, everything, full access, make a all EC2 action, or you can expand the each of it, expand the right. You can see lots of things are there. Attaching a volume, taking a snapshot, give a user read instance or stop instance, stop, start, granular access. I want a specific access. So I want user can start or stop the instance. I want user can create a machine. You can give any access. You can see lots of policies are here. And whatever the policy you created here, I'm just showing you a few things. Then you can define the resource. Assume you want all the resource user can manage, means all the resource, all the EC2 machine, or a specific machine. If you want a specific machine, you can click on add URN, give the region name, and give the instance ID. Instance ID, this one, this is your instance ID. Or you can give a multiple instance ID, your wish. So you want a specific resource can also be managed. And you can I put all. You want that user can only manage this action when the two-step authentication is enabled. You can also say that user can only manage this policy when the request is coming from the specific public IP address. Let's assume that I want the user can only manage this resource when the add request is coming from your corporate IP address. Otherwise, user cannot. So you can create a policy, give the name, create a policy, and then you have a policy. You can see here, this is the policy. You can expand the policy, and this policy is automatically created the respective JSON one. Same thing. Effect allow, action, start and stop the instance, condition, a resource, all resource, asterisk means all resource, condition when multi-factor is present, condition when the respect is coming from this particular IP address. Now I'll go to the user. I open the user and assign the policy to the user. Same way. So I search for my policy and I can assign it. But rather than that, let me create a group and assign the policy to the group and add the user. Another option, good option. So create a user. I create a group, sorry. I open the group. I go to the permission and add permission. Which one? BV user policy I assign. So this group, I assign this policy, and now I will add the user. Done. Simplest way. So you can create a policy, assign the policy, create the users, attach the policy, create the group, assign the policy to the group one. Now, next thing which we're talking about is role. Now, role is you can use when you cannot assign the policy directly to the user. It is used for the assigning the permission from a resource to resource, or to the federated user or non, in case I want to give a switch account, assume. So first I click on a create a role. And the role when you're creating, you need to define which service you are creating the role. Are you creating for EC2 virtual machine, your Lambda, or any other services? You've seen lots of services are here. So I want to create a role for the EC2 machine because I want to assign this role to the EC2 machine. I go to the next. And I want the same thing. I want this EC2 machine have a full access to S3. So I search for S3. I can assign the S3 full access. I create a role. So I created any role with the S3 full access. I create a role. Okay, my role is created. My role is created. So I created a role. This role have a what? This role have a what permission? S3 full access. Okay. Now I want this machine should have S3 full access, so that when you execute any command on this machine, it will directly access the S3 full access. So that is the purpose. Now I go to the machine. You can assign the role at the time of creating a machine, or you can assign the role at the later on. So machine is running. I go to the action. I go to the security. I click on modify role, and I assign the BV role here. Now what will happen? Now I assign the S3 full access to my machine. What will happen now? Anyone? From this machine, I can do any S3 operation. Otherwise, I need to provide my username and password, user credentials. I don't need it. Assume after a certain point, you say that, no, I don't want to give this up. I want to remove it. Fine. I can go, I modify the role and then say no role. Now my role will be detached. So I can detach the role. So totally in your hand. Clear up to this point from the role aspect, from the service point of view, how you can create a role and assign a resource to the service to service. Clear? Okay. So assume I have a 2 account and this is my user account. You are seeing this option, switch roles. If you click on this switch role, it will ask the switch role option, and it will ask the 2 things, account ID and role name. The minute I put account ID and role name and click on switch role, what will happen? My account will eventually gain an access to where? To my second account. So account 1, account 2, user 1 here. So I created the role name A with S3 full access. The minute I click on switch account, it asks me 2 things. Account name. Let's say account 2 name is 1234. It asks the role name, which is A. The minute I click it, I get I log into my account 2. Now what I can do in account 2, what I can do? After switch account, what I can do in account 2? Can I create a EC2 machine? Yes or no?
No.
If you create a multiple role, give them a role. You ask the user, okay, first, if you want to perform an A action, perform the role A, select the role A, or you can assign the multiple permission to the role, EC2 machine, S3, RDS. Then he can log in without having the ID across the account to get an access to your AWS resources. This is what the role aspect from the user. If I want to assign the role to the user which does not exist in my account, we can use switch account purpose. Else we can use the account purpose to role to give my access on a resource to resource one. Someone asked the question, he was confusing with the role. Now it is clear. So when you go back into your production, don't ask your team that create an account into the multiple account. Don't do that. So I want that, and no one can access it. Then in my principle, I put the AR and ID so that it can be restrictive to specific user also, not to everyone. So you know how you can restrict it. You can say that only the specific user can access when their ID is same one, then only he can use, otherwise not. Got it clear? So anyone still have a clarification on user, group, policy, role? Everyone clear? Very important from the AWS point of view. Otherwise you get confused. Okay, how I get that permission? You can unnecessarily struggle when you cannot perform any action. You say, I don't know what is the reason. Talk to your IM team and ask them to give a permission and manage your credentials one, right? Everyone clear? Again, anyone have a question? IM role is still confusing. Any point? Please go ahead and clarify your one. Don't look for other one. Ensure that your concept should be clear. Okay. So now with respect to the multiple account, if assume you have multiple account, then problem is if you have 2-3 accounts, you can manage it easily. Fine. But if you have a 10-20 account, then how you can manage it? You need to go manage the billing invoice of every account separately. How you can assign some group, your corporate level policy to the account level. How you can manage your cross account access is enabled or not. You need to manage your account one, group account. There's another service that's called AWS Organization. AWS Organization is a service using which you can manage your multiple accounts from the single account. You can manage multiple accounts from the single account. So you can say that, so I have one account. Let's say this account will be parent account, and I attach multiple child account to this parent account. So what will happen? Now I can manage my all these multiple accounts from the central account. So central console, I can manage my multiple account. That's called AWS Organization. I can get a policy, assign the policy to the account level. What I'll talk about it. I can get the consolidated billing. I can pay all my multiple account charges from the single account. I can do multiple things. But one of the important point for managing AWS organization is your corporate policy. Let's look into this way. So I have a 3 account. Okay, fine. I have a 3 account. So let's say that you have 3 different projects. So your company managing 3 projects. Big company managing 3 projects. Every project have a 2 different account. Every project have a 2 different account. Production, development, production, development, production, development. 3 so eventually you have a 6 account. 6 account for 3 project, 3 for production, 3 for development. Okay, fine. Because production account is very critical. You don't want that any of your employees should go and delete any resource into the production account. You don't want. You want to apply the policy at your organization level that no one will allow to delete any resource. Even though user have a full access, still they cannot delete my resource into the production account. It means I want to assign a policy, same policy which I just talked about it, at my account level, which will be the highest precedence. This policy is called service control policy. Remember when you're talking about the policy, identity policy, resource policy, ACL, and then service control policy. The service control policy is a normal JSON policy, but they will apply at the organization level, account level, which have a highest precedence. Now I can assign a policy at my account level using the SCP, service control policies. But service control policy is the same JSON policy, same concept, no difference. You just need to assign to the organization level. That's the only difference. Or I want to create a policy that in my development account, user can only create a resource in Mumbai region. Why they should create into the other region? They should only create a Windows machine. Why they don't want to create a Linux machine? I don't want. I want they should only create a specific type of the VM which give you 2 GB RAM, not higher one, because the development one I don't want to add additional cost. In such a way, we use the service control policy which is assigned by the used by the AWS organization one. Now there again, assume I need to apply the policy to the 3 different account. I can create a policy and assign to the individual one. Not a good practice. What is the better option? The better option is, why don't I create a policy and assign the policy to the group? So I create a group and put all the account into the group and create a policy to the group that no one can allow to delete the policy, delete the resource. Easy to manage. This all we can achieve with the AWS organization. In simple word, using the AWS organization, you can manage your multiple account from the single console, from the billing aspect, from the policy aspect. If you want to create additional account, you can also do that. You want to create additional account, you don't need to define your username, your email ID and credentials and password. No, you can directly go to the AWS organization and create an additional account. So AWS organization is a service using which you can manage your multiple account from the centralized place, and you can assign the policy to the parent account, root account, or you can also create a groups which we call OUs, and policies are always inherited from top to bottom. If you assign the policy to the root, it will inherit to all. If you assign the policy to the OU, it will inherit it to all. If you assign the policy to the account, of course, it will be account one. But you can create a typical tree structure where the policies will be flow from top to bottom and can be assigned for your AWS resources one. So you can create an organization to assign the policy to manage your multiple account from the centralized place. This is what we talk about in this module. So in this module, what we discuss about the basics of the system operation, your basics of the cloud, your AWS global infrastructure, your how you can deploy any website, concept of the IAM, organization, management, aspect one. Before we go to the next module, anyone have a question, please go ahead. But from the management point of view, you just need to see from the, when you add, so what is the paid? Assume you go to the AWS or organization, you are adding another account. Of course, it's the paid one. But from the policy aspect is the free. Creating a policy, getting a single console for billing, all are free. It is a, in other words, you can say is a free service. Unnecessary confusing. Say free service, okay? So whatever you're creating, you will pay for it. Otherwise, it is free service. Here. Okay, so from the tooling and automation aspect, you can manage your resources from the multiple ways. You can manage your resources from the multiple ways. One is your management console. Of course, you can log in the way I log in. You can manage a resource from the CLI, command line interface. Whether you're using Linux, Mac, or Windows, you can do it anywhere. Usually, administrator prefer to use CLI instead of creating a resources from the console. You also prefer to create a resource from the CLI. So you can also do that, allowed. You can also use software development kits. As a developer, if you want to create a resource from your different programming languages like Python, Java, .NET, and so on, you can also do that, but you have all the option with respect to the AWS one. From the AWS CLI aspect, you can connect your AWS CLI for Linux, Windows, or Mac. To manage your resources from the CLI, you need to install the libraries on your local machine so that when you execute your CLI command, system should understand what you're talking about. And then you need to connect your AWS account using the command known as AWS configure. It means, let's look into this way. So let's assume this is my one server, and I want to create a EC2 machine from the CLI from this server. And I execute command AWS EC2 create. I'm just giving example. Now, which account this resource should create? I have not given any credentials. I have not authenticated. Neither I have authenticate, neither I have authorize. To authenticate, I should have a user. For authorize, user should have a permission or policy. So before I want to create my user resource using the CLI, I want to use the command AWS configure. AWS configure, when you execute, it will ask you access key, secret access key, because you are doing it programmatically. Your region, which region you want to create a resource, and your output, how you want to see the output. You want to see the output into the JSON format or tabular format, whatever. So when you write the AWS configure, it asks you to provide your user credentials, region name, and output. Okay, fine. Now here you are seeing one option within a bracket saying optional if instance profile is used. Instance profile is role. Another name of the instance role is the instance profile. Anyone? What is the meaning of this way? He's saying instead of access key, secret key, you can use instance profile. What does it mean? Think. So I want to create a resource, but before that I need to provide this detail so that I can get a authentication and I get the policy to create my EC2 machine, whatever. But they're saying another option is create a role. What does it mean? Instead of giving a AWS configure, I create a role, give a EC2 full permission, and assign the role to my machine. What happened? Same concept. Now my machine can have a EC2 access. So another option, another way. So that's why we're saying instance profile. Please remember, instance profile is nothing but a role. So you can use AWS configure, but assume you are, when you're connecting to the AWS from your local laptop or desktop, you cannot use the role. Role can be only used when you are using in AWS itself, but from the EC2 machine, or you can also use AWS configure, or you can also use your local laptop and configure. So you have multiple ways of accessing your resources from the CLI one. So what is the format? So you can use AWS EC2 stop instance. EC2 service operation is stop or run instance. You need to also define your parameter, which machine you want to stop, ID of the parameter, option also, how you want to see your option into the JSON or tabular format, whatever. Sometime I want to stop multiple machines. If I want to stop multiple machines, one of the option is I can execute the same command again and again, or I can put all the instance ID into the one file, like a JSON file, and pass as a parameter. Good option. If I want to perform my action into the multiple resource, I can put into the file and pass as a parameter one. So you can also use EC2 run instance and create your resources and manage your resources one. So you can eventually do all the things from your resources and expect your resources one and manage your resources with respect to the EC2 one. So you can also go and see for AWS help, EC2 help, describe instances. You can also use the help command to manage your AWS resources one. When you're writing AWS EC2 describe instance, remember, it will show you the complete details. The detail will always show in the form of the column separated, name value pair, column separated in the form of your array. Result will always show you in the form of the array, and it will show you into the column separated one, like image ID, instance ID, key name, launch name, placement, IP address. You get all the details when you write your AWS describe instance or whatever the resource you are creating. You can eventually do that and create a resources one. So you have all the option which you can eventually do with respect to the AWS and manage your resources one. And with respect to the resources, you can define the details, and when you need an output option, you can select your JSON table and text. When you need to configure your AWS, select your AWS configure, provide your access key, secret key, location, and then your output format, which you want JSON and one, and start executing your resources using your AWS CLI command. Few of the command which you can use. Of course, we are not going to the detail of the EC2 one. All the documents are available. You can go through it and manage your how to use the various command, how to write a script. You can learn from all this aspect, but basics of it, you can use the EC2 run instance, describe instance, create volume, create VPC, listing of your S3, copy, move, rename, lots of S3 command, which you can eventually use for managing your resources. So one of the way to create a resource from the console, another way of creating a resource from the CLI. When you're creating a CLI, you can, and you are using AWS EC2 machine to executing a CLI, either define your AWS configure or use your instance profile. If you're creating your from your own laptop or desktop, you need to use AWS configure. AWS configure will ask you the user credentials in the form of the access key, secret key, because you are using it programmatically and manage your resources one. Right? Anyone have a question? Please go ahead. Okay. Now, from the administration point of view, you need to perform multiple tasks. From the administration point of view, you need to perform multiple tasks. You want to manage your resources from the single console. You want to group the resources to perform some action. You want to view your data. You need to perform, you want multiple things. To perform all these multiple things, there's a service known as System Manager. AWS System Manager is a service using which you can perform multiple things, which include your automation. Run command means you can execute your script. You can connect your machine. You can perform the patch management. You can also create a maintenance window for patch management. State manager, parameter store, inventory, insight, dashboard. You can eventually, you want to manage multiple things from your environment one. So you can also do the automation. Means I want to create a script. I want to create a script means I want to create a document. I want to write my script and execute my script onto the one machine or multiple machine. Like I want to update my code. I have a 10 machine and I want to upgrade the code into all the 10 machine. Either you can log into each machine and then then upgrade the code. Or I have a 10 machine. I want to install my new application. Either I can log into each machine and then log and execute my script individually. Or I can, using the system manager, I can create a script. Document is your script and execute on all my machines. Yes, I can do that. System manager is a tool using which you can automate your environment.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
You can execute your common and repetitive task. The way you are using your any automation tool, exactly same way you can use the system manager. System manager, but remember it's a regional service. Within the region, you can manage all the resources. One. You can also use the run command. Assume your machine is already running. You already created your machine. And after your machine get created, I want to execute some command or I want to execute some script to perform my task, whatever. Then we can use a run command. Remember what I'm saying? Once your machine get created, after the machine get created, I want to perform some action, which include your any application deployment, updation, executing my command. We use the run command. The run command can be used to execute your script. Previous slide, we talk about that you can create a document. When you create a document, which is a script, then how to execute the script? Using a run command. So using the run command, you can execute your script. And you can execute the script onto the one instance or multiple instance. So you want to execute the script on all the machine which is mapped to the HRMS department. I can do that. So tag is a metadata which is used to assign your name. So like I have a 10 machine for HRMS, 10 machine for admin, 10 machine for IT, but I want to execute the script on all the HRMS machine. Yes, I can do that. I can select the department name under the tag. I select the department name as a HRMS and execute. So run command is an option using which you can execute the script for managing your resources. Schedule it or execute anything you want. You can do that. All option available. I want to connect my machine two ways. I can, for Windows machine, I can use the RDP and connect. For Linux machine, I can use PuTTY or SSH to connect. But there's one more option that's called a session manager. Session manager is used to connect the machine from the system manager console. But you can only connect to the console. You don't get the GUI option. Please remember it. But another option. Usually when you're creating a machine, you need to open the port. So for connecting to the Linux machine, you need to open the port 22 and you require a key pair. Key pair is the option using which connect the machine. So you require the key pair and the port number. If you forget your key pair, if you lost your key pair, if you have not opened the port, then we can use a session manager to connect my Linux or Windows machine without opening the required port within the region or without needing my key pair, which is a user credentials one. But remember, I can only connect to the console. For Windows, it should be a PowerShell. For Linux, it should be a Bash one. So we can use it and connect. Good option. So single console, you can manage all your machine one. and all the communication is secure, so you don't need to worry about it. You can also check who accessed my machine. You can store the logs into the bucket or enable the cloud logs, so you can check who did what. You can also get all the details with respect to the session manager one, so you can check which user have login and access it. You can also create a patch. You can also deploy the patches. You can deploy the patch automatically, all the group of the EC2 instances. Please remember, system manager is also used for on-premises. If you want to use system manager for on-premises machine, you need to install your exe file to manage your on-premises machine from the system manager. Like you have any other tool, Microsoft offering a tool, or any multiple products are offering the tool, you can use it from on-premises to AWS or AWS to on-premises. You need to install the your exe file onto the AWS. If you are using on-premises tool or on-premises machine you want to use, install the exe file on the on-premises. You can do the patching also. Create a patch baseline, define the maintenance window, apply the patches, check which all machine your patch is deployed. You can also create a maintenance window. You want a group of all the production server will be deployed on Sunday, or first server of the production will deploy into the Sunday, second server of the production will be deployed into the Saturday or Monday, whatever. You can do that. Define your maintenance window the way you're doing on on-premises, exactly same way. Define your maintenance window and deploy your resources with respect to the window one. You can also do that. You can also configure your state manager. State manager means I want that one of the states should always maintain. So what I want, that my web server should always running. I want my web server should always running. So I have one web server. So with respect to the web server, I want my, let's say, Apache service should always be running. Apache or IS services will always be running. How I can do that? To run Apache or IS services, we should ensure that I can schedule my script, which will go and check my services after every certain hour. And if services stop, my script will start the script. Simple. Whenever stop, it will start the script. So I can achieve it by the state manager one. So using the state manager, I want that my certain state of my machine will be maintained. Yes, I can do that, and I can manage my state manager one also. So I can schedule the script which will execute after every 30 minutes, and if my application is not into the specific state, my service will start the service one. So you can also do that with respect to the state manager. I can also use parameter store. The parameter store where I can store my credentials, not user credential, but like my database credentials. I don't want to store my database credential into my machine. I can store my database credential into parameter store, so my server can access my credential from the parameter store. Good option. So assume this is my VM. This is my database server, and my VM want to access the database credentials. Fine. So usually you put the database user and password of the database into the code. No, I don't want. Rather, you can keep your credentials into some other location. So you can keep your user and password into the other location, and this VM will eventually, whenever they want to connect to the DB, it will first go access your username and password from the database, your parameter store, then connect to the database one. Good option. So I can secure my user credential by storing to some other service like a parameter store. Good option. I can also generate my inventory. I want to collect my information of my instance. What is the software installed on them? What are the services are running on them? I can also do it from the inventory point of view. I can do that. I can also check all the dashboard from the single place. I want to see, okay, who all access my resources. I want to see all the resources changes from the AWS config. I'll talk about it. I want to see all my software inventory, my patch compliance, my resources access from the single dashboard. I can also do that. That's called inside dashboard. So centralized place, you can view everything from the AWS system manager. AWS system manager, and there another service called AWS config, which is mainly used for your compliance need, where you want to capture the changes. If you change your machine from EC2 2 processor 2 GB RAM to 4 processor 4 GB RAM, you want to see, okay, what are the changes happen to my machine? You can do that. You want to see some additional details. like how many machines are running, which types of the machines are running. You can do lots of things from the AWS config one. You want to check your configuration history, changes to the resources, your compliance need. If you want to create some compliance and you want to see whether you are meeting that compliance or not, you can use AWS config. AWS config is a tool using which you can manage all your compliance and resources one. So good option with respect to the compliance one. So you can use AWS config along with the AWS system manager to manage your resources with respect to the administration one. So compliance, you want to apply some compliance, organization compliance, and you see which all resources are meeting that compliance or not. So write your compliance and see which all resources are meeting that compliance. Execute your script onto the multiple machine at the same time. Manage your resources from the single console. This is all you can do from the AWS config, which is basically used for managing your resources one. And this is what we talk about so far. So from the administration point of view, you have all the options from the managing your resources from the single console using the system manager, or compliance need you can meeting via the AWS compliance. Some policies are already written, else you can write your own policy in the form of the JSON and execute it and manage your compliance one, right? We'll do this lab into the, we'll do the lab of system manager and AWS config when we do the EC2 one, we club it there, but yes, it is there. Anyone have a question so far? Please go ahead. So some additional development tools, like your, you can use your PowerShell. Yes. Like a CLI, you can also use a PowerShell. My AWS has now started supporting your PowerShell. So you can execute and manage your resources via the PowerShell also. You can also use various software development kits like Node.NET, Python, PHP, Node.js. If you are a developer, you want to use it, yes, you can do that. You can also create your resources from the cloud formation. Cloud formation, we have a separate topic we'll talk about later on. Not go in detail as of now, but just tell you, you can also automate your environment by using the cloud formation, using the JSON or YAML script. You can see all the changes, what is happening. You can also see what are the changes happen, which is a user did it unauthorizedly. You can see everything. So cloud formation is a service using which you can execute your JSON or YAML template, and you can execute your resources and manage your resources one. AWS also support your ops work. In case you want to use your Chef, Puppet, AWS also supported it. If you want, you can also go and use the AWS ops work. We support your Chef and Puppet for automation. A part of the system manager, yes, you can also do that. So in case you want to use your Chef or Puppet into the cloud, yes, you can use the AWS ops work. We support your AWS ops work, which you can use it to manage your resources in respect to the Chef and Puppet. So from this module aspect, what we have learned so far, we talk about your how to control your AWS services by the CLI or console. A part of this console, you can manage it from CLI. From the administration point of view, you can use the system manager. From the compliance point of view, you can use AWS config. For automation point of view, you can use cloud formation, or like the system manager, you can also use ops work one. So far we talk about your basics of the cloud. We also talk about the how to manage your administration, compliance need, creating a resource from the CLI, and managing your resources from the using the IAM, and so on. That what we talk about as of now one. Okay, so let's go ahead then. Next, we're talking about your virtual machine. Virtual machine, simple. And from the virtual machine aspect, we're talking about the AWS EC2. Now, remember, the virtual machine or EC2 is EC2 is your virtual machine, Elastic Compute Cloud. What is the purpose? To execute your deploy any application. Now, with respect to the virtual machine, EC2 is a service which you use to deploy your operating system or whatever application you want, you can eventually do that. Let's look into this way. So this is a physical server. Then you, on the physical server, you install your kernel operating system or host operating system. Then you install your hypervisor. Hey, anyone, what is a hypervisor? So some of the famous hypervisor is you have used VMware, which is use ESXi, Hyper-V, KVM, Zen, and so on. AWS use Zen. Even AWS have their own hypervisor, which we call Nitro. AWS also use their own hypervisor that's called Nitro. So as on date, AWS support two hypervisor. One is Nitro, which is their own product, and Zen, which is one of the open source product one. So then on top of it, you create a VM, and your hypervisor is basically responsible to managing your VM. Then on the virtual machine, you means you are responsible starting from this point. What is starting point? Starting to install your guest operating system, installing your application, backup, monitoring, availability, scalability, management. You are responsible for all this. But before this guest operating system, you don't have any access, any control. And that's what we call, when you're talking about the IaaS, infrastructure as a service, you don't have any control below your operating system. You can neither see it. So from the EC2 point of view, which is the Elastic Compute Cloud, where you can create a EC2 machine, virtual machine. Below the virtual machine, you don't have any access. Below your guest, you can start your support only from your guest operating system and above. And whatever you do, you are doing it where you can do the everything from the operating system and above one. This is a simple aspect of your virtual machine, right? Anyone have a question? So from the virtualization point of view, your physical server is connected to your storage, your SAN, from where you assign the storage to your physical server, and physical server to the VM. Everything is there. So AWS have their own servers. They provide you the servers are connected to the physical server, connected to your storage services like EBS and S3 we'll talk about later on. Every physical server have their own disk, which we call ephemeral or storage. I'll talk about later on when we discuss about the storage. Separate module, we have a storage where we discuss from the storage aspect. In this module, we're just concentrating from the EC2 point of view. It will be connected to the EC2 machine. You can have a manage your EC2 machine and everything. You can do that. Now remember, with respect to the EC2 machine only give you the processor and memory. What does it mean? It means when I create a EC2, it will only give you the vCPU and vmemory. But what I'll do with the CPU and memory, I want to create a machine. To create a machine, I need the disk. So that when I install my operating system or my application, I need the disk. But EC2 give you processor and memory. It means to create a machine, I need two services. And this disk is called EBS. So eventually, to creating a machine, you need two services, EC2 plus EBS. And your pricing include your EC2 plus EBS. If you're using a Windows or any operating system which needs a license, that is also included in your pricing. And the best part is, if you stop the machine, your EC2 and license pricing get stopped. When you stop the machine, your EC2 and license pricing get stopped, but not for the EBS. Anyone knows why EBS pricing cannot be stopped? So this is a disk. You already occupied the storage. So this assume this is 1 GB of the storage. You have not released the storage space. Correct. So that's why by default, when you stop the machine, your CPU and memory released. You're not using the license, but you still occupied the storage space. That's why storage space prices continue. And if you don't want the storage price terminated or deleted, then your pricing will be only stop for the storage. So remember it. If you stop the machine, your pricing for the disk will continue 1. So from the machine point of view, when you're creating a machine, you need to create a machine into the tenancy. Tenancy is called a default tenancy, means it is running from the shared environment. You can create a service role in your Bastion or your instance profile, same thing which I talk about it. And you can also create your, you can deploy your machine to the network. Of course, otherwise how you can connect your machine. So when you're creating a machine should be deployed in one of the network. When you're creating a machine, it should be deployed into one of the, you need to use your disk. You can execute your script using the user data. You require the image like operating system disk, Windows, Linux, whatever, in the form of the image. Which port you should open, you need to use the security group. How you can connect the machine, we use the key pair one. We'll talk about one by one. Okay, so with respect to the AWS EC2, when you need to create a machine, you don't need, you need to define your how much processor and memory you need. And with respect to the AWS, when you define how much processor and memory you need to tell to the AWS boss, I need to create a 2 processor, 2 GB RAM, but you cannot do the customization. So what the AWS did, AWS create the various instance type. They create the various instance type. From the instance type aspect, so what they did, they created the instance type like A1, which give you 2 processor, 2 GB RAM, B1, which give you 4 processor, 4 GB RAM, C1, which give you 8 processor, 8 GB RAM. So when you created a machine and you say, okay, give me a A1, AWS give you the 2 processor, 2 GB RAM, or 4 processor, 4 GB RAM, and 8 processor, 8 GB RAM. This is called instance type. And AWS have a, they have created a multiple instance type with respect to the, considering your size and configuration, like you see the right side, the T2 Nano or X3 large, give you the different type 1, like how much processor and memory you get. So they put the various type into the various families based on the business cases, which include your general purpose or compute and memory optimize, whatever. So from the instance point of view, when you're creating a machine, you say that, okay, how much, and each family give you the, how much CPU you get, how much memory you get, whether you can assign the SSD or HDD disk or what type of storage you get, your how much network bandwidth you can also get. Please remember, network bandwidth also varies. It means for the instance 1, which is a, let's say A1, you may get a 500 MB one. For B1, maybe you get a 1 GB of one. C1, you may get 25 GB. It varies. So how much network bandwidth, processor, and memory you get, it depends on the instance type which is selected. And these instance types are into various categories, which include general purpose, compute, memory, accelerated, and storage optimize. So based on your requirement, you can select the machine. Like a general purpose, give you the balanced CPU and memory. Compute optimize, you get more processor than memory. Memory optimize, you get more memory than processor. Accelerated computing, you get more, where you get the GPU, graphical processing unit. Storage optimize, where you can perform more what you call intensive IOPS one, better IOPS, input output per second. So you have a multiple option, you can select off it. So you can go to the machine, select off it. You have a multiple families, and from the multiple families, you can select the various machine types. AWS support AMD, Intel, and Graviton. Graviton is AWS own processor. You can select the machine based on this type of the processor also, but AWS support your AMD EPY, Intel Xeon or Graviton processor, and you can go and select your machine with respect to the all the different aspect one. So you have all the options. So when you're creating a machine, you select the type of the machine. The next thing you need to deploy the operating system. To deploy the operating system, you need to choose your image. And when deploy the operating system, you need to choose the image. The image comes as the form of the AMI, Amazon Machine Images. So with respect to the AMI, you to deploy, you need to select it, and then you can deploy it. So from the AMI aspect, AWS provide you the various images, which include Linux, Windows, Ubuntu, Red Hat. These are pre-built images, AWS provided images. You can select the image and image can be deployed. Some images are also provided under the marketplace, which is selling by the third-party companies. Assume I want to create a machine with the Citrix. So Citrix company is already supporting and provide the image, which include OS plus the Citrix in the marketplace, where I can go and buy the Citrix image. Few portion go to the AWS, few portion go to the Citrix one. Good option. Citrix, WordPress, or lots of companies offering their product. You can go to the marketplace and buy the images from the marketplace one. Some images are also offered by the community people like you and me. I want to offer some images which is available into the AWS one. So images are available. You can select that image, which include your OS plus database, OS plus a specific application, and so on. Now, from the image aspect, AWS already created these images, which is called pre-built images. A part of it, AWS also support your customized image. Anyone heard about what is a customized image? What is a customized image? So let's take as the example, I want to create a simple example. I want to create a 20 VMs. And when I create a 20 VMs, in this VMs, I want to, let's say I want to install my operating system, my X application, my another application, my one of the tool, and I want to create 20 machine with the same one. I don't go and create a 20 machine with the same operating system, application, and tool. No, I don't want. What is the best option? Why don't I create a customized image? This image includes whatever we deploy into the machine. And from this image, I can deploy the 20 VMs. Good options. Good option, right? So you can deploy the multiple machine from the same image. That image called a user built image or customized image. Now, image include what? Ultimately, image will be deployed where? Your root volume. Ultimately, when you select, I told you EC2 include what? Your processor and memory. But when you deploy your image should be deployed where? Image cannot be deployed in processor and memory. It required the root volume. So image also have the information of the root volume where it can eventually deploy. So where it can be deployed. And when you're creating your image, you can also define that who can use that image or not in terms of the launch permission. Like I want the user one can create a machine using the user one have allowed to create a machine from my image or not. I can also define it. Image you can also copy across the region, so that for disaster recovery purpose, you can create an image and copy across the region. So primary region goes down, you can create an image machine from the secondary region. Yes, you can do everything from the image aspect one. So Amazon Machine Images are your image, and you can eventually use it for creating your VMs. You decide what type of the VM you needed, processor, memory, bandwidth, then which OS you want to install. You can create a OS provided image. Now, please remember, you can also upload your on-premises image to the AWS possible. That's concept is known as import export. If you already have an image on premises and you want to use your image into the AWS, yes, you can upload the image using import and export, and using that image, you can create a machine. So with respect to the image contains your information of the volumes, whatever the volumes or a disk you attach, and who can launch your machine, you can also do that. Now, when you're creating a machine, next thing you require the storage, disk. AWS provide you two major types of the disk. One is SSD and HDD. Anyone knows what is the difference between HDD and SSD? So HDD is a traditional disk, magnetic disk. SSD is based on the solid state drive. It's faster. It gives you much more IOPS. With respect to the AWS support you 240,000 IOPS for your SSD. We'll talk about in detail your disk in later on one of the module. So we are not going in detail with respect to the disk, but just update you. You have two options, HDD or SSD, and maximum IOPS you get, which is a 240,000 IOPS. The maximum disk size is supported by the AWS 64 TB, and maximum throughput of the disk, it is a 4,000 Mbps. Very good option. 4,000 megabit per second throughput, 240,000 IOPS, 64 TB of the disk. That is the limitation as of now you have. But yes, we'll talk about later on with respect to the disk one. From the deployment aspect, when you do create a machine, you need to deploy the machine. But machine should be deployed where? In one of the region. Machine should be deployed where? In one of the zone. So when you're deploying the machine, select the zone, select the region. But machine should be deployed into your network. AWS by default have a default network. Every region, they have a default network, so that you can use your default network to deploy your machine, or you can also create your own network to deploy the machine. How to create a network, we'll talk about into the upcoming module, but just understand, if you don't know the networking and you want to use your existing network, yes, you can do that, or create your own network and deploy the machine in your network. You can also connect your on-premises data center to the AWS so that you can access your data, your machine from the on-premises network. You can connect your machine over the internet from the, like you're accessing your web server, it's supported all one. When you create your machine, you deploy your machine into your own network, your machine will automatically take one of the IP address of your network. Please remember, when you're creating your network, usually we create the network with the private IP address. Okay, anyone, what is the difference between private and public IP address?
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
In simple word, if I say private IP are non-routable IPs. Non-routable IP means you cannot route over the internet. Public IP is routable IPs. With respect to the AWS, by default, when you're creating a machine, you always get the IP address of your network. And usually we use the private IP of your network into the network, your AWS one. Your machine always get the private IP and you can access only within the network one. But sometime I want to access over the internet, like I deploy my web server, I want to access over the internet. And I want to access over the internet, then you can get the public IP. Public IP are two types, or IPs are two types, dynamic or static. Dynamic, if you stop the machine, your IP address gets changed. Static, your IP will remain the same. In AWS, elastic IP is static IP, and public IP is your normal IP, which is a dynamic one. And you stop the machine, your IP gets changed. Public IP is, dynamic IP is free, elastic IP is chargeable. So when you deploy the instance, if I want to access over the internet, you need a public IP. And based on the business need, you need a static or dynamic. If your application is critical that you cannot allow that IP should be changed, it will impact your application, go for elastic IP. Static IP, else go for dynamic IP. If you change it, it will change. It will not overall impacting your services. Then a good option with respect to the public IP or private IP one. So remember it. Now, with respect to the AWS, or with respect to the any cloud services, all services of any cloud services is by default internet facing. Remember what I'm saying. By default, all the AWS services or any cloud services are internet facing. It means it will always facing to the internet. If everything is facing to the internet, it is more prone to attack. If it is more prone to attack, your first job is to secure it. And with respect to the EC2 machine, you need to secure it by using the security group. Security group is a virtual firewall which running at the VM level, using which you can define which traffic should allowed in, which traffic should allowed out. Which traffic should allowed in, which traffic should allowed out. And with respect to your security group, you can block your ports. If assume I have a web server running here, web server running on which port number? So if you install the SSL/TLS certificate, that becomes a 443, which use a HTTPS, or it is a HTTP. So whatever the port you want, you need to open it manually, explicitly. So if assume I deploy the web server, open the port 80. If you want this is a Windows machine, you want to connect the Windows machine on RDP, open the port 3389. If you want to connect your machine onto the Linux, you need to connect via SSH, open the port 22, and so on. So security group is a service using which you can open your port to protect your machine and open the respective port, whatever you want. You define the range, which ID you want to open the port, port range, port IP address, and you can also define from where it should be allowed to access. You can say that it should be accessible by anyone. Anyone means anyone can access it. Yes, I can do that. So I want it will be open access by anyone, or I want it should be my machine can be only accessed by this IP address. So you can protect it all. So say that my machine can be only accessed by my corporate IP address. If any traffic is coming from this IP address, then it should be allowed to access my machine, or anyone can access the machine. I can do that. Everything is possible with respect to the security group. Security group can be, same security group can be associated to the multiple VMs or single VM. You can update it, add it, remove it, delete it, whatever you want, you can do it. Your security group at the time of creating a machine or after creating a machine, you can do everything. So you can secure your security group and restrict your access to the instances via who can access your machine one. Now let's take one more example. And let's understand what we are talking about here. One of the various good options for securing your environment, control access. Let's assume these are my machine. These are my web server. I have created one security group, and I have an ID, I have a port number, and source. So three things to define. So this security group I created, security group ID is security group 123, port number 80, source is anywhere. It means now this machine can be accessed by anyone. Anyone can access it, correct? Okay, fine. All good. I created one my app server. I created my security group to the app server. The security group ID is SG456. Port number is 80. But in the source, what I did, I added the security group ID 123. I have not put any IP address. I have not put any open to anyone. What I did, security group 123. Anyone, what do you think what I did? What does it mean? This concept is called service chaining, fencing. What I'm doing, I'm saying this machine can be only accessed by whoever who's sending the traffic via the security group 123. It means, in other words, simple word, my app server can be only accessed by my web server. Because when web server is sending the traffic to the app server, that traffic will be eventually flow from the security group 123. So the source of the security group become 123. And this source app is saying that any traffic which is coming from 123 will be allowed. It means this will be allowed by the web server 1. This is another way of creating a controlled traffic, secure environment. And assume I have a database server, DB security group, which have a security group of 789, port 3306, SG 456. I again create a control access. My web server can be only accessed by the DB. This concept we use to create a fencing or service chaining to create a security from that one layer can only access by the another layer can be only accessed by the another layer. This is another way how you can create a secure environment in AWS using the security group. So security group will allow that you can access it. If you say security group source any, means anyone can access it. If you say 1.2.3.4 IP address, it can be accessed only by 123.4 IP address. And other method is you can put the security group ID, and then it will be only accessed by the traffic which is flowing by the security group 123. Yeah, go ahead, Arvind, go ahead. Okay, clear everyone? Got it? Anyone have a question? So restricting access by the IP, port I range, or resource ID one, right? Clear? Anyone have a question? So from the security group, that's what we talk about. Same thing example here. You can see that allow HTTP port from port 80 from source 0.0.0.0/0. 0.0.0.0/0 means from anywhere. Or you can also define the source as IP address, or you can also define the source as the security group ID. So you can allow that specific traffic will be allowed, and you can simply access it from anywhere. One. Another concept, instance profile, which we discussed earlier. You can attach your IAM role to your EC2 instance profile. Another way of assigning your permission, instead of storing your keys and secret key, you can also execute your CLI command without entering your keys. You can use the instance profile, which we have discussed earlier. So you can use an instance profile. You can, instead of one way to create as access keys, assign that access keys, and change, rotate your access keys, means you can, in case you want that it can be misused, keep changing your access keys on regular basis. But that is not a preferred one. Best option, use the instance profile or role, so that without using your credentials, you can access or manage your resources using the instance profile one. And good option, you can eventually use it. Something like this one, my instance want to gain an access to the S3 bucket. I want to create a policy. The policy will be assigned to the role. Role can be attached to the instance, and eventually your EC2 can have a full access to your user, what you call S3 bucket. So you have all the option which you can eventually use it. So another concept is called user data. Now, remember, let's assume I created a VM. I want to execute my code, or I want to install my script. I want to execute my script. To execute my script, what I need to do? After the machine get created, I log into the machine. I execute my script manually. I don't want. I want that. Can I get some option? So at the time of creating a VM, when I'm creating a VM, when I'm creating a VM, I want to pass my script so that AWS will create the VM, then execute my script and ready my server. I don't want to do anything manually. I want all the things automated. In that case, we use user data. User data is used to execute your script without, execute the script at the time of machine creation. We also call this concept bootstrapping. For Linux, we use shell script. For Windows, we can use Windows batch or PowerShell script. For Linux, we can use shell script one. And by default, when you pass it in AWS, there is a cloud is a service which is running on EC2 instance, and your EC2 launch service which is running on AWS Windows machine, which will execute this script. But remember, so with respect to the user data, you can only pass at the time of creating a machine. Question for you. It means I can execute the script while creating a machine, and I can also execute the machine script from the system manager. run command. What is the difference between these two? What is the difference between system manager run command and what is different between EC2 user data? So remember, user data can be only used at the time of launching an instance. That's why we also call it the bootstrapping. You cannot use it later on. If you want to execute your script later on, use system manager run command. So there's two difference from the run command aspect and user data aspect. If you want to do it later on, that's not a limitation. Use the system manager and use your user data also. So you can use a Linux shell script, write your command into the Linux for your shell way, execute your script. Linux will always start from your exclamation mark, hash exclamation mark /bin /bash. Bash means you're communicating that you want to execute in the bash format. Or you can also use cloud config. For the Linux environment, you can use shell script or cloud config. Cloud config, or we also call a cloud init. For the Windows one, you can write the script in the form of the batch file or PowerShell script. If you want to use a PowerShell script, always start with the slash within a bracket PowerShell and with the within a bracket / PowerShell or script or / script. So you have to define your start and end point of the script. For the Linux one, you need to just define your exclamation mark /bash. So there's a two ways you can use to execute your script and manage your resources. One, now assume you already log into the machine and you want to execute your script based on some input of your machine. So I have a one script and I want to create that script that this script can be executed on all the machine, whether it is a Linux and Windows, and I don't want to create a two different script for Linux and Windows. So I want to create a script which have a two section. If it is a Linux machine, execute this part. If this is a Windows machine, execute this part. And I don't want to say that, okay, let's put a Linux machine differently and Windows machine differently. I don't want. But the problem is how your machine script knows that where it should execute, that machine is Linux machine or Windows machine. It means you need to, when you're writing a script, you should tell them, but if it is a Linux machine, then execute this part. If it is a Windows script, then use the Windows part. In simple word, what I want to extract some information after logging into the machine, which includes what is the instance type, what is my public IP address, what is my OS. This we can achieve by the metadata. Metadata is a service using which you can get the basic description of the machine from the machine itself. You don't need to go to the console and use it. Basically, we use for creating a script one. Sometime I want to execute the script based on certain conditions, like which I just explained. So you can query your instance metadata, get your desired results, and then execute a script accordingly. So instance metadata is a way using which you can get your instance detail, and you need to use, if you want to use it from the Explorer, right? http://169.254.169.254. 169.254 is always point to the local machine, and it will get the metadata like instance ID, public IP, private IP, whatever you want, you can do that. Or you can also execute from the command line using the curl command one. So you have all the option, and using which you can eventually get the local information of the machine and execute it from your machine one, and you can use it for your environment one. So while creating a script, see, let us assume I want to execute the script. I want to create a script, but I want this script should be based on certain condition. So I want that if my machine have a Linux machine, I'm giving another same example again. Assume that I have one script which have a two part A, part B. I don't want to create two scripts, but I want to create one master script, and I want to execute all the 100 machines. But the problem is how you can differentiate that machine is OS or Windows, sorry, Linux or Windows. It means programmatically you want to get to know whether the machine is Linux or Windows, yes or no. Correct? Your script should know that machine is OS, Windows or Linux one. If it is OS, execute the part A. If it is Windows, execute the part B. Correct? Yes or no? This is clear? This point is clear? Right. Yes, so yes. It means programmatically you want to access to know the machine details. Either you can write your own script to know the OS one, Other option is you can use your what you called instance metadata, and using the instance metadata, you can get the machine information. Like I just give you host name, your OS1, but you can do it on the different aspect also. Like I want that if my machine IP, if I have a two aspect, if my host name is A, then execute the script, otherwise not. I can also do that. But how I can extract the host name? One way you can use your own script. Other option is you can use instance metadata. In AWS provide you using the instance metadata, you can extract programmatically all details for conditional input and you can execute it. So you can query your details of the instance from the machine itself. All this information is already available from your console, but I don't want to use a console. Rather, I want to log into the machine and I want to extract that information to execute my information. That is we called a instance metadata 1. Clear? So now when you're creating a machine, you define your image, you define your type, you define your security group. Now you can also define you require a key pair. The key pair is your cryptographic keys. Remember what I'm saying. In AWS, when you're creating a machine, you need to create a machine when you're creating it first time when you launch. It is mandatory that first time when you launch, you should use the key pair. Key pair have a two section: public key, private key. Because it is part of the same series, if two keys match, you are allowed to access. So when you're creating a VM, when you're creating a key pair, this key pair, the public section of the key pair is keys will be installed on the VM. And the private key pair you should download and keep it with you. Key pair is a regional service, so every region you need to create a separate key pair. But in the same region you can use for the multiple machine, no limitation. Now, if you have you deploy the machine in US and Mumbai, you should create a key pair in Mumbai and US separately. But same key pair, if assume I created a key pair ABC and I want to use for multiple machine, yes, it is allowed. But again, is a regional service. Got it? Clear? It is a regional service, but you can use with the multiple machine. You can create a key pair at the time of creating a machine, or you can create a key pair before that also. Your wish, no limitation. But within the region, you can use with multiple machine. And across the region, of course, you need to create a separate key pair. So your VM is ready. Now I want to connect to the VM. Now remember the two cases. Case 1. For Windows machine, you need to use the key pair to generate the password. So using the key pair, you need to generate the password, and then you can log into the machine using your username and password. Username is fixed administrator, but password you need to generate and log in. For the Linux machine, key pair is a replacement of your password. It means you can just give the username and you don't need to pass the password, because key pair is your replacement of your password. So instead of the password, you are using the key pair in both the one. So two cases. Linux machine, you are using the key pair instead of the password. For Windows machine, you're using the key pair as a generating the password first time. But after that, assume for the Linux case, after that, before that, for Linux case, whenever you need to connect the machine, you always require the key pair, because key pair is your password. You said, boss, I don't want to use a key pair again and again. Can I do differently? Yes. Change the password. Log into the machine and change the password. Change the password. The minute you put the password password, key pair is no more usable. You can connect the machine and use the username and password and connect the machine. Once again, for Linux, it is a replacement of your password. If you just go copy, change the password, you don't require to use the key pair again. No need. For Windows machine, now for the Windows machine, Once you generate the password, then you don't require the key pair. But assume you forget the password. Generate the password which you generated, you forget. Again, use the key pair and then generate the password and connect. But after login, if you change the password, key pair does not needed. And same case, if you forget the password, go to the system manager, connect it and then use it. So key pair used to connect your machine using your Windows or Linux. Windows required to generate the password. Linux, it is used to use instead of your password. And remember, in a Linux, your username is always fixed. For Linux machine, you have a EC2 user. For Ubuntu, you have Ubuntu. For CentOS, you have CentOS. You can also change the username later on. It's totally up to you. So key pair is only needed first time. If you change the password, you don't require it. But if you're creating the scheme using the key pair and you created a 10 machines, you need to generate the password for every machine separately for Windows 1. So remember it, you can generate the one password for one machine and use with all the machine. You need to generate it for every machine, but same key pair can be used multiple times. Clear? Anyone have a question? Okay, so now another way of managing your username, if you add your machine into your own directory service, like Active Directory. By default, AWS does not provide you Active Directory. You can install the Active, create the directory and add into the directory services, use that one. Or you can also integrate your Linux machine to your directory services, which provide you single sign-on. Lots of third-party giving you service, even AWS Active Directory supported. You can also generate the key pair using some third-party software like PuttyGen. You can also generate it from the SSS keygen. You can and store your keygen into your local machine and access it from there. And you can use the instance by generating the password and storing it. Now let's take one case. Let me just tell me one thing. Assume I created a VM. Windows VM, I generated the key pair, use the key pair, I generated the password. Password is, let's say, ABC. I'm assuming. Then from this machine, I created the image. Now this image which I created, from this image, I created the VM. Now I use the key pair to generate the password. Can my machine will be allowed with this generated password or the password which you created earlier and generated one? Which one will be used? When you generated the password previously, image is what? Image which takes off your password. When you create the image, when you created this image include this password you generated. Password will be generated where? Password will be stored here in the machine. Yes or no? Whenever you log in, your password will be stored where? In the VM itself. Yes or no? So when you created a clone, the password is coming from that one or not? When you created the clone, correct.
Yep.
So it means you can only use the previous password. You don't need the new password. And that's why AWS key pair also give you one option. Skip the password. Don't need the key pair. Usually we use it when you create your customized images. Okay. Usually when you're creating a new AWS image, now when you're creating a new image, AWS image, this will use the key pair to use it. Otherwise not. Okay, not clear because this is a pre-configured will be the images is created by the AWS, which is the pre-configured, which will use the key pair and allow to use it and create it. This is one option, but eventually there's a clear this point before I talk about on one more thing. Clear? Eventually there's a one more option in AWS that you don't need a key pair also at the time of creating a machine. You just need to write a script in such a way that at the time of creating a machine, it will skip the pass. It will set the password itself. Yes, possible. So you can write a script that when machine get created, it will set the password, and you eventually does not need the key pair at all. Another option which is very much available, but not by default. So if you have a large environment and you don't want to use a key pair at all, possible at the time of creating a machine, just write a script that it will create a machine, create a username or existing username and set the password. You eventually does not required. This is also possible in AWS. It is not mandatory that without a key pair, your machine cannot be created and connected. No, very much possible. But you write a script, execute the script at the time of creating a machine via the user data. Your machine will create it. Your script will execute it. Your password will be set. Yes, all enjoy. Okay. So remember it. It does not mean yes, only one, but by default, that is a pay. That is a way. So remember, it is not something like, so if you're doing a large environment, possible, very much possible that you can create a machine without a key pair. You don't need a key pair, just set the password for entire environment. Good option. Usually we use into the large environment one. So when you're creating a machine, you can also create a machine using the CLI. You can create a machine, you can define your image. Please remember, every image have the image ID. When you're creating a console, you just need to select the machine. Otherwise, when you're creating from the CLI, you need to select the image ID. And when you're selecting the image ID, you need to define your image ID, instance type, key pair name, security group ID, subnet ID, your instance profile, your user data, your tag, which are like additional information of the machine. And you can also use it and deploy your machine one. So from the machine aspect, that's what we discussed so far. So when you're creating a machine, you need to define your user data, key pair, your tag, security group, AMI, instance type, region, zone.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And your machine can be deployed. Got it? Anyone have a question? So last few slides and then we go for the lab. Okay, so that's what we talk about so far. Now, with respect to the managing an instance, remember when you create a machine, the machine will go into the running state. Machine can go into the stop state or terminated state, multiple state. From the billing aspect, the minute your machine into the running state, your billing will be started. When your machine go to the stop state, billing will be stopped. You can also terminate the machine, delete the machine. You can start the machine, you can restart the machine, you can stop the machine, you can terminate. Terminate means delete. And if you terminate the machine, you cannot recover. Simple. With respect to the machine, if you assign your public IP, which is a dynamic IP, if you stop the machine, your IP will be lost. If you use a static IP, your IP will remain the same. If you use the disk, EBS volume, your data will remain there, no loss. Data will always there. But if you use instance store is a temporary storage. And what is the instance store? We'll talk about detail into the storage, but just remember, instance storage is temporary storage. And this is another type of the storage, but which is coming as a free. But the problem with the instance storage is that if you stop the machine, your data will be lost. Good option, free. So we can use it somewhere. But in simple word, if you stop the machine, your data will be lost. So from the lifecycle point of view, when you're creating a machine will go into the pending state and then running state. The minute it becomes running state, your billing start. If you stop the machine, your billing stop. If you terminate, everything is deleted. No question from that aspect. Dynamic IP will change if you stop the machine. Static will never change. EBS all volume, all the data will remain there. Instance store data will be released or lost if you stop the machine one. So from the machine aspect, you can also use the stop, start, or terminate the machine. You can also do the hibernate. All the machine does not support hibernate, but specific machines support the hibernate. Hibernate means all the data of the machine will be stored into the storage. Like when you do the sleep of your laptop, when you stop the when you just close the lid of the laptop, it becomes hibernate. Same concept. Your data will be stored into the disk. So eventually coming from the disk one. Same concept, but it is not supported by all the machine. It is only supported by the specific machine. And same concept when you go to the hibernate one, no loss. instance storage data will be lost, your public IP, dynamic IP will be released, and you can use it in case you go for a Hibernate one. Good option for hibernation machine one. So with respect to the Hibernate, that's what we talk about it, and you can use it for managing your instances one. So stop, start, reboot. Reboot does not change your public IP address. Remember, reboot does not change your public IP address. Reboot does not lose your instance storage data, because reboot and stop is different. Stop means going to the stop state and then you starting. Reboot just touch and then come back. So you can do all the things with respect to the instances one. Physical server. This is a disk, physical server disk. This is a SAN. This is your VM. So the data, the EBS volume is here. When the EBS volume is coming, it is from the network. That's why if you stop the VM, nothing will be lost because data will be here. But if you, the instance store data is disk is coming from here. When you stop the machine, this data lost. But you may say that what is the problem when my machine still have this disk? The data is inside disk only. Why it is lost? Because it is possible in AWS that if you stop the machine, next time your machine will be start from the another physical server, because all are into the farm. So you stop this machine ABC. It is possible that this machine will be start from the another physical server, which is here. If you're starting from another physical server, your network data will be always remain there, but the disk which is coming from the local physical server will not able to map. That's why when you stop the machine, your instance storage data will be lost. Got it now? Clear?
Yes.
Okay, so that's why instance storage is it is coming as a free for a few of the instance, but if you stop the machine, your data will be lost. So this is what we talk about from the instances one. Okay, so with respect to the your instance, AWS allow you to change your instance type. It means if you're creating a machine with the instance type A1, which give you 2 processor, 2 GB RAM, you can change the machine type without losing your data. So assume this is a EC2 instance. A1, you get a 2 processor, 2 GB RAM, and there's a disk. Assume this machine is running with the 90% utilization. Okay, I want to add more storage, more processor. So I want to use my another machine which give me a B1, which give me 4 processor, 4 GB RAM. Fine. In AWS, you can change the machine type, resize the machine. This concept is called resize. Modify the machine configuration. You just go stop the machine. When you stop the machine, your data will be in consistent state. Change from A1 to B1. Change one from A1 to B1. And start the machine. The minute you change from A1 to B1, the same disk will be attached to the another B1. And when you start the machine, you eventually get a 4 processor, 4 GB RAM. Good option. So you can create a machine, change your type, instance type, and but remember, it will only allow with the same architecture, because if you go to the OS, you have in OS you have a ARM or x86 or 32-bit or 64-bit architecture should be same. Then you can change it the machine size from existing to the new one, and your machine is running from the new configuration. You can do the to a machine which is give you more processor or more memory, or a machine which give you the less processor and less memory. Both is supported, no limitation, and eventually you can use it for your machine one. So you have all the machine aspect, and you can use it for managing your machine one. And this is what we talk about with respect to the VM. So from the VM aspect, you can change the instance type. Even disk also can be changed. But remember, disk can be only add. So 1 GB disk is running. You want to make it 2 GB, yes, possible, but you cannot reduce the disk. In AWS, reducing the size of the disk is not allowed, but adding a new storage will be allowed without stopping a VM. You can do on fly. So add the disk, upgrade the disk, remove the disk, all except the root one. You can do into AWS. You can resize the machines, the disk also. All are possible with respect to the AWS one, right? So that's what we talk about. And with respect to the EC2 instance, you can eventually use it for managing your resources and create your EC2 instance, manage your EC2 instance. That all we can do with respect to the AWS one, right? Anyone have a question? Please go ahead. Clear? Now, from the security aspect, remember, security is a mixed responsibility, shared responsibility. Now, what do you mean by the shared responsibility? It means you are responsible for your area of resources. AWS is responsible for their own area of the resources. So you both are responsible for their own area of the resources. One, if assume you created the machine and open all the port. If you created the machine and open all the port, then your machine can be hacked. Who's responsible? You or AWS? You are responsible. If you created the machine, your data, you have not secured your data. And if your data is not secure and your machine is misused, who's responsible? You or AWS? Someone enter into the AWS data center and steal your data. Who's responsible? You or AWS? So remember, everyone is responsible for their own area. That's why in AWS, security is a shared responsibility. Everyone is responsible for their own area. So you are responsible for your data protection. You are responsible for who can access your machine or resources. You are responsible for keeping your firewall configuration. You're responsible for encrypting your data. You're responsible for who can access your machine, which port should be open, encryption, storage, security, everything your responsibility. But anything related to the AWS foundational services, their data center, physical server, which they are managing it, responsible by the AWS one. So from the instance point of view, remember all these aspects and ensure that you are responsible. You should know what you are responsible and what you are not responsible before you're talking to the customer and raising any case. So you should know what is you are doing and what is AWS one. So from your service point of view, you are responsible. From AWS point of view, AWS is responsible one, right? Pricing, multiple ways of paying in AWS. One is on-demand instances, pay-as-you-go model. Good option. For Ubuntu machine and Linux machine, you can pay by per second. But per second means minimum is 1 minute period you need to pay. 50 seconds you can use, pay for 1 minute. 90 seconds you use, pay for 2 minutes. So it's a per second, but minimum billing is 1 minute. For rest of the machine, you need to pay for per hour. If you use the machine for 50 minutes, pay for 1 hour. If you use the machine for 5 minutes, pay for 1 hour. If you use the machine for 1 minute, pay for 1 hour. So remember it. But good option. For immediate need, I need a machine for few hours, for few days, for few weeks, go for on-demand instances. In case I want to go for longer period, I say, why I want a machine for 1 year. Why don't AWS give me a good discount? Because I'm giving a committed business to the AWS for 1 year. Fine, good. AWS say, fine, go ahead and use it. I give you almost 70% to 80% discount if you're creating a machine for at least minimum for 1 year or 3 years. But remember, if you create a machine for 1 year or 3 years, and after a few months or few days or few weeks, you say that, hey, AWS, I don't want this machine. Can you take it back? No. You cannot return the machine. You cannot return the machine. You can either go and sell the machine into the market by become a seller in AWS, in a marketplace, sell the machine, or you can use this machine into the different account, which is part of your AWS organization. In AWS organization, remember, we say that multiple account will be part of it. If you have a multiple account, which is part of the AWS organization, then you can allow that other account will use your reserve instances, otherwise not. You can buy the machine 3 types, all per month, all upfront, 50 per month, or 50 partial per month or partial upfront. Pricing will change accordingly. You have a multiple option to buy. A part of the reserve instance, there's one more machine that's called spot instances. Spot instances are a specific type of the machine, which is an unutilized machine. In any point of the time, AWS does not able to sell all the machine. Then what they do, they start offering this machine in the spot category with almost 90% discount. They're offering you this machine because they are not able to sell it. But what they say, boss, if I get the customer, I will take this machine back and I can sell into the normal price. And to take this machine back, they give you 30-second notice period. 2-minute notice period. It means if you buy this machine almost with 90% discount, but any point of time, if AWS needs this machine, they give you 2-minute notice period and terminate the machine. And this 2-minute, okay. So 2-minute notice period can happen today, tomorrow, after a day, after 6 days, after 1 week, 1 month, you don't know. The maximum to maximum you can block the machine for 6 hours. That is maximum you can do. Means after 6 hours, this machine get terminated. Or you can say that, okay, I'm okay whenever machine get terminated. I'm okay with that. 2 minutes is good enough for me. And I'm using for non-production machine. I'm using for learning purpose or development purpose. I am good option. So go for a spot instances. Good option. 90% discounted it, but with the problem that it will be terminated. You can use this machine. A part of it, AWS also support your dedicated host and dedicated instance to manage your compliance need. The dedicated instance means I need that my all virtual machines running from the specific piece of the hardware or any specific piece of the hardware will be only used by me. Two different options. So I want a dedicated instance. When you create a dedicated instance, AWS will ensure that on whichever physical server, you don't know which one, whichever physical server your VM is created, either all the VMs from that physical server will be assigned to you, or if you use only one machine, then 3 machine AWS keep into the stop state and not will assign to anyone. Of course, the charge is very high, but yes, possible for meeting our compliance. But you don't know from, you cannot see anything. You can still just see the virtual machine and you are assuming that AWS has given you this machine, which is running onto the specific piece of the hardware where only your machine is running. No one else machine is running. If I create one more machine, again, it will be running from the same piece of the hardware. Sometimes you have a more stringent compliance. If you have more stringent compliance, then you can go for dedicated host. The only difference between dedicated host and dedicated instance that in a dedicated host, you can control your physical server and you can eventually see, oh, yes, this is a physical server. This 4 machine is you. It is your, one is running, one is not running, just from the more stringent control. So one, you are assuming, one, you are seeing. So you can also go for dedicated host and dedicated instance to manage your resources. One. Dedicated host and dedicated instance will also allow to bring your own software, bring your own license, BOIL. If you already have a license, you said, AWS, don't charge me. I already have a Windows license or SQL license, other one. Go for a dedicated host or few types of the dedicated instance which support your bring your own license and which you can eventually use for managing your VM1. So pricing aspect, smaller need, shorter need, go for on demand. Longer need, at least year and above, reserve instance. You want to use for temporary purpose, testing purpose, learning purpose, development purpose, where if your machine get terminated will not impact your application or your task, go for spot instances. To meet your compliance need, go for dedicated instance or dedicated host. This is what we talk about so far in this module. And from the what we have discussed so far, what is the concept of the computing, EC2, type of the instance, images, key pair, security group, your public and private IP address, your pricing, your resize, and so on. That what we talk about so far in this module 1. Okay, anyone have a question? Clear, everyone? So if you see here, there's a two, even I have a 2 disk 1 GB, which is not used by it. The green signal, blue signal show that it is not attached to anyone. It is just, I keep it as it is. Okay. Yes, all possible, no limitation. Okay.
Okay, good.
Okay, so before we go to the demo, anyone have a question? Please go ahead. Okay, so let's go to the instance. Search for EC2 region. Select the region and click on the launch an instance. Go to the left side instance. Launch the instance. You can see all the images are. These are AWS pre-built images. You see all these images are there. Linux 2, Red Hat, SUSE, Ubuntu, Windows. Some images are coming with the Windows plus SQL Server and so on. You can also go to the marketplace and see the images which is offered by the third-party companies like Trend Micro, Juniper, Barracuda, OpenSea, Splunk, lots of. You can buy the images from here also. You can go to the community AMIs and also buy the image from community. Few images are chargeable, few are free, depends. When you create your own image, this image is shown under the AMI. So when you're creating a machine, you can select your own image. But let's go and create a image one. Let me create a Windows machine. Let me select the 2019 base. I'm using 2019 just for this demo purpose. And remember, you can also see the AMI ID. When you're creating a machine from the CLI, you require the AMI ID. Images can be x86 or ARM architecture, depends. So which processor you are using, ARM base or x86 or 64-bit or 32-bit, so depends. But I'm fine. I'm just going to click on 2019 base, selecting my image. The second thing, you need to select your resource. So you see here, type of the instance T2 micro. T2 micro give you one processor, 1 GB RAM. Now, if you see here instance storage means wherever you're seeing EBS only, it means this machine does not give you the temporary storage, instance storage. But if you go below, you can see the few machine where you can see the size of the instance storage. Yes, you can see here. This machine showing you 1 into 50 SSD. It means it gives you one disk of 50 GB SSD as a instance storage, but it is coming as a free. So you can see all the instance storage which is showing you. Wherever is EBS, no instance storage. Wherever is size, you can see that. And you can see all the machines, processor and memory, whatever you want, you can select it based on the processor and memory you want. For this aspect, I just need a T2 micro, which give me one processor, 1 GB RAM, which is good enough. Go to the next. Define your how many instances you want, 1 or 10. You should deploy into your VPC. Which VPC, which network you want to deploy. You can have a default one or you can create your own one, depends. Which zone you need to deploy? Under the subnet, you can select the zone. 1A, 1B, 1C, 1D. Because North Virginia give me 6 zones, you can see the 6 zones here. If you don't select the zone, it will automatically deploy into your default zone, any zone. Else you can select the zone. I don't want, I just put the default one. You can select your role from here. You can also copy your script from here, user data script. I just keeping as it is, everything as it is. I don't want anything else. I go to the storage. By default, when you're creating a VM, the root volume for the Windows will be 30 GB. Root volume for the Windows for Linux is 8 GB. Root volume for Red Hat, Ubuntu, CentOS is a 10 GB minimum. And what is the other volume type I'll talk about later on, and you can see it. Now, remember, when you terminate the machine, your disk is also terminated. Someone asked this question. If you remove this option, when you terminate the machine, your disk will not be terminated. Disk will remain with you. Your data remain with you. So if you uncheck it, your machine get terminated, but disk will remain with you. Else you can check it so that machine get terminated, your disk will be also deleted. So fine. Tag is a metadata for managing purpose. So I want to create a machine. I define my type. So sorry, I just put the name. Let's say demo win VM. I want, let's say department. Let's say HRMS. I want a cost center. So just for the management purpose, you can put everything, whatever you want. I just want to keep a name, nothing more than that. And click on security group. Security group, virtual firewall. You can create a security group, give the name, description, whatever you want. By default, when you're creating a Linux machine, it knows that you need to open the port 22. For Windows machine, it knows that you need to open the port 3389. That's why it automatically show you the port 3389. Custom, you to define which IP address your machine should be allowed to access. Anywhere, anyone can access it. Custom or anywhere. In anywhere 0.0./0 and custom 0.0.0/0 both are same thing. This both are same thing. 0 means anywhere. So put custom with the 0.0.0/0 or you put anywhere, both are same thing. My IP is your public IP, your local public IP from you're creating this machine. I want anywhere, fine. If you want to add more port, drop down, select whatever the port you want, like a HTTP. You can also add the rule later on, no limitation. So I just keep it a 3389. I go. You can see all the details here. Launch the instance. Now here you can create a key pair. Proceed without a key pair. I explain you why you can go for proceed without a key pair. Create a new key pair and create an existing key pair. If you create a new key pair, fine, create a new key pair. If you already have a key pair, use that one, your wish. And if you're creating a new key pair, ensure that your private key will be, keep it secure with your local machine one. So choose an I can use existing key pair because I already have. So when my machine get launched, then I click on the view instances, or you can directly go to the instances and you can see the machine one. Now, when you see here the machine, which is showing you the initially your instance state, your machine of the name of the machine, your ID, instance state show you pending. After the pending, machine becomes running. After the machine get running, then AWS performs certain check. That's called pre-checklist or post-checklist. Before you handing over the server to the customer, you perform multiple tasks. That machine is healthy in all aspect. That's why after machine get running, it will perform the status check. The status check will show you that it will check the health of the physical server and check of the virtual machine. If both is healthy, then it will say that, okay, go ahead and use it. If anyone is unhealthy, it will say that unhealthy and you might to terminate the machine and create a new one. So if you go below, you can see the status check, system check, and instance check. It is initializing. We need to wait unless become a 2x2 check pass. So you can also go. So we'll wait. You can also see the zone where it is running. You can also see the public IP address. You can go below, click on the details to see the machine public IP address. You can also go to the security group, see the security group. You can also see which port you have open. You can also click on the security group to open the additional port later on. And you can click on the edit inbound rule to add the additional rule. Fine. Now, if you see here, you're seeing the two rules. One is for 0.0.0/0 and one is :/0. :/0 is for IPv6. This for IPv4. So don't get confused. One is for IPv4, one for IPv6, because AWS support both IPv4 and IPv6 one. So machine get created, is launching, and you can also see all the details of the machine and perform it. Now, when your machine will be launched, then you need to eventually go to the action, go to the security and get Windows password, because it's the Linux Windows machine. So he's saying that wait for launch to be complete before you are allowed to access your password one. So we need to wait for a few minutes before we access your machine. So this is a simple way of connecting your machine and accessing your machine one. Now remember two things for the Linux one. To connect to the Linux machine, you need to connect via SSH, and you need to create a key pair. The key pair which you download is a PEM file. The file which you download is a private key. Will the extension of name is PEM file. So if you are using a Linux and Mac, connect your machine using SSH. Provide the path where you store the PEM, then your username of the machine, @ of your IP address. Fine, your machine get connected. But if you're connecting your machine from the putty, remember putty is a machine. Look, more people are using the putty to connect the machine from the Windows. You can also use Mobi. But if you're using a putty, the problem with the putty software, that putty software does not recognize the PEM file. This is not related to the AWS. This is related to the putty software. If I want to connect the machine via the putty software, because it does not recognize the PEM file, we need to convert into the PPK. And then we can connect the machine from the putty. And to convert the PPK file, we can use the software known as PuttyGen. PuttyGen. So PuttyGen is a software using which you can convert your PEM file to the PPK if you want to connect your machine via the putty. Else you can use some third-party software like MobiWik, some new software, which one you can use with the PEM one, or you can use whatever you want. But remember, from the putty aspect, if you want to connect the machine, you require the convert it to the PPK and then you can use it. So, okay, my check pass is done. Security, get Windows password. Okay, select my key pair, PEM file, click decrypt password. This is my password. Okay, so all good. I copy this password into the notepad. I know my username fine. I close it. I copy my public IP. I open my RDP. Copy my public IP. Username and password I need to provide. That's all. I connect it to the VM. Now you can do whatever you want. And this is the simplest way how to create a machine and logging the machine into the AWS one. And you can do exactly the same thing what you're doing on premises. So this is what we talk about from the EC2 instance aspect, and creating your EC2 instance, Windows, Linux, whatever you want, right? Anyone have a question so far? Okay. See, by default, T2 Micro give you 750 hours per month free. And EBS will be 5 GB, 30 GB storage is, 10 GB storage is free. And if you go beyond it, it will be chargeable. So now remember, when we go into do the lab, expect that you might see some charges at the end of the fifth day. There's expectation. I'm not saying it is completely free. Based on experience, you may get charged for 8 rupees, 10 rupees, 12 rupees, 14 rupees.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And last day, you can also raise a request to AWS that you have doing for learning purpose. They will waive off the charges. No need to worry about it. Or you can also block your account. No worries. So no need to worry from that aspect. Okay, so what we do in this lab, you're creating a Linux instance. You're creating a Linux instance from the console. Then from the Linux instance, you can create a Linux instance again using the CLI. So you're creating a Linux instance from the console and creating a Linux instance from the CLI. Then you are creating a Windows instance from the console and creating another Windows instance from the CLI. Please remember, by default, the AWS CLI libraries by default install into the Amazon Linux. Amazon Linux is a machine image. By default, it is already installed. You don't need to do anything. It is come as part of the image. But Windows 1, you need to install it. So remember. Then in the last, so you're creating a 2 Linux machine, 2 Windows machine, and that 2 Linux machine and Windows machine you need to use in a system manager for various aspects. So using a system manager, you need to generate the inventory. Using a system manager, you need to create the script or document to execute your run command. Using the system manager, you need to connect to the machine like a session manager. You need to creating a system manager, you need to perform your state manager and schedule your command so that your state will remain the same. So using the system manager, you need to perform various options: inventory management, run command, session manager, and state manager, and run it. So when you complete this lab, you are able to understand how to create a Linux and Windows machine from the console as well as CLI. How to use the roles with respect to the instance profile. Please remember, system manager can access your machine via the role. I told you a resource can access the another resource via the role. So you are using all this concept. So you're creating a policy, you're creating a roles, you are creating a Linux and Windows machine, you're using a system manager, because system manager, why we are using in this lab? Because you already created a 4 machine, and using this 4 machine, you are using the system manager one and managing it. You're also using the AWS config for some compliance purpose. This is what all you need to do with respect to the lab 1. Good, everyone who's completed the 1, 2, and moving from lab 2 to 3. Fine, continue. Thank you. So the next topic we are going to talk about your scaling and name is resolution. Basically, we are talking about your load balancer, auto scaling, and Route 53 major topics. So with respect to your infrastructure point of view, the next big topics are load balancing, auto scaling, and Route 53. And then we go for the lab. So from the scaling aspect, the overall scaling aspect is how you can maximum utilize your hardware on premises, and how you can manage your scalability, elasticity. If your load increase, how you can manage it. If your load decrease, how you can manage it. What will happen if my machine get unhealthy? All these aspects we are going to talk about from the scaling point of view. Now, from the integration point of view, the auto scaling usually access via the load balancer. And to access my load balancer, I want to use my own organization name where we use the Route 53. So Route 53 load balancer auto scaling is used together to access your application 1. And let's go and talk about each module one by one. The first one is a load balancer. Anyone have you used any load balancer? If yes, what is the purpose, and which load balancer have you used? So the first question is, what is a load balancer? Let's look into this way. So assume your manager asks you, hey, ensure that your web server should always available. You said, fine. So what you did, you go and deploy the 2 web servers in 2 different zones. So you have web server 1, web server 2 running across the 2 different zones. One is AZ1, one is AZ2. Okay, fine, all good. You said your manager, boss, I deploy the 2 web server. Please go ahead and give the user 2 IP, IP1 and IP2, so that user will try. If one server goes down, he will try with the second server. Manager say, this is rubbish. I cannot ask my user that keep a 2 IP and try one by one. Or if I have a 4 server, I cannot ask them to go and select the server 1 and select the server 2. This server 2 is not accessing, try with that 1, 2, 3, 1, 3, 4. No, that will not workable at all. You need to give some solution. So from the user point of view, he does not care whether you are running a machine 1, 2, 4, 10. Whether you are adding a machine, user should not care. Whether you user removing the machine, user should not care. If your one of the zone goes down, user should not care. If your entire web server goes down, user should not be care. I don't want to impact my user performance. Fine. Then we go and propose a solution that why don't we use a load balancer? Now, load balancer will be a single point of contact from the user point of view. It means user will always send a request to the load balancer. Remember, load balancer is a regional service within the region, but it accommodates all the zones. Fine, all good. So now you deploy the load balancer. User will send the request to the load balancer, and load balancer will eventually distribute the traffic to the 2 servers or 4 servers, how many you have. Load balancer usually distribute the traffic approx equally. It means it will distribute the traffic in such a way that first traffic goes to the server 1, server second to the 2, 3, then 4, then 5, then 6, then 7, 8. They try to balance it. Your problem is solved. So load balancer work above the web server layer, which distribute the traffic. And from the user point of view, you can access it. The load balancer, your traffic always go to the load balancer, and load balancer will distribute the traffic. Assume your load increase from 100 user to you added 200 user. Fine. I will add more instance. My load balance start distributing the traffic to the more additional instance. User does not see whether you are running a 2 machine or 20 machine. Now, if your load increase, you remove the machine. User does not care whether you are running a 2 machine or remove the 2 machine. User will always send the request to the load balancer, and load balancer distribute your traffic to the web servers so that you always get a high availability. Now assume your web server goes down. All the remaining traffic go to the second web server or rest of the server. If your entire zone goes down, all the traffic will goes to the rest of the server or second server. User will always see the high availability from the load balancer aspect 1. This is a simple aspect of load balancer to distribute your traffic across the zones, provide you high availability, give a single point of contact to the user so the user can access your multiple web servers without accessing directly. Rather, the traffic will go via the load balancer 1. Right? This is a simple aspect of load balancer. Anyone have a question? Now, assume by default your session goes to, so when user send first session, it might go to server 1. When user send the second one, it goes to the server 2, right? Let's assume there's a small application running behind this web servers. There's a application running. What this application do, they take the 2 input from the user. They ask, okay, give me the 2 numbers, and this web server will give you the, add the number and give you the result. Simple application. So user give the 2 number, it gives you the result 6. Now by default, the load balancer I told you that is running into the distribute the traffic. When user send the first session, it will go to the first server. It means now user want to add 2 numbers. The first request will go to the server 1. It will give the input 2, but when hit to the second one, the request will go to the server 2. It means the one server have 1 input and another server have a 1 input. This problem will never be resolved in this current case. Then how you can solve this problem, anyone? What you think will be the way to solve this issue? A sticky session. What is sticky session do? It map the one user to one of the server. It basically map the user to the one of the server. So what happened the sticky session? A sticky session will bind the user to one of the server, right? Problem will be solved. So now, now what will happen? User give that input 2. User give the input 4. Both will come to the server. Your problem will be solved. Okay, fine, all good. So the server will have the 2 input, 2 and 4. Problem will be solved. Correct? Problem will be solved. This problem will be solved, yes or no? Session issue, initial session issue problem will be solved. Yes or no? Okay. Let's take the another example. Assume I have application which takes 100 input from the user, 100 input from the user. Fine. I map it. User give 99 sessions, 99 details. After that, server crash. Then what we do? It means now from the load balancer point of view, the next time you hit the session, it will create a session from the new server. New server does not have the session details. It means it's asked the user to perform the job again from the step 1. Oh, bad experience, bad performance. What we need to do now? This is your question, correct? This is the same question you're asking, how to
Correct.
solve this issue. Now, tell me, anyone, how you can solve this problem. When machine crash, session detail also deleted, na? It will be gone along with that server, yes or no?
Yes.
So what you'll do? It means, again, your user need to start the activity from the step one. Bad one, because second machine may also crash. Oh, user will not be able to fulfill his request. What is a better option? Anyone, think as a, just try. What is the other option? Create one more layer. That layer may contain a virtual machine. Usually this is the process we following on premises. Your session detail will be stored into the memory, machine, additional layer of the machine, which usually we do on premises. We create a one server or multiple server in cluster and keep the session detail into the another layer. It means all the session details will be stored here. Now, if this machine crash, you write the logic accordingly that whenever application start accepting the request, it will check any other session detail stored into the machine, means additional layer. If yes, it will get all the 99 user details from here and ask the user to perform the 100th request. Usually in AWS, we don't keep our VM, rather we use our database in high availability mode, like a NoSQL database, which is a DynamoDB we'll talk about later, to store our session details. To solve the session details, you required one more layer. On premises usually use virtual machines. If you see any application on premises running, we add additional VMs. This is a normal practice which follow. But load balancer, we have another AWS, we have another option. We usually use the DynamoDB because the session is stored in the form of the key value. Session will store the information into the key value. So we use DynamoDB where we store the session and our additional layer will be served to solve your problem. Clear? Got your question? Answer?
Yes.
Okay.
Thank you.
So this is a simple aspect, and there's no other aspect with respect to the keeping to the machine, because machine can be crashed. So session details will always keep into the additional layer to solve the problems now, right? Okay. Okay. So this is a simple aspect of the load balancer. So load balancer provide you what? High availability. Load balancer also do some additional things. Now, high availability, if you look into here. So see, so I have a load balancer and I deployed my load balancer. Now tell me which zone you should deploy the load balancer. Which zone you should deploy? Load balancer should be deployed somewhere, na? But it's a regional, but on the thing, it is a zonal service. Let's assume this is a zonal service. So which zone you should deploy? Zone 1 or zone 2, you have only one, either zone 1 or zone 2 or both. What do you think? Okay. So you deploy the load balancer into the zone 1. So load balancer you deploy into the zone 1. Fine. What happens if zone 1 goes down, then load balancer also goes down then? It means load balancer should be across the two different zones, yes or no? VPC is ultimately linked to the zone. How? We'll talk about later on. But load balancer is supposed to be in the zone. So which zone? Both zone? Yes or no? Are you considering this current situation, you need to deploy the load balancer both the zone, yes or no? So remember, load balancer is a zonal service. It is not a regional service. Number 2, what do you mean by the zonal service? By default, when you create the load balancer, on the back end, load balancer will create the 2 load balancers minimum for when you're creating a load balancer. If you select the single zone, remember what I'm saying, at the time of creating a load balancer, if you select the single zone, it will create the 2 load balancer into the same zone. If you create 2 zones, it will create a 2 load balancer across the 2 different zones automatically, but you need to select it. So if you select the load balancer across the 1 zone, it will create 2, but in the same zone, because it will always create a 2, minimum 2. Maximum can be your number of the zone you have. But if you create a 2 load balancer, you select the 2 zones, then you have a 2 zone. It will automatically deploy the 2 load balancer across the zone, and your entire zone goes down. Still, you can access your application from the second zone. If you have a 6 zone, you select the 6 zone, it will deploy 6 and charges will be vary. But remember, the best suggestion is don't select the single zone. Always select the zone 1, zone 2, and deploy the load balance across the 2 different zones for high availability purpose. Now you may have a question. Are we using 2 different IP address or DNS? No. It is an internal mechanism that you always hit to the same load balancer with the IP address or DNS name, and load balancer internally send the request to one of the load balancer, this one or this one, and request will be fulfilled by that particular load balancer. So no need to worry about it. Clear this concept? Got it?
Yes.
Okay. So it means load balancer is also providing the high availability, but you need to configure it and you need to deploy in one of the zone 1. A part of this, load balancer also performs some additional activities, which include health check. Load balancer also check the health of the instance on regular basis. So load balancer will check the health of the instance on regular basis. You can configure that I want to check my health of the instance after 30 seconds, 1 minute, whatever. And load balancer check, hey, are you healthy? Hey, are you healthy? If web server say, yes, I'm healthy, it keeps sending them a traffic. But if any point of time, web server say, no, I'm not healthy. Oh, okay. Then the minute load balancer knows that web server is not healthy, it stops sending all the traffic to that machine and send rest of the traffic to the rest of the machine. This will ensure that user will never see the outages for a longer period. Of course, for few seconds, he may see the outage. Why? Because assume load balancer at 001 minute, system check healthy, and he send the request, because next health check will be after 30 seconds. If you assume you put it, it means if 002 second, machine goes down, for next 29 seconds, it keeps sending them a traffic. So user might see some page not available error. It is very much possible, but you can ensure that after 30 seconds, user might not see the page error pages. So you can reduce the 30 second also. You make it 5 seconds, 10 seconds, up to you, that how want to configure. So you need to configure, and it will check the health of the instances. Health of the instance means health of the your service, Apache service or IIS service, because assume your server is running fine, but services is down. From the load balancer aspect, it is down because our user is accessing your web server. Web services is down. What he will do with the machine? Machine is still up and running. There's no use of it. So best option is check the service. So it will check the web services. If services are up and running, fine, keep sending the traffic. If services goes down, stop sending them a traffic. So it also perform the health check. So high availability, health check. You also need to use a security group, which traffic should be allowed in, which traffic should be allowed out. All these things you need to also configure with the load balancer, and you need to ensure that your load balancer should accept it and then process it accordingly. So you need to open the certain ports. If your web server is running on port 80, open the port 80, port 443. You can also open the port 443, which is a secure one. Now, by default, your traffic between a user. So usually what we do, we place our load balancer and all the web server into our network. So by default, my traffic between user and server is on running HTTP. The load balancer and web server is also on the 80. Okay. I want a secure traffic. I want the traffic should be HTTPS. What I need to do? I want to change my HTTP to S. So you need to install the SSL/TLS certificate on your load balancer and open the port 443 so the user can access the server on HTTP. Now, if you see here, I just installed the certificate into the load balancer end. I have not installed the certificate onto the web server. It means the traffic between user and load balancer is secure, but between a loader and web server is unsecure, which is perfectly fine. Because using the security group, I'll say that my web server can be only accessed by the load balancer. My load balancer and web server is running on my network. I can secure it. It is running onto the AWS data center. I can secure it. I don't need to worry about it. Means only installing the SSL or TLS certificate at my load balancer solve my problem. And when install the SSL TLS certificate on load balancer, my problem will be solved. This concept is called TLS termination. TLS termination means the session, it terminated at the load balancer and rest of the traffic is port 80, which is perfectly fine. But sometime business say, no, I need an end-to-end encryption, end-to-end encryption. In that case, you install the SSL/TLS certificate in each server. So becomes 443 in all end, but this is much more costly because depends what kind of the certificate you're buying, but this is an additional concept. This concept is called SSL termination. So installing the certificate at your load balancer is good enough to make your traffic between user and load balancer secure. Rest of the traffic flowing into the AWS network, that's not a problem, but in still someone business say, no, I need end-to-end encryption. You need to install that certificate on your machines also. This concept is called TLS termination. AWS provide you the three types of the load balancer. Layer 4, layer 7, and layer 3. I'll talk about it. And you can also enable the monitoring and monitor your load balancer 1. Now, as on date, we use 3 types of the load balancer. Application, network, and gateway load balancer. Initially, there was but there's one more load balancer that's called classic load balancer. Classic load balancer, we are not using it. It's a previous generation load balancer. And with respect to the previous generation load balancer, it basically used to support for some limitation. All the additional feature will be available into the your new load balancer 1. So from the load balancer point of view, your you have we have option to select application load balancer or application network and gateway load balancer. Now the major difference between these 3 are application load balancer work at the layer 7 of the OSI layer. Network, you have a 7 layer. Physical layer, data layer, network layer, transport layer, session layer, presentation layer, and application layer, 7 layer. Application load balancer work at the 7th layer of the OSI, which is application layer. Application load balancer, because work at the 7th layer of the OSI, it only support your HTTP and HTTPS. If you are using any application which is running on port 80 or 443, use the application load balancer. Application load balancer can be accessed with your DNS1. So you can access with the DNS name. You can access with the DNS name. And you access your application load balancer. It can be deployed across the zone. You can access with the HTTP or HTTPS running on layer 7, 1. Network load balancer is another load balancer which work at the layer 4. And it support your all the TCP and UDP 1. It means you can access the network load balancer for the application which is running on any port. It supports your TCP and UDP both. Not only that, your network load balancer can also access from your static IP. You can create elastic IP, which is a static IP, and assign to your network load balancer and access with the network load balancer. Because network load balancer support your static IP, it means you can directly access you deploy the 2 load balancer across the 2 zone. You can assign the 2 static IP to the 2 node load balancer, and you can also access it individually. But when you're using it with the application load balancer, it gives you the DNS URL. That DNS will automatically hit internally to the one load balancer, second load balancer automatically. User will never see what is happening on the back end. Request will automatically goes from one server to another server. But from testing purpose, for other purpose, you can use a network load balancer for using the TCP and UDP1. The third type of the load balancer is a gateway load balancer that we also call IP load balancer. Basically, we use to configure with the different application which you can use to support it. A gateway load balancer support your multiple VPC. Application network load balancer supports single VPC, but gateway load balancer support multiple VPC, which may be across the region also. It work on the layer 3, and support your layer 4 capabilities also, but may basically work at the network layer and support your layer 4 capabilities like an application load balancer. So from the load balancer point of view, you have a application network. Mainly we use application and network. The gateway load balancer we use if I want to send the traffic to the additional appliances, IP appliances, which may be my firewall, which can be my some additional appliances or virtual appliances. I can do that. To configure the load balancer, we require the root tables. For rest, we just need a normal configuration one. And eventually you get a 3 load balancer, which we can use for your access one. So from your load balancer point of view, you have all the options. You can use it for your business requirement. You can choose either of it. From the differences, if you compare, all support health check, all support with the CloudWatch, means you can use to monitor your resources. All you can use for logging purpose. Logging means I want to capture the logs, to monitor the logs, all supported. SSL offloading, TLS, SSL offloading and TLS termination is the same concept, which is supported by the application network, and classic load balancer gateway does not support. What is the connection draining?
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Talk about it, but which is only supported by the application load balancer. The static IP address, I told you, it is supported by the network load balancer. You can also use the application load balancer to send the traffic to your Lambda. Lambda is a serverless compute. We'll talk about it, but your load balancer also support your Lambda. And also you can direct the traffic to another endpoint. So I want that when I receive the traffic to the load balancer 1, it should direct the traffic to the load balancer 2. Redirect. Redirect is also supported by your application load balancer 1. So if you look from the usage point of view, you can select either of it. If your application just running on HTTP or HTTPS, go for application load balancer. If your application running on different port than 80 and 443, use the network load balancer. If you want to distribute the traffic across the IPs running across the VPCs, go for gateway load balancer. Or if you want to load balance your traffic to the multiple appliances, virtual appliances, firewall, or anything else, appliance aspect or services aspect, go for a gateway load balancer. Classic load balancer we are not using, and as of date, it's the previous generation. It will be decommissioned soon. So from the load balancer point of view, that's what we discussed so far, right? So with respect to the load balancer, we can eventually use the load balancer and distribute the traffic and support your high availability one. So if you look here from the load balancer point of view, so assume you can have a VPCs, you can deploy the load balancer across the zone, and you can deploy your load balancer in the same zone in a subnet. Subnet is mapped to the zone. So when you're creating a VPC, you create a subnet. Subnet should be attached to the zone, and load balancer can be deployed across the subnet or across the zone also. So your wish, you can use it from the load balancer aspect and access it across the zone also, and distribute the traffic one. So your wish, how you want to use it, totally depends on you, how you want to use it. And when you create a load balancer with the endpoint, if it's a DNS one, you get the DNS name. If you attach with the IP address, it will attach with the IP address, and you can access the load balancer with the respective IP one. Actually, what happen on the back end, AWS will eventually create, remember what I'm saying, AWS will create the network card. Remember, it does not create the complete load balancer install on your network, no, or zone, no. It create the network card. So AWS have a load balancer, but they will extend the load balancer for your requirement by creating a network card. So it create the network card, place the network card in your subnet and zone, which can be accessed by the user. So eventually user hit to the load balancer. Load balancers distribute the traffic based on their network card, and you can access it from the multiple zone one. So user can access with the IP address or DNS name. With the IP address, then you have a limitation. With the DNS one, it is much easier because it is automatically distribute the traffic across the multiple load balancer, and your traffic will be eventually work from that aspect one. Now, with respect to the connection draining, the connection draining is an option which can help you to manage your resources from the load balancer point of view. Let's look into this way. So assume you have a two web server. You have a two web server, and your load balancer is distributing the traffic to the two web server. Okay, all good, fine. So load balancer keeps sending the traffic. Assume you need to perform some maintenance activity. Now, when you need to perform the maintenance activity, you suddenly go and remove this web server or stop the web server. You remove this web server from the load balancer. Then what will happen? Anyone? First of all, my load balancer will only check the health into the next cycle. It means for till the next cycle, it will keep sending them a traffic. Number two, my web server, whomever he need to respond, he will never respond. And user will never get the output. What is the best option? The best option is connection draining. The connection draining is the option which you enabled. Then what will happen when you start removing that web server? Removing the web server from the load balancer is the concept of deregistration. Registration means you adding the load, adding the server to the load balancer. Deregistration means you removing the server from the load balancer. When you performing the deregistration, and when you performing the deregistration, then load balancer do what? Web server do what? It send the request to load balancer. Hey boss, I'm going to offline. Please stop sending me additional traffic. Load balancer know that you are going to offline. It stops sending you traffic. Before you move out of you complete the deregistration, web server ensure that all the requests which he received, he will respond back to the user. So becomes no request will pending with them. And gracefully, it will remove itself from the load balancer. This will ensure that user will never see your page outages issues. But of course, it does not mean that your server crashed. Then what will happen? If server crashed suddenly, then of course, same thing happened, that user may see some page will not be, page error issues, or some requests will never be fulfilled. But at least you can use this option when you're doing a graceful performance management, which include your maintenance or whatever. At least you can remove the instance gracefully so that your request will be processed and user will never face an issue, at least on the case of the maintenance or other aspect one. So from the load balancer point of view, now by default, there's also concept of the load balancing, cross-zone load balancing. Cross-zone load balancing is enabled, which ensures that your traffic should be distributed equally to all the endpoints. Endpoints means machine. Assume 2 server running into the zone 1, 8 server running into the zone 2. If you enable the load balancing, cross-zone load balancing, it will distribute the traffic evenly to all the machine. Means all the machines will almost get the equal number of the request. But in case when load balancing, cross-zone load balancing is not enabled, the request will be distributed based on the zone. It means if your 2 servers running into the zone 1 and 8 servers running into the zone 2, the 50% request will go to the 2 servers, which is 25, but rest of the zone, the request will be hit 6.25 because it equivalent to the 8 server. So you can, based on the business requirement, you can go for it. But suggestion is always go for cross-load zone balancing so that your load will be distributed all the machines across the zone equally. So every server will fulfill your need with the equal number of the percentage. And you can simply use it and manage it from the load balancer point of view. So from the load balancer point of view, you can enable the cross-zone load balancing. You can enable your connection draining. You can enable your sticky sessions, which we earlier discussed, and so far multiple options which you can use to manage and distribute the traffic accordingly. Now, with respect to the load balancer, when you create, you have to create the target group. The load balancer cannot, a server cannot be attached to the load balancer directly. You have to create the target group. So target group is a collection of the load balancer. Target group is a collection of the load balancer. So let's assume this is my load balancer. I want to add 2 machines. I need to create a target group. This target group I should attach to the load balancer. My machine should be deployed into the target group. And my load balancer will automatically distribute the traffic in the 2 machines, 1. Now, why we are creating a target group? Target group give me some additional features. And one of the feature is known as URL-based routing or path-based routing. URL or path-based routing. URL or path-based routing is a feature which is only available into the application load balancer. URL/path-based routing. So let's take an example. I have a company which where I'm providing lots of videos and images to my customer. I have a big company, and I usually lots of users requests come to download the images or my videos. Because I receive lots of requests for video and images, I created 2 separate server for images. These 2 servers only serve the images. And then I created one more set of the servers, which is only meant for videos. So I have 2 servers for videos and images. I keep the 2 servers so that it can be load balanced. In case one server goes down, I can still get a high availability one. Fine. Now, what I want that whenever user write, they go to the browser and let's say they'll write the aws.loadbalancer.com name / your images, the request will hit to the 2 server which is serving for the images. So the minute user will write abc.com/images, then AWS load balancer will automatically route the request to these 2 load balancer. And whenever user write abc.com/video, the request will automatically route to these 2 web servers. Single load balancer distributing your request based on the URL or path which you're defining in your browser one. So if you write your abc.com/images, request will go to the 2 set servers. If user write video request will go to the to set of the server. This concept is called URL or path-based routing, which is only available into the application load balancer. Good option. Another use case, probably you have some application, and for that application, you want to dedicate a server only for the report. So you can say that for normal user, for normal data processing, this should be used. For report, only these two servers are used. I want to distribute because I don't want that report generation will also happen to the same server. User will see the performance issue. So what I'll do, the minute my user will accessing the normal data processing, request will be hit by the two different web servers. The minute user want to generate the report, request will be the two different servers. My performance will be maintained. My application will be maintained. And everything should be good one. You need to write the create a listener. Listener means on the where it will listen, and in the listener you need to send that whenever someone send the request /images send to the target group A or sent to the target group B, and your request will be processed and fulfilled by the load balancer 1. So load balancer is a service using which you can distribute the load. And when you distribute the load, it can provide you a high availability. Load balancer is automatically inbuilt high available because when you create, if you select the multiple zone, it will deploy across the multiple zone. When you're creating a load balancer, you have option to create a network load balancer, application load balancer, or gateway load balancer. Based on the business need, you need to select either of it. We don't use classic load balancer. A part of it, you have multiple features available from the multiple load balancers, which include your connection draining, path-based routing or URL-based routing, cross-load zone balancing, your session persistent or static session, like managing your sessions 1. Load balancer is a paid service, and you need to pay based on your how much data it processes. It is a regional service or maybe across the region, supporting by the gateway load balancer considering the IP address, and you can distribute the traffic and manage it accordingly. This is what we talk about from the load balancer aspect. Anyone have a question? Please go ahead. Yeah, if you want the URL based routing, target group is supporting that aspect, but otherwise the load balancer cannot be added directly to the web servers cannot be added to the load balancer directly. Earlier in a classic load balancer you can do that. In a classic load balancer you can add the VMs directly, but due to some additional features which is based on the group of the server, they introduce the concept of the target group. So target group is like your group of the servers, like your users group, or you put all the folder into the one group and then you configure it. So target group is a logical collection of the server, simple logical collection of the server, where your server should be registered with the load balancer via the target group. It is a via way using which you can add the server to the load balancer 1, right? So it is a target group is nothing but a logical collection of the servers. The target group should be mapped to the load balancer, and when you add the server, instead of directly attaching to the load balancer, you need to map to the target group. Internally, load balancer will distribute the traffic to the multiple VMs, but it should be mapped via the target group. It is nothing but a logical collection of the server, and then it will be automatically attached to the load balancer internally. Got it? Clear? Base routing is within the load balancer only. For redirection means if I have a 2 load balancer, I want to send the target to another one. So I don't want that user know what is happening. So I say that user will always hit the traffic on www.abc.com, which will hit to the load balancer, this one. But on the back end, this load balancer will distribute the load across your, send the redirect to the another load balancer or another endpoint, which may be www.xyz.com. So you are redirecting to outside, to different one. Path-based routing is within your machine, which is mapped directly to the load balancer. Got it? Clear? So From the load balancer aspect, that what we discussed one, and the next topic we are going to talk about your scaling. See, okay, what do you mean by the scaling elasticity with respect to your machines or your application or your load or your user base, whatever, anyone? What is the purpose of scaling elasticity in the context of the AWS or without the context of the AWS, whatever, on premises also, anything, whatever. But what is the basic concept behind it? So before we talk about the auto scaling, there's a two kind of the scaling. That's known as vertical scaling. And what is another one is? Now the difference between vertical and horizontal scaling is, if you have a virtual machine, if the one machine is running with the 90% of the load, then what we can do, we can, and running, assume this machine is running with the 2 processor, 2 GB RAM, then one of the best option is I can add more resources to the VM. Probably I make it 3 by 3. Or assume my load balancer running with the lower utilization, I may reduce the resources, which is 1 by 1. But in simple word, what we are doing a scaling in vertical direction. That's called scale up, scale down. Scale up, scale down, you're adding a resource or reducing a resource from the same VM.
Right.
How you can do the vertical scaling in EC2? How you can you achieve the vertical scaling in EC2? If yes, how? Can you resize the concept using which you can achieve what? Vertical scaling. But vertical scaling need that your machine should be stopped. Of course, there's no other option. But in case I don't want my machine should be stopped, then another option is called horizontal scaling. In a horizontal scaling, we don't stop the VM. Rather, we create a new VM. So assume this machine is running with a 2 processor, 2 GB RAM. I'll create a new VM with the 2 processor, 2 GB RAM. Your load will distributed. So earlier this machine is running with the 90%. Then I create a 2 machine, which will be a 45% each. My problem will be solved. If load increase further, I can add more machines. I add more machines. So what we are doing into the horizontal fashion. When you're adding a more machine, we call a scale. When load decrease, I will start terminating the machine. Then load, this concept is called scale in. Benefit, when load increase, add a VM. User will be happy, performance will be maintained. When load decrease, reduce the VM, save your cost, organization will be happy. So both will be happy. I create the additional machine, add the VM, reduce the VM. I can do everything to maintain my load, maintain my performance, and organization's cost also. Usually, I'm not saying it is mandatory. Usually, we use the auto scaling group with the load balancer, because I told you user does not care whether you're running 1 machine or 10 machine. User always send the request to the load balancer. Load balancer distribute the traffic. So earlier case, you are creating a machine manually. In this case, machine will create it automatically, but load will be automatically distributed across the machine. When you adding it, fine. Removing it, fine. User does not care. But horizontal scaling, usually we use with the load balancer 1. So 2 kind of the load balancer, vertical and horizontal. So what we'll do now from the auto scaling aspect, but before that we were talking about load balancer and we discussed about the load balancer 1. So auto scaling are 2 types, vertical and horizontal scaling. And the benefit of the scaling to manage your demand and manage your cost. So usually, if your capacity, if your demand varies, instead of creating a machine with a higher configuration, why don't you create a machine what is demanded? So based on the peak demand and capacity, we should always ensure. Usually what happen, if you see on the right side of the screen, in November, you have a capacity of 100%, but demand is only 10%. It means you are wasting your money in terms of the cost by just keeping this much of the resources unutilized. Or if it increasing slowly month by month, you're eventually wasting your resources in terms of the cost, and your resources are unutilized. This is what is a normal issue on premises one. So you create a machine, let's assume with the 4 processor, 4 GB RAM, but initially the requirement is only, let's say 0.5 processor and 0.5 GB RAM. So you are wasting your lots of resource initially. Wasting a resource, just not just wasting a resource. Wasting a resource means you are wasting your money also. And that can be achieved by the scaling. So with respect to the scaling, you can create a resource based on the demand. If your load increase, demand increase, add the instance. Demand decrease, reduce the instance. If there's unhealthy instances, remove them. Create a new healthy instances and pay whatever you consume. Simple aspect. So auto scaling is a concept using which you can manage your resources with respect to the manage your demand versus your cost, and you can balance your demand versus cost. You manage your performance versus cost, and your system will automatically launch or terminate based on your configuration or rules. So from the auto scaling aspect, if your load increase, scale out. Load reduce, scale in. Okay. So if your load increase, add the instance. Load decrease, remove the instance. You can also terminate the instance. If any machine is unhealthy, terminate it and create a new one. Simple. So assume you have created a 2 VMs. So you need a 2 VMs. That's fine. You need a 2 VMs. So auto scaling also support one more concept that's called auto healing. Auto healing. So assume I need, I say AWS, hey AWS, I need 2 VMs. Fine, he'd create a 2 VMs and give it to me. And assume due to some issue, this machine crash, or you might stop the VM. So if you say that you ask the AWS, I need 2 VMs, and due to some issue, your 1 VM crash, or you stop the VM, and AWS will see that your VM count is become 1, then it will automatically create a new VM. Okay. So let's assume you ask the AWS, I need a 2 VM. So auto healing is a concept which ensures that your number should always maintain. Let's assume that you say that, okay, I need a 2 VM. So AWS will create a 2 VM and assume your 1 VM crash. Assume you stop the VM. Then AWS will see that initially the number which you ask is a 2, but number is reduced to 1, right? So number reduced to 1. It means the numbers of the VM you ask the AWS to maintain, it is reduced. In such a case, AWS, what they do, if your machine crash, it will launch a new VM and maintain the 2 numbers always. This will ensure that you 2 VMs always running. If you stop the VM in auto scaling, because if you stop the VM, AWS will consider that this VM is crash or not available. The machine which you stop, it will terminate that. This is an inbuilt feature. It will automatically terminate the machine which you stop or crash and launch a new VM to maintain the numbers. This is called auto healing. This will ensure that you don't need to worry about maintaining your numbers. You say that, okay, create a 2 machine across the 2 different zones. If anyone, and due to any issue, one of the machine goes down, it will automatically launch another machine to ensure that your number will be maintained and your machine, you're always distribute the load across the VM. So there's the additional feature which is also supported by the auto scaling. This concept is called auto healing. Clear, everyone? Anyone have a question here? I got it. Backup means image. So when your load increase, add a VM. Load decrease, reduce the VM. CPU reach to 90%, add a VM. CPU reach to 10%, reduce the VM. This is all. So it means you need one more service which should monitor your resources, utilization of the CPU, and so on. That's why auto scaling is tightly integrated with the CloudWatch. AWS CloudWatch is a monitoring tool we'll talk about later on. But CloudWatch is a tool which is needed to maintain your, which is used for monitor your resources like CPU utilization, and then it will trigger to add a VM and reduce the VM. So CloudWatch is a tool which is used along with the auto scaling. It is an inbuilt one. You don't need to do anything. You need to just configure the CloudWatch rule that my CPU reach to 90%, then add a VM, or 40% reduce the VM. You can do all the things with respect to the auto scaling one. When you're creating an auto scaling, the auto scaling can be, you can create it with the dynamic scaling, schedule scaling, or manual scaling. Scaling are multiple types. I'll talk about it. All these scaling one, but scaling are dynamic, schedule, or manual scaling one. So from the scaling aspect, you can eventually use it and manage your scaling and resources one. So first of all, when you're creating an auto scaling, so auto scaling, so the first thing is launch configuration. Now the question comes, let us assume this is a VM is running fine. You initially add a one VM and you say that whenever CPU reach to 90%, add a VM. Okay, absolutely fine, all good. It will add a VM.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Now, how the AWS know which instance type I should select, which security group should be used, which network VM should be deployed, which key pair I should use, which image I should use. How my AWS knows that, which all details we can find. Anyone? How we can do that? How we can provide all the details?
So
in simple word, you are putting all the details in a template. You're putting all the details into the template. So template include, let's say, T2 micro, your Linux AMI, your security group 1, 2, 3, your key pair 1, 2, 3, your VPC 1, 2, 3, and so on. Of course. And when so you can put all the details so that whenever a new machine will create it, it will automatically pick up the details from here, and a new machine get launched. Now, someone asked me this question, where you should keep the data. Now, are we keeping the data into this VM or yes or no? No, not the EBS also. Someone said some separate entity. Absolute. What do you mean by the entity here? Are you saying separate layer or separate disk? Remember, in auto scaling, usually when you launch, when you terminate the instance, we are terminating the machine as well as disk both. Usually. It means you required to keep the data. The data should be separate of this layer. So where you can keep the data in that case? Where the data you should keep. The data should be persistent, always remain. If you terminate the VM and create the new VM, it will not impact the data. So where the data should be?
Yeah, on this AWS disk.
AWS will terminate na. Generally we terminate. You have one more option. You go into the right direction, but say something different. One more option. Think. Two options. we have an option. Now that option is, one option, you can create a shared storage. Shared storage. Your data will remain to the shared storage. Option number one. And whenever machine can create, it will always access the data from the shared storage. Your operating system, your disk, OS disk will only, operating machine disk will only contain your operating system and application, not the data. So the data usually we keep into the shared storage, or the data we keep into the database. You can maintain the data into the disk, but mapping the disk to the new VM, it's always a more complex way. It is not an ideal situation. To solve this issue, what you need to do, create into the new layer. That layer is a shared storage, we'll talk about later on, or database, we'll talk about later on. But these are two ways where you can keep all the data which is persistent, which will not impact when machine created or deleted. Machine deleted, fine. New machine created, it will access the data from the shared storage or database. You always get the data. Got it now? Clear? Okay. EBS is a one-to-one mapping. That's why we don't use it. We have another option that's called EFS, which is shared to the multiple VM so that you can perform the read and write operation. Got it? Now, question. So my new machine created, my operating system deployed. Okay, I am happy. You are happy. Everyone is happy. Are you going to deploy your application manually, or you do something different? How you can deploy the application? A Linux machine installed or Windows machine installed. How you can install the application code? How you can install your Apache or IIS or code? Are you, after creating a machine, you can log in and then do it, or you can do something automated way? So custom image is one option. User data is another option. You can use either of it. The difference is, create a custom image. In your image, use the custom image. Else, use the user data. Both the option is correct. Machine get created, application will be deployed by user data. If it is a custom image, machine can be created with the user, with the customized image, which include your OS plus your application. So you have both the option. You can use either of it and ensure that your environment should be created. With respect to the template, there's a two options. You can use template plus launch configuration. Launch configuration is a way which you're using it along with the your auto scaling. Template is also same concept, but versioning and some additional feature is available into the template. So now AWS also support your template, but both are the same concept. Just from the versioning point of view or managing point of view, small difference. Otherwise, both are same. So launch configuration oblique template support your, provide your details via instance type, security group, key pair, AMI, customize ID, your user data, and so on. So whenever a new machine get created, it will get all the details from your machine one. Even you can map your roles, your all the details with respect to the launch configuration one. Now, when you're creating a group machine, you have to also define your numbers, minimum, maximum, and desired number. Minimum, maximum, desired number will provide you the detail that what is my, you are putting a limit. You don't want that machine get created. It goes on. I don't want to pay so much of the cost. So we put a limit. Limit is your numbers. So what you do, you put a minimum number, a maximum number, and desired number. So you say that even your utilization is 0%, keep one VMs running. Yes, I can do that. You say that if I have a maximum number is 10, I say that even all the 10 machines have 100% utilized, but don't goes beyond 10 machine, because I cannot pay more than 10. I don't have a pocket sufficient budget to go beyond 10. So you can define your minimum number and maximum number. It means when scaling happen, it goes between your 1 to 10. Never always remain 1, maximum 10 be 10, and it will remain within the 1. So you say that whatever situation, don't go beyond it. The other situation is desired, and desired is the same thing which I just talked it with respect to your auto healing. So if you desire 2, it will ensure that 2 VMs always running. If your 1 is crashed, but if scaling happen, desired in normal case always remain 2, but if scaling happened, in a scaling it never goes beyond 1, It never goes beyond 10, and you always maintain a number. You can also integrate with the load balancer so that whenever VM get added, it will add into the load balancer. You can also distribute the machine across the zone. So AWS will create the machine but distribute across the zone. So machine first go to the zone 1, second goes to the zone 2, zone 1, zone 2. This will ensure that numbers will be maintained across the zone 1, and you can ensure that your numbers will be maintained across the zone 1. From the scaling policy aspect, now you can define the various scaling policies. Scaling policies will be happen in multiple ways. Auto scaling or dynamic scaling, schedule scaling, and manual scaling. There's one more scaling that we call a predictive scaling. Predictive scaling one. Let's look into this way. Number one is dynamic scaling or your auto scaling. Dynamic scaling and auto scaling we use when you don't know when the load increase or decrease. You cannot predict as a dev, as an application architect or as a infrastructure guy. You cannot know when the load increase because your load is very, it is not, it is very, it's cyclic. Sometimes something, but you cannot predict. Sometime your load may increase into the midnight, sometime morning, sometime after 1 week. You don't know at all. When you cannot predict when the load increase, and you cannot predict when the load increase, how much VM I need to manage that load. If you don't know these two things, when and how many VMs I needed, if you don't know these two things, go for dynamic scaling. In a dynamic scaling, you create a rule that if my load goes beyond 70%, add 1 VM. If load goes beyond 90%, add 2 VM. So when load increase, add a VM. Maintain your performance. When you don't know, whenever load increase, your add a VM. Or same way, you can also say that if my load decrease goes beyond 40%, reduce 1 VM. If less than 20%, reduce 2 VM. You create a rule. And whenever load increase, add a VM, load decrease, reduce the VM. Maintain your machine, maintain your performance, reduce the VM, maintain your costs. But usually the dynamic scaling when only use when as an organization, as an architect, you cannot know when the additional user come, when additional performance, my performance will be hit. I don't know. There's another kind of the scaling that's called schedule scaling. Schedule scaling we do when I know both of this. Both of these two, you know when the load comes. You also know that when load comes, how many VMs I needed to manage the load. If these two details you have, use the schedule scaling. Like, assume you have a HRMS application, and your HRMS application for whole month you need a 1 VM, which is a good enough for you. But every 25th of the month, your HR team generate the report. And the minute they generate the report, so they start generation the report at 9 a.m. and the report generation end at the 6 p.m. Usually what happens whenever they generate the report, your user will start crying. Performance hit, performance hit. As an architect, you very well know that if I create a 1 VM during this period, my problem will be solved. It means if I have one more VM on every 25th of the month between 9 to 6 p.m., my problem will be solved, my load will be distributed, all the things will be good. I am happy, your user is happy, report will also generated. Then we go for schedule scaling. You can write that every 25th of the month, 9 a.m., add 1 VM. So your VM becomes 2. 6 p.m., reduce 1 VM. Your VM becomes 1. So maintain the load, manage your performance, reduce your cost. This is what we call a schedule scaling. The other scaling is called a manual scaling. Manual scaling, you are changing the number manually just for testing purpose. You keep the number 2 VMs created. You change from 2 to 3, 1 more VM get created. 3 to 1, 2 VMs can remove. So you change the number and your scaling will be happen accordingly. So with respect to the scale out or scale in, you want to trigger your policies. You want a schedule scaling, manual scaling, dynamic scaling. You can define the scaling that if my machine added, you can put into the percentage also, like 10%. So total machine, 10% should be added. You can also say that I need a change from 2 to 1. So exact number or exact capacity you can do. Everything you can perform via the scaling one. So now there's two more terms. That's called cool down period and warm up period. So let's say your CPU reached to 90%, machine will be added. After a few seconds, CPU reached to 20%, machine will be removed. Then again, CPU will be 90%, add a VM. So it means it will create a VM, remove the VM. This will not be possible. This will be not the good option. How we can avoid it? Anyone? What do you think will be the way to avoid it? Cool down period is nothing but a put the wait period, waiting time. So it say that when my first scaling trigger, this is my first scaling, it will say that next 5 minutes or 50 minutes, whatever you time you put, don't consider any other scaling. Don't consider anything else. It means if next 5 minutes your CPU reach to 90%, 20%, 90%, 20 minutes, it will just ignore it. It will just ignore it. And it will ensure that your machine will never be created or deleted for next 5 minutes. The cool down period means I don't want to consider any other trigger for certain period. That is called a cool down period, and you can avoid it. Got it? But there's one more thing that's called warm up period. Let's assume your VM creation will take almost 5 minutes. Remember it, approx. It means 90% happened. Your VM will launch. VM will not created but launch. If VM will be launched, what does it mean? So if user, so your CPU reached to 90%. At 001 hour, it will launch one VM. Can your performance will be immediately reduced, or user need to wait for 5 minutes? So remember it, everyone. Auto scaling does not mean that it will solve your performance issue immediately. No. That's why don't create a scaling policy at the later stage. Always start with the lower number. So start with the 70%, then 80% and 90%. Don't create at the 90%. And you assume that you created at the 90%, machine will take 5 minutes. User will see the performance till next 5 minutes and then machine get created. So remember it. Now, assume machine created will 1 minute, and assume, let's take another example. So your machine is taking 5 minutes, and then so 70% CPU hit. So you have a 1 VM. So 70% you need a 1 VM. 90% you need a 2 VM. Remember it. So you created a policy, add 1 VM and 2 VM. Currently you have 1 VM. So CPU reached to 70%, a machine creation will be hit. Okay. So, and forget the cool down period for a few minutes. Forget the cool down period for a few minutes. So 70% CPU hit, a machine creation will be start happening, which will take another few minutes, 5 minutes, 10 minutes, whatever. But again, CPU reached to 90%. Then how much machine it will create? 1 or 2. Eventually, how many VMs you will get at the end? Correct? Yes or no? Arey baba, initially 1, 70% 1, 20, 90% 2. So you eventually get 4 na. So this is not the ideal situation, because you know that you want at a 90%, I need 2. So warm up period will ensure that whenever a new machine get created, when the new scaling happen, it will consider that a machine which is already in the creation state to consider that number. It means the warm up period ensure that the total time it took to create a VM, and when the new scaling happen, it will say, oh, 1 VM is already creation state. So I need to create only 1. So your numbers becomes what? 1 and becomes 3. So this is an inbuilt feature which ensure that you never get unnecessary the additional machines and manage your performance and the cost. So two concepts: cool down period and warm up period, which is used for managing your resources one. Clear? Anyone have a question? My CPU is 90% over a 5 minute, then add the machine. This is what you're saying? This is exactly, you are right. Usually we go in this fashion only. Configuration is because it is usually if you go to the machine level, you see that you are hitting to the 90% above is too often. You don't go there. We say that if my average utilization, if my 70% utilization over the period of 5 minutes, so average 70% average utilization for 5 minutes, then add the VM. This is what you're saying, correct?
Yeah.
Yes, same thing. It is where you need to configure it accordingly. Is your wish how you want to configure, but yes, both is possible. So this is basically is a monitoring you need to configure into the monitoring that if CPU reach to if 70% utilization over the 5 minute, then only instruct the VM, instruct the auto scaling to create a 1 VM or 10 minute or 15 minute. It is up to you. You can do that, or you can also configure that if during the 5 minute, if 70% hit 5 times,
Okay.
trigger VM. So you have all the options. Got it? So from the scaling point of view, it maintains the health state. I told you terminate the instance which is unhealthy, and it check the instance health. And behind the load balancer, it can be used to check your load balancer instance check or EC2 instance check. Means if my instance is unhealthy, sometime we are using without load balancer, we can use EC2 instance check, or sometime we are using the load balancer. Load balancer, I told you load balancer also perform the health check. You can use either of it, and we can maintain the health check of the instance one. So this is what we talk about. And with respect to the termination policy, you can terminate the instance, and you can create your instance. You can perform your policy that which instance should be terminated. You can terminate the instance when the machine is in scale in, which machine should go first. So you have a multiple option that which machine should be goes first. You have a option like oldest instance, the instance which is created first, it will be terminated first, or the new instance which is created latest one will be terminated. Because when you reduce it, which instance should be terminated, you need to define the policy. Or you can also default create a that machine will be created which is completing their billing cycle. Let us assume so 2 machine is running, and out of this 2 machine, so VM1 is running, VM2 is running, and VM1 after 5, your billing cycle will start after 5 minutes. VM2 billing cycle will be start after 10 minutes. It means if this VM goes beyond 5 minutes, it will add 1 more hour. So AWS will automatically launch the VM which is nearest billing cycle to save your cost. So this is one aspect. So you can also delete the terminate the VM based on the billing cycle, or which is a launch initial one or the latest, or you can also based on the launch configuration. Assume initially you put the launch configuration which is launching your version 1. So you put a version 1 launch configuration later on. So you created a 2 VM with the version 1, and then you updated your configuration, launch configuration. You added some new, you change the type of the VM. Let's say that you are creating a machine with the T2 micro. Later on, you want to create with the T3 micro. So you create one more launch configuration, which is a version 2, where you put the T3 micro. So all the new machine now started creating with the T3. Okay, all good, no problem. But when it terminated, you say that first terminate the machine which is created with the older launch 1. So you can also terminate the machine based on the multiple aspect, old instance, new instance, which is launched with the older configuration, launch configuration, or which is coming your instance billing cycle. By default, it will automatically launch with the billing cycle. Default is billing cycle 1, and you can simply use it to create a machine and then manage your VM with respect to the VM1. So from the scaling aspect, schedule scaling at a specified day and time. Dynamic scaling, you can configure based on your specific based on the utilization, and you can configure single rule or multiple rules. Step scaling and simple scaling means only one step. You can just configure one step, like greater than 70% add a VM, or you can also configure multiple steps. That's called step scaling. Step scaling means CPU reach to 70%, add a VM, 90%, 2 VM, 40%, multiple steps means step scaling. And third option is your target tracking. In a target tracking, you say to AWS boss, I'm not creating any rule. What I want, my application should be always running with the 70% utilization. And your minimum number is 1, maximum number 10. You don't create a rule. Now AWS will automatically add a VM and reduce the VM to maintain your 70% utilization. Same concept, but another way. So if a machine 70% goes above, it will add a VM. 70% goes below, reduce the VM. So it will automatically add the VM and reduce the VM based on your percentage one you define, and you can create it. So you have a target tracking. You can just define the target. I want to maintain this target, and AWS will automatically add and launch the VM with respect to the dynamic scaling one. Now, all this scaling, the dynamic scaling is reactive scaling. Reactive means when CPU hit, then a VM launch. It means user will still see the performance issue when the CPU reach to 70% or 80%, 90%. There's one more type of the scaling, which is called predictive scaling, which is a what is the different of the reactive, and then what is more a different one? Reactive and proactive. Yeah, thank you. So predictive scaling is proactive. It is a machine learning based scaling, artificial intelligence based scaling. It will, you don't define anything. It will just look into the logs of your environment, and based on the logs, it will forecast when the load will be increased and add the VM before the load will be increased. So it's a proactive. So based on the log, it will see, okay, every Wednesday, the load increase at the 9 a.m. So before 9 a.m., it will add a VM. So it will be a predictive scaling. Based on your scaling, it will automatically launch your VM or terminate the VM and maintain your VM1. And you can define your scaling with respect to the predictive one, machine learning or AI based scaling, and you can use it. You can also use all these scaling in combination, no limitation. So you can use all the scaling in combination. So with respect to the scaling, you can scale out, launch the VM, add the instance to the group, scale in, remove the instance or terminate the instance from the group. So all scaling will happen, adding a VM and reducing a VM from your group one. You can also configure your period, like alarm one, CPU utilization is 90% for more than 5 minutes, then add a VM, or 10% more, add the VM. Suspend the scaling for next 5 minutes in terms of the cooldown period. Define the warm-up period, how much time you take the VM should be up and running, so that system will consider that your VM with respect to the auto scaling one. And this all we talk about with respect to the auto scaling aspect one. Auto scaling help you to manage your resources when the load increase or decrease, and you can define the limit. It never goes beyond 1 or 10. So, and you can define your auto schedule or dynamic schedule and manual scaling or predictive scaling. And usually auto scaling we use with a load balancer, but you might also use without a load balancer. It's not mandatory. If you have some application where you need to just perform a testing, we can use without a load balancer. But from the user perspective, you usually use the user will always hit to the load balancer, and then it distribute the traffic to the multiple VMs in the auto scaling one. And that's what we talk about from the auto scaling aspect, right? Anyone have a question? Please go ahead. So assume your CPU at 01, it reached to 90%. It add a VM. 03, it will reach to 20%. Before the VM get created, it terminate the VM, right? Then again a 5 minute, it reached to 90%. Before the machine terminated, it again started a VM creation. 7 minute, it terminate the VM. So what we can do, we can say that when I'm launching the VM, please suspend any trigger. Well, it means don't configure any scale, don't use any scaling, suspend all the scaling, ignore all the scaling for next 5 minutes. So next 5 minutes, it will just ignore any trigger. After the 5 minutes, After the 5 minute, then it will consider that, okay, CPU goes to 20%, then remove the instance or add the instance one. Clear? Cool down period. The warm-up period talks about that how much time you take. The VM should be ready. So when you create a VM, assume your VM will be launched at 01 minute, and it will take, let's say, 10 minutes for the VM should be ready. And after 10 minutes, it will add it to the group. It will take 10 minutes to launch and deploy the application. Assume you created a scaling that 70% add a one VM. So your one VM will be started. And cooldown period is 5 minutes. So next trigger will happen at 6 minutes. This is a 90%. It will create a 2 VM because 2 VM, you configure that 2 VM will be added. So it means my machine will take 10 minute time. The next, it means it in the second one, how many VM should be launched? In general, what it should be launched? What? 2 VM. But eventually, one VM is already there. 1 minute, you have launched one more VM. 2 VM will be launched. You become 4. But ideally, at the 90%, you configure the rule that one machine is already there. Add a 2 machine because you know that 3 machine is good enough. But here you created one more machine. You are paying something extra. So what is the instance warm-up period define that? That within the 10 minute, when your machine is creating, please consider it that is a part of you. So when it launch a 2 VM, it say, oh, one machine is still launching stage. Please consider that VM. So I just need to only launch one VM because one VM will launch. So one VM will be added automatically, and one VM I just need to add more. So becomes a 3. So what instance warm-up period is the time you took to build the machine, and it will consider that machine during the period. Yes, let's use this machine as a number instead of creating one more. Got it? So this is what we talk about. And the last topic is Route 53. Then we go for the lab. So Route 53 is your provide you 2 different services.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Route 53 provide 2 services. One, name resolution. Internal or external, whatever. It resolve your name, and it support 2 different kind of the DNS services: public DNS service or private DNS service. Public DNS service means when you want to configure for your public server name resolution. So assume you have a domain name abc.com. You create a DNS server, Route 53 DNS server. 53 is a, what is the 53? Anyone? Is a DNS port number. That's why service name is Route 53. So Route 53 you can configure as a public DNS one. You have a server, web server with the public IP 1.3.4. You create a record set in Route 53. So when user will hit, request will go to the domain name. Domain name send the request to the DNS server to resolve your IP web server. So user is accessing www.abc.com. DNS server will respond back your IP address to the user, which is a 1.2.3.4. Then your user will send the request directly to the web server, which is 1.2.3.4, and you are opening the web page 1. In simple word, we use the Route 53 for name resolution. Public name resolution is a paid service. Auto scaling is a free service. You need to only pay for the machine you created. Remember, auto scaling is a free service, but you need to only pay for the resources which you are creating, like machine 1. Route 53 is a paid service, and you have to pay for every resolution. Means every query, whenever user hit to the DNS for resolution, you need to pay for every query and fix charges for per month. So per month plus every query respond, you need to pay for it. So public DNS server, you can use it. You can also use for the internal name resolution. So if you have a VPC and you can map it with the VPC. VPC is your network, your AWS network. You map the Route 53 so that your server can resolve your name from this root 53 one. Here, when you use for internal name purpose, you use the private IP, not the public. Use the private IP for name resolution, not the public one. So root 53 support multiple things for internal name resolution, external name resolution. You can also buy the domain name from the root 53. You can also buy the domain name from the root 53. Means it is also supporting as a registrar. You can buy the domain name the way you're buying from the GoDaddy and so on. A part of it, root 53 also support your high availability. High availability across the region. Load balancer support within the region, except the gateway, but root 53 support across the region with some additional support mechanism. So when you, okay, so before that, with respect to DNS num, you can configure the DNS num. You can also integrate the DNS name. So when you're accessing the DNS name, your load balancer you're accessing with the AWS DNS name, which is web app, US West 2, so on. Instead of that, you want to create your own domain name. So create a own domain name with the your www.abc.com map with the web app. So you can access with your own domain name. So you can also do with respect to the DNS one also. So it is mainly used for the name resolution, whether you're using your web server or DNS or a load balancer or any services, so that you can access with your own domain name one. With respect to the root 53 provide you the your multiple routing option. It basically help you to provide the high availability across the region, even in the hybrid also. And it provides the various policies, which include your simple, weighted, latency, failover, geolocation, geoproximity, and multi-value routing policies. Let's understand one by one. So first of all, root 53 will support high availability across the region or hybrid also. It means, assume you have a load balancer in region 1 and load balancer into the region 2, and you want that your root 53 will fail over your traffic if one region goes down. So root 53 will check the health of the region 1, means load balancer. If load balancer goes down of the region 1, and root 53 is a global service, so no need to worry about from the regional aspect, global service. It will automatically fail over the traffic to the region 2. From the user aspect, he does not need to know whether the service running from region 1 and region 2, it will always hit to the region, he will access the application with the www.abc.com. On the back end, your application will be fail over across the region, or even on your on-premises also, or even all to the other cloud platform also. You can do everything. Root 53 is a public DNS service. You cannot use for the internal network. Public DNS service means you can only access with the DNS name. You cannot access with the IP address. It has to be use the name resolution 1. So root 53 support your multiple features. Root 53 name resolution and routing policies. And one of the routing policies, which I just explained, is called failover routing policy. Failover. It means if one region goes down, failover to the other region. A part of it, we have some additional policies, which we called latency-based policies or weighted-based policies 1. And one. So let's understand one by one. So failover policy. Let's understand the few more policies 1. So let's assume this is a root 53. You are accessing your with www.abc.com, and you have a multiple endpoint. So you have a region 1, region 2, and region 3. Region 3, you may have endpoint. Endpoint can be a single virtual machine or a load balancer with a 2 virtual machine, multiple machine, whatever. Endpoint can be anything. You can deploy a single server or load balancer, is up to you, no limitation, but it should be accessible over the internet. So assume you have a 3 endpoint in 3 different regions, and you want that whenever user is moving across the globe, and you want that whenever user will accessing my www.abc.com, the response will be always come from the nearest endpoint. So the latency will be low, response will be high. So assume user is near to the region 1, then AWS should respond the request from the region 1. If user is near to the region 2, the response will come from the region 2 and so on. This concept is called latency-based routing service. In a latency-based routing service, your Route 53 will check what is the latency between a user and all the endpoint, and which have the lowest latency request will be processed from there. This is called a latency-based routing service. Good option. It is checked by the Route 53 itself as a managed service. As a user, you don't need to do anything. AWS will know which all the endpoints, and it will check internally the response from each endpoint, and the request will be processed accordingly. Okay. So it is an inbuilt wherever the user is request coming from, because every IP address is based when user send the request, or request is coming from the IP address. Route 53 internally check the IP address and your endpoint IP address latency, and whichever the lowest one, response will come from the respective endpoint. Correct. Got it? The other option is weighted based routing policy. Weight. Now weight means I want all the traffic, 50% should go here, 30% should go here, 20% go here. So I can also distribute the weight. So weight means you can distribute the weight across the region. So from the weight point, if assume your this is the example of the blue-green deployment. But before that, anyone knows what is the blue-green deployment? Heard about the blue-green deployment? Is the application need weighted? We usually use into the blue-green deployment. Anyone heard about the blue-green deployment? Okay, look into this way. This is a web server. This is your www.abc.com. Okay, so user is accessing with the web server. Assume your web server is running with the code V1. You have to upgrade the code from V1 to V2. How you can do that? Anyone? Are your application is running with the V1, you need to upgrade the code to V2. How you can do that? What are the steps you need to follow? A simple task, Baba. Your web server is running with the V1 code. You need to upgrade the code. How you can upgrade the code into a virtual machine or server? Let's take a simple example. Stop the machine. Upgrade from V1 to V2. Start the machine. Yes or no? Correct. Simple. Like yes, na? But it will take some downtime, which is perfectly fine. Okay. Let us assume after the few hours, this code which you upgraded to the V2 have some bug. Some issues arise. Then what you need to do? Revert back. Again, stop the machine, change from V2 to V1 and start. User is unhappy. Organization is unhappy. They're saying you cannot do anything. Give me the better option. I don't want this much of downtime. Then what you can do? What is the other option?
Yeah.
Why don't we do one thing? We create a new VM with the V2 code. And instead of stopping my services, I can simply go in the DNS server. Can I point to the new server? Is it the simplest way? Yes or no? You may require just a few second downtime, not more than that. Okay, so if I just go here in a DNS, I can put a 5 minute or 5 second or 10-second downtime, 10 second, then my problem will be solved also. Correct? It is possible. So depends. I can configure the DNS configuration accordingly. Consider that caching is not an issue as of now, because you have defined the caching with the lowest number, right? Then this issue will be good. Yes or no? This problem will be solved automatically. Yes. Okay. So if this VM will create another issue, V2 will be a bug, then I can definitely, what we can do? So we can avoid a downtime. In simple word, all the load goes 100% here. Then this one is 0% load. Then I change to 0 to 100% here. Then if problem arise, I again change to 100% to 0% here. Problem solved. This is what we can achieve via the weighted routing policy. Weighted routing policy. So weighted routing policy, you can define the new environment, that's called green environment. You can also change the load with the percentage also. This concept is also called a canary deployment. Canary deployment. Same concept with the canary deployment. Anyone heard about the canary deployment? We also called canary deployment or AB deployment. Same concept. So if you see in this case, if your VD V2 is a new code, and if this goes down, all the user will be impacted. Yes or no? So can I do something like this one? I say, boss, only 5% traffic sent to the new machine. 95% goes to the older machine. If my user will be impacted, only 5% will be impacted, not the 95%. Yes or no? Good option. Another good option. So I don't want 100%. I say, let's start with the 5%. I can watch for next few days. If 5% is good, then I increase to the 10%, 20%, 30%, or 100% later on. So we can also achieve your deployment using the weighted. So weighted also support your percentage of the traffic you can send. That's called a canary deployment or greenfield deployment. This is usually used by the developers with the infrastructure guys. So they define, okay, my 5% loads go to the machine 1, 95% goes to the machine 2. Lots of time you have seen that when two users sitting next to each one, but when you are accessing, you are seeing different page and I'm seeing different page with the same URL. This is a concept of the weighted policy 1. So from the policy aspect, you have a failover policy, you have a latency based policy, you have a weighted policy. There's one more policy that's called simple policy. Simple policy means only one endpoint, simple configuration, nothing more than that. So put www.abc.com. It will always send the request to the one endpoint, and your user will single endpoint. If it goes down, everything goes down. No issues from the simple aspect 1. Another aspect is your geographic based routing policy. Geographic base. In a geographic base, what we do, we map the region with the specific country. So we say that all the India requests will be fulfilled from the region 1. All the Europe requests will be fulfilled from the region 2, and so on. It means any user who's accessing your within the India country boundary, request will be open from the hit to the R1 server, region 1 server, or anyone coming from Europe will be hit from the Europe R2 server. This is called geographic based routing. Geographic based routing is a service which you use lots of time. You say that when you're opening the website in India, it will open into the Indian language. When you're opening from the France, it will open to the French, or open from the Germany, it will open to the German language. Because of this same concept, that's called geographic based routing. There's one more routing that's called a geo latency. In a geography, you map the region. In a geo latency, you map the latitude and longitude, bigger region. So based on the latitude and longitude, you define that any region which is coming in this latitude and longitude, request will be full bit, which can be one city or multiple city, or one country or multiple country. So you can also define your geo proximity 1. And the last latency is multi-value. In a multi-value, it will just check, user will get all the response of all the healthy instances. So when user hit, it will receive the response from the region 1, region 2, region 3. All are healthy. So assume R3 is not healthy. So it will receive the response from R1 and R2. It will see both are healthy, and user will connect either of the machine. This is called your multi-value 1. So from the policy aspect, you can route your traffic across the region, even on on-premises also, based on the simple routing, weighted, latency, failover, geolocation, geo-proximity, and multi-value. And you provide the high availability across the region with respect to the routing 1. So load balancer within the region, but along with the route 53, you can distribute across the region and provide you high availability 1, right? Anyone have a question? Please go ahead. Okay, so the next lab which we are doing, what we are trying to do in this next lab, we are creating an auto scaling in AWS. This time, you are deploying one VPC. All the previous lab is clean up, right, everyone? Last lab you have clean up, right? Yes. Ensure that that previous lab is clean up. Don't keep it running. Unnecessary confusion. So we are deploying we're creating a cloud formation, creating a VPC, but this time we are creating a two subnet, one for public and private. What is the public and private? I'll talk about when we discuss the VPC, but just understand Here we are creating a load balancer and creating a EC2 auto scaling machine. And we're adding a machine and reducing the machine based on the scale out and scale in terms of the CloudWatch. So now when I want to deploy my image, my application into my EC2, when I launch a EC2 machine, I want that my image should be deployed. And I can use two options, user data or AMI. So what we are doing in this lab, we're creating a VM, Windows VM. We're installing our code. We are executing our script. This script is actually install your code. The code, which is a .NET code, what this code is doing basically, it will, when you open the web server, it will display the private IP of the machine. This web server, this code will display the private IP of the machine. Why? I'll explain you. So you're creating a machine and creating a machine with deploying the code so that when you access the web server, it will display the private IP of your VM. Okay, all good. Then we're creating a customized AMI from this machine, customized AMI. Now, what will happen? The minute I create any auto scaling group with this AMI, what will happen? What will happen? If I creating a scaling and a new machine will get created, all the machine have the same code, yes or no? It means if your load balancer send the request to this machine, what you see? Private IP address of this machine. If the load balancer send the request to this machine, it will see the private IP of this machine, yes or no? So you can differentiate. Oh, yes, my request is coming from the server 1, which is a different IP, server 2 is different IP. That's why you are deploying the code so that you can see, yes, my request is coming from the multiple endpoint. Clear? This point is clear? Okay. Now, to create a auto scaling, you are using the CloudWatch. We'll discuss the CloudWatch later on, but you're creating a policy that whenever CPU reach to 90% for 5 minutes or whatever, then add a VM. And then whenever CPU reach to 40% or for 5 minutes or whatever, reduce the VM. So you need to create a CloudWatch policy, and based on the CloudWatch rule, your machine will be added or reduced, and you are testing your scenario. Once you complete the lab, it will help you to understand how to configure the load balancer. It will also help you to know how to configure the customized AMI. It will also help you to configure your auto scaling group and policies and add the instance and reduce the instance in this lab 1. Clear? Anyone have a question before we start the lab? So what you did in the lab, what was the learning, what you have seen in the last lab aspect? So if you look, what are the things you have did? You have seen the how to use the load balancer with the auto scaling. So eventually you created a network, right? And where you have deploy your web server. So you put the web server here in the public side. Public network means where you can access over the internet. You install your code and you also create the image. So why we created the image? So that when we create an auto scaling group and the machine needs to be launched, I don't want to do that manual processing. I want that my machine get launched, my code will be deployed. So we created the image. Then we also deploy the load balancer. And you have seen that when you're deploying the load balancer, you selected the zone 1 and zone 2, correct? Right. Why we selected the zone 1 and zone 2? So for high availability purpose, you deployed across the zone. Then you created the scaling group. You put all the details under the launch configuration, which include this image also. So you select this image and your security group, key pair, and in case you want to add any role or whatever, you can also do that. Then eventually using this launch configuration, you created your VMs across the zone. So you selected that it should be deployed zone 1, zone 2, and you created the VMs. You define your minimum, maximum, and desired number. You can also integrated your servers with your load balancer, and when user hit to the load balancer, you can access your application. How you verify that actually load is going to the different machine? How you did that? And the purpose of the code to help you to understand that yes, my traffic is actually going across the VM, and that is the reason the code, which is a .NET code, will display the private IP address of the machine. So you can use it to identify easily, yes, my code is going across the machine, and also how you can deploy your code and your app onto the machine via the image. Then you also configure the CloudWatch rule. So you configure the CloudWatch rule where you can say that, okay, let us assume if traffic going to 70% and above, and then you created actually alarm. Alarm is the concept using which you can trigger the notification when something goes beyond a threshold. So you created a alarm for 70%, assume, and 40% or 30%, whatever. And same alarm you have used while creating the auto scaling group configuration, that when it goes beyond 70%, add a VM. When goes below 40% or whatever percentage, I don't remember, but you can remove one VM1. Then how to stress the load, because we are using the low end machine, is the lowest end machine, which is the one processor, 1 GB RAM. So usually utilization will be high, but if you can, but it is a free one, that's why we use it. But if you use the higher configuration machine, it will be much stable one. But from the lab aspect, how you can stress the load. So we use one VBS script which stress your CPU utilization to the 100%, and when CPU reach to 100%, a CloudWatch will trigger the alarm, and it will create the VM, and it will go up to the maximum number, because you are keep adding and adding, and the CPU reach to the maximum number, and you can test it. And and if you stop the stress load, it will reduce to the your normal one. So it will go back to the minimum number, or whatever the number you have, or desired number. So overall aspect, you have learned how to create a load balancer, customize image, and auto scaling group, and how you to use it in your application or infrastructure aspect one. Yes, everyone clear? Anyone have a question here? All good. So the next topic we are going to talk about is your container and some serverless compute. Before we start the container, what is a container? Anyone? What is a container? Have you used any container in your environment? Are you using any container environment in your AWS? Sorry, on-premises one? Or if I want to differentiate between a container and a virtual machine, what is the major difference between container and virtual machine? Look into this way. So this is a physical server. On the top of the physical server, you install your host operating system. Then top of it, you install your hypervisor. Hypervisor include host operating system, but I'm just differentiating it here. Then on top of it, you can install your VMs. Then on top of the VM, you can install your guest operating system. And then on top of it, you can install your binaries, libraries, code, whatever. This simple aspect from the virtual machine. Physical server, host operating system, hypervisor who's responsible for managing your virtual machine. Virtual machine have guest operating system. Then your you're installing binaries, libraries, and configuration file. Okay. Now, let's compare with the container one. So if you see here, the hypervisor which you are deploying, you may have a VMware, Hyper-V, KVM, Zen, and so on. Now let's go and compare with the container. Container, physical server. Container, host operating system. Now, hypervisor you use to manage your virtual machine. The container, which is also a virtual, let's assume this is a virtual machine, assume, but virtual machine, which is a container, assume, it needs to be managed by someone. So container needs to be managed by the layer, or like hypervisor you here, which is basically an orchestration layer. The container is managed by the orchestration layer, which we call a Docker. So hypervisor manage your virtual machine, Docker manage your container. Then on top of it, you create your containers. The container have everything, like you can assign the IP address. You can define your processor. You can define your memory. You can map your storage. You can do everything, but container does not have their own operating system. Then question comes, how you can execute the code? For executing the code, you require an operating system. Therefore, this container used host operating system, which will be shared to them when they need the operating system. A part of it, container have everything your machine have, virtual machine. Exactly same thing. It have a binaries, libraries, code, configuration. You can connect to the container. You can log in. You can do everything. No difference. One of the major differences that you can have a container which does not have an operating system, and if they use the host operating system for managing their execution of the code.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
That is one of the biggest difference which make your container very popular, because now I can execute the container, create a container which is very small in size. If VM, I have a 30 GB of the VM, where 20 GB I put into the OS and 10 GB into my application and code, I may create a container which is just in 10 GB in size. I don't need to worry about my 20 GB of the space with respect to the OS. Easy to manage, easy to maintain. Now, not only that, the best feature of the container that you can deploy the container to the physical machine, but you can also deploy the container on the top of the virtual machine, means you can virtualize to virtualize. In other words, I can install the Docker in this virtual machine. Then I can create a container on this virtual machine. It means I virtualize my virtual machine, and then I again virtualize I create another container which is the virtualized. To top of the virtual machine, I can create a container. The reason why the containers become so much famous, that you can use your existing virtual machine to create a multiple containers and manage your environment. Easy. So from the container point of view, is a runtime environment, which include your all the binaries, libraries, code, and configuration file. And you can execute, create, manage the way you are using any virtual machine. Because it does not have an operating system, it is much fast to start, stop, run, whatever. This is the major or basic difference in terms of the container versus a virtual machine. One. before we go to the next slide, anyone have a question here? Clear? First of all, you cannot do the RDP or SSH1 because SSH1. See, RDP is not there, but it is possible if you can install the GUI. So it is very much possible, but usually container, to keep the container small, we don't install these RDPs and one. You can connect the container via the SSH, which is via the interactive one, which is much easier, and connect to the DIT, and you can perform all the operation the way you're doing into the normal virtual machines. So you can connect interactively, and then you get the prompt, and you can execute all the commands the way you use for the Linux one. Usually container are not give the very great services for the Windows one. For Windows one, it does not give you the great services. I have never used for the container for the Windows one. It is much, because it supported the Windows, but eventually it is much difficult to manage it. It is very easy to manage from the Linux environment and very easy to connect, deploy, map, do lots of things from the Linux aspect one. But later on, it was after now, even in last few years, Docker started supporting the Windows environment. But again, this is a much more in terms of the configuration point. You need to install the Windows again, map the Linux environment, the Docker running onto the Linux environment, and you can use it. It's supported, but much more difficulty and complexity. But if you go to the Linux one, it is very easy to maintain, manage, connect, and you can do eventually everything from the container aspect. So you can use the Docker. So Docker will provide all this communication. So you can map the Docker with your, when you need to integrate. So you eventually integrate with your any authentication and authorization service, the way you add your container or virtual machine to your domain, and then you authenticate and authorize. And in this case, you need to look which are directory services supported by the Docker, and then you map the Docker. So eventually authentication and authorization will happen not to the VM directly, sorry, container directly. It will happen via the Docker. Eventually, all the communication connection will happen via the Docker, because Docker is responsible for everything. If you're talking about you're connecting to your container, but if you're talking about I want to log into the application which is running onto the container, then your application should directly map to any directory services which can be login. That is nothing related to the container one. So two aspects. If you're talking about authentication with respect to the container, who can log into my container, who cannot, that's a different aspect. If you're talking about if any application running onto the container and who can log into my application, that's a total different case. Second one is the way you're doing in any application, whether it's running onto the Linux, Windows, virtual machine, or whatever, exactly same way. But with respect to the container, that will be happened by the Docker. So this is a simple aspect. Right? Clear? Everyone got it? Done? Okay. Now, the next step is what happened? Container becomes so much famous, very famous. And when container becomes famous, everyone start looking for the container. They want their application should be containerized. Now, seeing this trend, all the bigger companies started offering their image as a containerized one, because the major difference, if I talk about the VM image and if I talk the container image, what is the major difference? No operating system. Na? So if you look from the VM, there's no operating system. Here, there's no operating system. Here is operating system. It means the images are very small in size. Now, one of the important aspects of the container one, that all the companies who started offering these images, they try to create the images as small as possible by not installing all the application and packages one. So they don't put all the things. They just give you the base image. And then you can add more layer or more application if you need it. So they try to create as small as possible the images one. So from the image aspect, all these companies started offering these images via the Docker Hub. Docker Hub is a repository where you can see all the major images are available. You go to the Docker Hub, You can select any images, and you can see all the official images are shared by anyone, and you can see the images there which you can use it for your environment purpose. So all the major application you can think of it, MySQL, Apache, Oracle, MS SQL are available in your hub one. Hub which support your Docker command. So it is compatible to the Docker command, and you to use your Docker command to upload and download the image. Now what happened here? So all the images are available where? Here in your Docker hub. So if I need to create a container, assume this is a virtual machine where my Docker is running, then I need to do what? First, pull the image. Image is pull. Then from the image, I need to create a container. Run the image, create a container. Then log in into the container. Install your app or code, whatever. And finally, your user can access it. Okay, all good. So assume I want to automate this one. I want my image should be downloaded. My application can be installed. And then my image should be created, which is something similar to your customized image. So I want to create a customized image. Then what we can do, we can create a Docker file. Put all the details the way you are doing it. For creating all the steps, we put all the details here. Pull the image, install the app, copy the code. You put all the details into the Docker file. When you execute the Docker file, it performs all the steps and eventually create your image. This image is like your customized image. Now, I can create a container from this image and my user can directly access it. Good option. So two ways of you can do it. Now assume you want that this is a customized image which is stored into this VM, and you want that in future also you want to create multiple container, or you want to create a container from the different images, different machines, and future you want. It means this image you need to store somewhere. Now this customized image you need to store somewhere so that you can use it to the future one. In AWS, when you create your images, your VM images, all the VM images stored into the S3 one object storage, and it supports your virtual machine command. Normal, I'm saying. Same way, the customized image of your container needs to be stored in your some repository, or repository we called, registry we called, or storage we called, where this image will be stored, and you can use the Docker command to perform the pull or push. You can pull the image, you can push the image, you can store the image, you can do everything. This repository should be compatible with the Docker one. Of course, you require the Docker command to execute, connect, and do whatever the things. This repository is your registry or container repository or registry, which you use to store your images and manage your images one. So from the creating a container, download the image, create a container, login, install application, automate it via Docker file, store your customized image to some repository where you can push it image and pull it later on to create your images later on, or future needs, or the way you want to store your customized image to create multiple container, you can do all the things one. This is the overall aspect what we need to talk about so far. Any question before we go to the next step? Right. So this is what we talk about it. So from the container point of view, This is what we discussed, and we have creating a container and managing it. So container, a method of operating system virtualization. So you can execute your container. You can assign your easy to manage, easy to create. You can create a version control. Developers can now create an image much easier. They can execute the container, deploy the container. All the things are basically, they talks about it. And whatever we discussed with respect to the difference between VM and Docker, you can see the same thing here also. So you see that if you're left side or right side, the major difference is container does not have their operating system, but virtual machine have the operating system. And on the operating system, you can also store the Docker to create your containerized environment one. Now, from the container aspect, now if assume I need scalability, I need high availability. So I want that, assume I have created the container, I have created the VM. In the VM, we call this VM is called a node. So this is nothing but a node. And I need to, in general way, you need to create a machine, install the Docker, then create a VM. Assume I want to create a web server, web container. Okay, I deploy the web container. But what will happen if your this Docker goes, this node goes down? It means you should deploy across the two different nodes for high availability. You can say that, okay, what will happen if my this container reach to 90%? Can I create a new container like a scaling? How I can do that? Assume my node reached to 90% and I want to create a new container. I don't have a sufficient storage resources. I want to create a new node. So I'm looking for more than a container. I want someone who can do and provide me high availability by managing my container in the cluster, provide me the scalability, provide me the availability, and so on. If assume this node goes down, there should be someone who can create a new node and create my container from there. If this container goes down, there should be someone who can create a new container like auto healing and auto scaling. This all feature needs to be supported by some software which manage your environment to the cluster. And this software is your ECS. Elastic Container Service support your cluster management. It provide all the aspect and make your life much easier. Cluster management, scheduling, creating a task. Task means you need to create your how to create my container one. You need to provide all the steps. Scaling, security, integrate with your container services. This is all I want. And for this one, we require the container who can provide me all this option one. And that is your ECS one. Elastic Container Service is your cluster management service, which is used to manage your container into your cluster environment. Easy to manage. ECS is AWS own service. A part of the ECS, there's a one more thing that's called a Kubernetes. You people have heard about the Kubernetes, lots of. Anyone knows what is a Kubernetes? And it's one of the famous cluster management tool, which is we are using on premises. In simple word, if you want to use Kubernetes, you can also use the AWS because AWS support the Kubernetes one. Remember, Kubernetes, ECS, both are cluster management services. But if you want to go to the AWS service like ECS, you can go for it. If you can also go to the Kubernetes, there's no limitation. Both are providing you almost same feature and functionalities. The usage may be a different one, but eventually you can use it. So because on premises, people are already using the Kubernetes, they have lots of people who's already certified like you. So they think that why don't I need to go to the ECS one? Why don't I go to the Kubernetes and make my same environment easy to migrate and manage? Yes, you can do that. Else you can go for the ECS one, But if you're talking about from the ECS service, from the AWS services, is the ECS one. And with respect to the Kubernetes, you can create a Kubernetes cluster. Kubernetes cluster include your master and nodes, master who can do all the scheduling and management of the nodes where your container is running. You can connect to the container service, run your app, with much ease of it. So on the on-premises, you're responsible for deploying your, creating a container machine, deploying your Kubernetes, managing it, scheduling it, lots of things you're doing. You don't need to do all the steps with respect to the container one in AWS, and you can easily use it. Now, in terms of storing your images, you can store the images to the Docker Hub, which is one of the, which is a free one. I'm not seeing much issues with some limitation. You can create the private container, you can store it, the Docker Hub. But because we're talking about the AWS also provide you one more service that's called ECR, Elastic Container Registry. Elastic Container Registry, which is compatible to the Docker, and it support your to store your images. Eventually, ECR use your object storage on the back end, and you can store your image. You can define who can access it. It will also provide a high availability by replicating it. You can integrate who can access it by putting access control. It is an encryption one, so it cannot be misused. It is a secure one. And not only AWS, you can also use for some third party. Means I want to use on-premises one, I can use Kubernetes services. As an individual service, you can use a Kubernetes services, and using a Kubernetes service, you can also use for the ECS, or you can use the ECR you can use with the ECS, ECR you can use with the Kubernetes, or you can also use some your on-premises one. No limitation, is up to you. You can use it. But one of the best option with respect to the ECR, that is tightly integrated with the Kubernetes and ECS one, so easy to manage from the AWS point of view. Yeah, go ahead, Ajay. So that's what we talk about from. Okay, so next thing we are talking about the Lambda. Okay, anyone, you have heard about it if you are working on AWS. If you are not from the development background, but people who are coming from the development background, they're using the Lambda very oftenly one. But Lambda says that there's a one concept. It is a serverless compute. Serverless compute. Now, when I'm saying the word serverless compute, what is the meaning of it? What do you mean by the serverless compute? Anyone? Are you meaning that executing the code without the server? Or what do you mean by the serverless compute?
Lambda use 7 or 8 language functions.
Yeah, which is fine, but what do you mean by the serverless compute?
We don't need any server to run it. Like the Lambda function will, as per the requirement, it will automatically take that CPU, etc. from its own. We do not need to manage that.
Correct. In simple word, you don't need to worry about the infrastructure. Infrastructure is provided by the AWS. Fine. So the serverless compute mainly means that as a customer, you are responsible for developing the code and managing the code. Of course, the deployment also. And whenever deploying the code, AWS provide me the environment where my code can be executed. It means based on my requirement, it will create a machine, assign the CPU and memory, and my code will be executed. But one of the best feature of the Lambda, that you need to actually pay based on your compute charges. And that is one of the best feature of the Lambda, that you can eventually pay based on the code execution. If your code executed for 2 minutes, you are eventually paying for 2 minutes. If code executed for 5 minutes, you can pay for 5 minutes plus whatever the memory you assign. But that first of all, when you don't need to worry about the infrastructure, will be taken care by the AWS. Not only that, you can actually pay not based on the infrastructure using, rather you're paying based on the compute charges. And not only that, the best part is you can execute your code based on the trigger. Like, assume I want that my all the VM should be stop at 6 p.m. So I want to schedule or trigger, what both is possible. I want all that dev machine, any machine which have a tag is equal to dev. I want to stop all the machine at 6 p.m. So I can create a Lambda. I can put my script. I schedule it. Every day, this Lambda will execute. When the Lambda execute, AWS will create the resources for them. When AWS create the resources, that resources will execute it and you stop the machine. Same way you can say that start at the 9 a.m. So stop and start. Eventually, you cannot think of any way. And you can create a Lambda, execute the Lambda and access your services. And the basic purpose of the Lambda, that it will provide you two major feature, that you can trigger the Lambda based on the, you can execute the Lambda based on the trigger, and you can pay for your compute time only. And Lambda supported the specific languages. It does not support all. It supports C#, Java, Python, and so on. And you can execute the code. Remember, you need to bring your own code. You are responsible for code development and deployment. You need to, and AWS will build the environment for you, your scaling, fault tolerance, availability, security, everything is provided by the AWS, and you can use based on the use one, pay per use, and manage your Lambda one. So you need to create a handler. Handler means you need to define your code, create a Lambda. Now again, you require the role. Okay, anyone, why we need why the role is here? Why role comes in?
Not have access to
correct, absolutely right. Yes, Lambda needs an access to another resource. Like I want to store some images to the S3 bucket. I want to stop the machine. So you need to give the Lambda role. Lambda need an access. So we require the role, upload the code, invoke the Lambda, and you monitor your resources, and it will execute your code one. Mainly, it is used by your developers. If you have a good knowledge of writing a script, your code, do that. Else connect to the developer, ask them to create lots of Lambda function based on the infrastructure need, and you use it. Nowadays, infrastructure team use lots of Lambda for lots of purposes. Like, let's take a simple example. My region 1 goes down, and I want that when my region goes down, a Lambda should execute to create a new environment into the region 2. But I want an automated way. So write a script. When your instance goes down, trigger the Lambda function. It will execute the code, environment can be created. You can do that. You just created the resources via the cloud formation. So you can execute it via the Lambda one. So it supports everything. Same thing which I just talked about it. You can schedule the Lambda to stop the instance at night and define your code, or you can start the instance at the morning. You can define the code and manage your resources one. So stopping the instance, starting the instance, you can do just a small usage, but eventually you can use the Lambda for much bigger role and manage environment in your environment. The only thing you need to remember that Lambda is give you two flexibility, that it will trigger, means it will create the environment based on my trigger. So no need to worry about it. And I just need to pay only when I compute, when I use the compute one. Rest of the time, it does not charge anything. Instead of creating your own machine, writing a code, putting the code in the machine, and keep paying for the machine for whole time, when you are not using it, it is much easier to move into the Lambda to save your cost by all this means one. And that's what we talk about from the Lambda aspect. The only limitation with the Lambda that your code should not go beyond a 15-minute. It means you should ensure that the code which you are executing, it should be completed within a 15-minute. If not, your code will be terminated. You don't get the desired result. So as a developer, you need to ensure that your code should be completed within a 15-minute. You need to write a code in such a way that it should be executed within a 15-minute. It should not go beyond a 15-minute one. If it's good beyond a 15-minute, then you need to create some additional workflows to use it. I'm not going into that detail, unnecessary. Is more from the development point of view, but it is possible that you can go beyond a 15-minute with the different ways by creating a workflows and serialization. Leave it that point, but just consider that 15 minutes is the maximum time your Lambda should be executed, else your code will be terminated one. So this is what we talk about the Lambda. Go ahead. Anyone have a question? You can trigger the Lambda function from CloudWatch, from the load balancer, from the auto scaling. You can do the queue services. Lots of services are integrated and you can trigger the Lambda. So now another thing is the API gateway. API gateway is also used by the developer to secure their backend services. If you look that you are exposing your backend services to the internet and you want to secure it, we use API gateway. API gateway also support the DDoS. So from the security point of view, it also supports the DDoS. Let's look into this way. So my user is accessing my storage. My storage like S3. My storage is triggering the Lambda. My Lambda is storing the image into the storage database, like say DynamoDB. But if you see here, all are exposed to the internet. I don't want. I want my backend services should be secure. To secure the backend services, we use API gateway. So we put one layer here that's called API gateway, which is used to secure your backend resources. The API gateway give you one URL. U means for your application. And this URL will eventually map to your Lambda or other function. The storage cannot know what is happening on the backend. It send the request to the URL, and this URL will hide your backend environment from the user point of view. If user want to try to see what is happening on the backend, he cannot see because it will just see the gateway URL. Not only that, if there's a DDoS attack happen, anyone know what is a DDoS attack?
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
What is DDoS attack? What happened in DDoS attack? You get millions of the requests and you reach to a stage that so it is completely occupied, consumed. CPU become 100%. Now, API gateway support your DDoS attack because what it do the limitation. So it will see that if lots of requests is coming, you can configure that only 500 requests per second should be processed. So what will do, it will only process the 500 requests. It means more than 500 requests cannot go beyond it, and it will safeguard your environment from the DDoS attack. So API gateway, again, it is mainly used by the developer to safeguard their backend resources, and the backend resources can be anything which you don't want to expose to the user from the internet point of view, which can be your servers, EC2, DynamoDB, Lambda, VPC, or whatever, and you can protect it from the backend expect one. There's one more service that's called a batch. AWS batch is used to execute your batch operation in where you want to execute your batch services. Batch services usually we use to perform our parallel operation. I want to create a parallel server. I want a big code, or I want to do the parallel processing where thousands of the server running the code, and then I get the output from the 1,000 servers, and then you get the result to the user one. Like usually we use into the data warehouse case or big data cases one. So AWS batch is a service using which you can perform the parallel operation by creating hundreds of the server. All can perform your operation into the parallel operation, and you can execute, manage your batch operation from the AWS point of view. You can create thousands of the server. Code, you need to write it. It's a fully managed service. You need to just write the code, execute the code. Code should support your parallelization, and you can create a code. The best option for the batch operation, you can use the spot instances one, because if you're running 100 machines, and out of which 1 or 2 machine can be terminated because of the 2-minute notice period, then eventually overall application does not impact. Good option for your parallelization with respect to the code one, and you can use the AWS batch for your execution one. So with respect to what we have discussed so far in this module, we talk about what is the concept of the Docker, ECS, Kubernetes, EKS, ECR. What is the basic concept of the Lambda and advantages and limitation, an API gateway, and your AWS batch one, right? Okay. So what we're doing in this next lab, image. AWS Cloud9 is a environment, IDE. IDE is integrated development environment, which is used by the developer to create the code. One of the options to create the Docker image, that you can create a Linux machine, install the Docker, and then create your image one. Instead of that one, we are using AWS Cloud9. Cloud9 is a tool which directly give me the Docker environment where I can directly execute the Docker command. So what we are doing it here, from the Docker Cloud9 environment, we are creating an image using the Docker file. The Docker file, we are doing very simple thing. We're creating pulling the image, installing the service, copying the code, and creating the image. From that image, we create the container. So we are doing a Docker file, we automating it, creating an image, and then we creating a container, and we are testing it. Okay, fine. Then we are storing the image to the ECR. The arrow is wrong. Actually, we're storing the image to the ECR one, not the Docker to the ECR. So the image you need to store into the ECR. Once you store the image into the ECR, then you are pulling the image from the ECR, and then you're creating our container into the ECS1. For creating a container, you need to create a task, and then your container will be created, and you're creating a services, and then your environment will be created one. Very simple aspect. You're creating a Docker image, container, storing the image into the ECR repository, creating the container from the using the ECS, and accessing your containerized image one. Right? Clear? Anyone have a question? Clear what we talk about? As of now, we are using AWS Cloud9. AWS Cloud9 use the AWS EC2 machine where it will deploy your Docker and everything. So Cloud9 use the EC2 machine where it can install the Docker commands and everything. So you are using the AWS EC2, in other word, but not directly via the Cloud9. Got it? Yes, yes. So actually, Cloud9 is a development environment which support your backend. Ultimately, the Docker and container needs to be run on the machine. So what happened when you create a Cloud9? Cloud9 will be deployed. It is a front-end tool which use one of the virtual machine to deploy your Docker. So on the back end, it install the Docker and lots of other tool on the virtual machine. So you are actually executing all the command on the Cloud9, but on the back end, this Cloud9 is actually running on the top of the VM. So you're using as a web service, as a browser tool, but on the back end, actually it use the AWS EC2 machine where all the information will be stored and deployed, and you're using the Cloud9. Got it?
Yeah.
Okay, so what we did in the last lab. The last lab, you actually created the image by using a Docker file. So what you did, you created a Docker file. You eventually download the image, install your Apache service, copy the code. Then it create the image. You tested that image by creating a container, which is a normal Docker container, which you use from the machine aspect. We deploy the container on the top of the EC2 instance, and you access via the EC2 instance. Then you push this image to the ECR, and from this ECR, you pull the image to the ECS, and you created the container, and you access the container one. Simple aspect. You created, if you look into the ECS and ECR, you look for it. So eventually from the image aspect, when you actually move into the AWS services, and you deploy the AWS services, and then use the ECR as a repository and ECS one. Now remember, all this job which is related to the creating an image is your responsibility, whether you are AWS or you're on premises, whatever. On premises, actually you're doing everything, but even AWS creating an image is your responsibility. Then you push it, then you can do whatever with respect to the creating a one image or multiple image. You can create your multiple container, or you can deploy the container across the multiple machines, node. You can do everything with respect to your container aspect one, right? Anyone have a question? Okay, so the next topic is VPC, networking. Multiple people who's part of this session may not be familiar with the network. Who are familiar with the network, all good. But who are not familiar with the network, and they're not using the AWS, your networking concept, who are more from the CBIL or database or management, you are fine with on-premises one, no issue with respect to the managing an on-premises. But it is not fine when you move into the AWS one. The AWS, when you're using, if you don't have a good understanding of the networking, means your VPC, which you have created into the last two modules via the cloud formation, if you don't understood, or you do have a good understanding with respect to the VPC, is much more difficult to manage your resources in AWS. Even if you have a database administrator, still you need to know it. Even if you have Linux or Windows administrator, still you need to know it. Even if you're a monitoring guy, probably yes, you need to know it. So who are not familiar with the VPC, virtual network or network, please remember it, that you cannot live in AWS without a networking concept. In other words, what I'm trying to say, that to become a good into the AWS, networking is mandatory. And when the networking is mandatory, you need to spend some time, probably within the session or after the session, to understand more from the networking point of view, so that you should be very clear that what is the network talks about, how the communication happen, how the connectivity happen. Considering the limited time and we need to complete multiple things, of course, we cannot go into the basics of it. But if you don't have any basics, my suggestion to spend some time. And still, if you're not understanding few points, probably try to discuss or do the Google, but ensure that your concept should be clear. When you go back and start your journey in AWS, And whenever you're stuck in some issues, your first step to resolve your issues is a network point of view. Even now, you have seen that whenever any issues comes and any bridge get open, your networking team is always comes in a picture. Whether it is a database problem or app problem or server problem, every time network comes in a picture. But when we move into the cloud, expectation that you are the one who know whole soul. You should know everything from the networking point of view or whatever. It is okay that you don't know the database, but it is not okay that you don't know the networking. It becomes a mandatory in different aspect. Now my question, what is why we need a networking? Simple word, you can, for communication, whether within the from one machine to another machine, a database to web server, a web to app server, your on-premises to AWS, your any point when communication comes in picture, you require the networking. With respect to the AWS, by default, AWS give you one VPC. And you have seen that whenever you go to any region and you open the VPC service, you by default, you get the default VPC. The purpose of the default VPC so that when you start the journey in AWS, you don't stuck. From the learning point of view, you to say, oh, what I can do? I cannot even create a machine also. So that's why they created a default VPC. But when you start the journey in AWS, usually we don't use the default VPC. We create our VPC and deploy our resources. Why? Multiple reasons behind it. Number one, why we need to create the VPC? And you may some ask, I already have a VPC. Why should I do all this so much of the configuration and then complexity? I don't want it. So from your network point of view, let's take a simple example. You need to deploy the N-tier architecture. Sometime the N-tier you also call a 3-tier architecture or 2-tier architecture. Anyone knows about it? Absolutely right. The tier means your functionalities. Let's take an example. Your management asks you to deploy the 3-tier architecture or deploy the web app and DB. So they ask you, go ahead and deploy the web server or multiple web server or app server or multiple app server or database or multiple database. Fine. And they want that you should deploy these services in a separate layer so that you can segregate the traffic. They also want that you can secure your traffic. Communication should be secure. So what you did, you created a layer, network layer, not the function application layer, network layer, one for web, where you have one web server or multiple web server. You have app, one web app server or multiple app server, DB, one DB or multiple DB. You also want that I want to deploy 100 web servers. I want to deploy 50 app servers. Sorry, let's say reverse of it. 50 app servers and 100 web servers or 20 database. You also want that my app server can be only accessed by the web server. You want my DB server can be only accessed by the app servers. You want that your network, this is your network which you created. You want that your network should be used your IP address, whatever the IP address you want, you should define. So you need to use your own IP address. You might want to connect your on-premises network to your AWS so the traffic between on-premises and AWS can be flow. Now, these are all needed that you should define and design your own network. The minute you need to deploy your application and then deploy your according to your requirement, it means my default VPC will not be usable. I need to create my own network. So I should know how I can differentiate the between web server and app server and DB server. I want my web server can only access over the internet, but not rest of it. App and DB cannot be accessible. I want how much IPs I want into the function layer of web, app, and DB. Which IP address I want to use for my network. How I can connect my on-premises to the AWS. What are the different ways I need to connect. How the communication happened. These all need to use the service which is known as a VPC to create an AWS one. VPC is your virtual private cloud. Private cloud does not mean the private cloud. Remember it. It is still in a public cloud, but you are securing your resources as per your need. VPC is a virtual network service which you use to create your network components, where you can eventually deploy your web, app, and DB instances, and you can perform all the job. You may have a multiple network. Probably you want that you have a network in region 1 and network in region 2. Network in region 1 is primary, network in region 2 is secondary. How the traffic should communicate? You require a VPC. You want to connect your on-premises network to the AWS. You require a VPC. So eventually, the VPC is the need to create your network one, and you require the VPC to create your network in AWS. Now, few things you need to understand. From the AWS point of view, VPC is a virtual private cloud. But eventually, VPC give you the logical IP range which you used for creating your which you used to define how much IPs you needed in your network one. VPCs give you the logical IP range which tells you what is how many numbers of IPs you get in your network. So assume I want to create a VPC or network with 1,000 IPs. Let's say 1,024 IPs. Then VPC give you the number of 1,000 IP range as part of the network. In simple word, VPC is the boundary of your network. But when you write a boundary, you can just put the number 1024. You need to put into the IP address range. So we tell VPC how much IP we needed. So let us assume I need 256 IPs. And I need, I'm using 192.168.0.0 IP range. Now, what will be my last IP? In any block of the range, but 254 give you how much? 254 plus 0, it give you 255, right? What is the maximum block of the IP range? 250, 256, nah?
Yeah.
So what is the last IP should be? So 255 starting from 0 give you 256. Correct? Okay. So now 0, I start from 190.168.0.0 and with the 0.255, it give me 256 IPs. Absolutely fine. Now, assume I need a 512 IPs. Then what I need to do? What will be the next block of IP range?
0.
So assume, let's say that I need a network of 512 IPs. So I created the 2 block of IPs. And if someone still don't understood why we put into the 0.255, 1.0 and 1.255, spend some time into the Google. It will be much clearer, but this is a simple way of writing it. You need to write the block, add the 3rd octet, then 4th octet accordingly. But let's understand, we are not going to too much of the basics one. So VPC gives you what? Logical IP range. But logical IP range will just give you the boundary. So my network boundary is 512 IPs. But what I can do with the network boundary, because in a logical range, I cannot deploy many resources. That's why your VPC should be divided into the multiple segment. So the VPC, we divide into the multiple segment. You can say that multiple segment, multiple chunk, logical divisioning of your IP range of the VPC, whatever you called. So what we do, we divide the VPC into the multiple segment and assume segment 1 will contain 0.0 to 0.255 and segment 2 contains 1.0 to 1.255. IP should not be overlap. And I divided into the multiple segment, absolutely fine, all good, no issues. So this goes here, this goes here. Every segment which you are creating needs to be attached to one of the zone. So segment 1, I attach with the availability zone 1. Segment 2, I attach with the availability zone 2. And this segment we called subnet. Subnet 1 and subnet 2. So the VPC is a logical IP address range which give you the total network, a total boundary of your network, which needs to be divided logically into the multiple segment. That's called subnet. And that segment needs to be attached to the one of the zone. Zone 1, zone 2. Now, when you deploy your server in subnet 1, eventually it will take one of the IP address of your subnet, maybe 0.200. And eventually this machine will be deployed into the which zone? Zone 1. Because this subnet is attached to the zone 1. That is the reason when we're saying that deploy your machine across the zone, you cannot see the zone and directly deploy into the zone 1. Rather, you're deploying the machine in the subnet and you deploy into the public subnet 1, public subnet 2, whatever. Because that subnet will be eventually mapped to the zone. So when you create a subnet, it will attach to the zone. And when you deploy the machine, your machine will get one of the IP address of that block of the IP which you map to the subnet and deploy into the zone 1 or zone 2. Remember, VPC is a regional service, but it can span across the zone. It means if you have 1 zone, 2 zone, 3, 4, 5, 6, single VPC can accommodate all the zone 1. So VPC, logical range. Divided logically into the multiple segment to ensure that IP should not be overlap. And every subnet should be attached to the zone. So when you deploy the resource, any resource, it will be eventually deployed to the respective zone because your subnet is attached to it. A subnet can be only attached to your one zone at a time. It means 0.0 to 0.255 cannot be attached to the 2 zones at a time. No, it is not possible, only 1. So it is a one-to-one mapping, but a zone can contain multiple subnet, of course, because in a zone 1, I have 1 subnet for public, 1 for app subnet, or 1 for DB subnet. A zone contain multiple one, but subnet can be attached to the 1 zone, and you deploy the resource, select the subnet, select the VPC, and your resources will be eventually deployed in that subnet or your zone 1. Clear? Anyone have a question? Please go ahead. If you understood this concept, all the VPC concept will be much more clear. You will not face much issues. But go ahead with your question. With respect to the IP address range which you used, AWS says that you need to use the IPs which is defined under the RFC 1918. RFC 1918 is a document which talks about which all IPs are non-routable, which you can use with your internal network, which cannot be clashed with another network, because public IP is unique. You cannot, two-person cannot use the same public IP one, but private IP is non-routable. That's why you can use the private IP in your own network one. And as per the RFC in 1918, you can use the IP which include your 10.x.x, 120.16.x.x2, 172.31.x.x, 192.168.x.x. Wherever you're seeing X, that X can vary from 0 to 255. So you eventually get a millions of IPs. But with respect to the AWS support that you can use these three ranges. And because these ranges are private, non-routable one, and it is a free. VPC is a free service, except the few components which is a chargeable, but by default, creating a VPC, creating a subnet is a free service, no chargeable, and this IP range is also free. You don't need to pay anything with respect to the VPC one. Yeah, go ahead, Arvind.
Oh,
So this is what we talk about. VPC, regional service, span across the zone, tells you, give you the number of the IPs, which you break into the multiple segment called subnet, attached to the respective zone. And when you deploy your resources, it will get into the respective zone because you deploy into the subnet attached to the zone, and that's why you get it. That's what we talk about with respect to the VPC one, right? With this one, we are good to close the session. Before we go, anyone have a question with respect to the VPC? And if you still do not understand the why we use the 0.0 to 0.255, spend some time, it will be clear. And in case still any question, please go ahead before we close the session for the day. Yeah. Thanks everyone. Have a great day ahead. Bye.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.